I did not make the best choices, but that's okay. We got here. We made it.
We did, and that's why we're here to apologize in part for
Yeah.
all of the bad choices.
Yeah. I mean, they.
Communication, anything you say, anything you do is public, and we need to start treating it that way so we together can make cyberspace a safe place to live,
Yeah.
work, and raise a family.
They were definitely good choices in the moment. But
I
that
regret
moment
nothing.
was probably fueled by a lot of clouded by a lot of blurriness. But we're delighted to have you all back today. I see the room is filling up. I do often joke that no matter.
One side note here: anytime I see a big red thing that says "warning" and then "do not," do something, I always pay special attention to that. I like to do things.
Summercon on day 2.
And anyway, who counts? So,
Bad things will happen. At some point, I'm going to go look exactly into what that bad stuff is and.
To give away a bunch of merch, that's for sure. And we need to thank people because yesterday our thank yous got abbreviated because of time.
we were too excited. We said too many words.
Yeah. I should be a lot higher energy right now. I don't know what's wrong with me.
We could do, for every time Mark takes a long pause, he has to do 8 squats.
I don't think I can do it.
That's when you all yell, squats.
Oh, God. No.
Mark
My
is
knee-
grateful
my-
that Emily's not in charge.
Yeah, my knees are shot to hell anyway. So yikes. All right. Well, with that, I see that we have the very first person to heckle me from the audience. Why does this keep doing this? Is there a?
It's tired, Mark.
Yeah, like
it drank
me.
too much at Canal Bar.
Yeah. I mean, is there a tech issue that we need to resolve with the SDI to HDMI deal here? Is there something going on? Okay, you got it. It just keeps blanking out every few seconds. I don't know. Just watch for it. You are wearing an amazing tuxedo jacket, Hiram. I really need to start thinking about sequins for the future. Are you coming up here to take a look at the tech? Yeah, I am. Yeah, I want to see. I want people to see
You have to
this.
twirl for us, though, Hiram.
Yeah, look at this. Look at this. Okay, now it's okay.
Now that
because
he
you're
touched
here.
it,
Yeah, thanks.
it's magic.
Thanks. Yeah, that's how technical support works. I swear to
He didn't
God,
even
it was
have to
doing
turn it on and off again.
Yeah, exactly. So, Steve, there you
Steve.
are, and Paul, you guys have been wrangling the volunteer staff. Making that happen. We're really, really grateful to you for making that happen. We're grateful to you and the volunteers. Summercon is an all-volunteer organization. As we said yesterday, none of us get paid.
Except for me, who's
You-
getting a 2 billion% raise.
Yes, yes.
Yes.
0 times any number.
You know I'm bad at math, Mark.
Yes, yes. Let's go shopping. Barbara and Jimbo, take a bow. They are our, we call them the Summercon janitors. They're cleaning up all of our messes. Thank you for that, guys. You guys are terrific. Oh, look, it's doing it now. Hiram. Yeah, you can't hide now.
We could get ready for the movie tonight and just do our slides completely from memory. Entirely from memory.
Entirely.
Completely from
It's
memory.
entirely from memory.
Oh, the actors are gonna get mad.
And they already did. They got really mad about some post that we made that said completely from memory, not entirely from memory. Anyway, tonight is entirely from memory, The Matrix, and we hope to see you all at it. It's going to be
In costume for
amazingly
giveaways.
great. Yeah, we do have prizes for costumes. So I was going to dress as Bullet Time. I think that's going to be my costume, yeah.
See, work your core, work your core. We're doing this. Talk faster and you can avoid it.
Tracy did a ton of work with you, Emily, on outreach to sponsors and bringing in a ton of bread for Summercon. We're grateful to her for that.
Thank Tracy, buy her a drink
Yeah,
for all of her hard work.
absolutely. Aaron, who headed up our speaker selection committee and ran the speaker Thunderdome to determine which speakers we're going to get to see the. Look at me glaring at Hiram right now. See this? And Ian, who did a bunch of different things, but on both the speaker selection and on the sponsorship-related side of the biz. So we're grateful to all three of them. In a moment of self-congratulations, I would like to thank the Summercon Board of Directors, of which I am the chairman. So thanks to me. Emily is also a director. But yeah, the Board of Directors oversee and make sure that we don't lose sight of our mission.
If you don't like it, it's our fault.
That is true. Dawn is also a member of the board of directors. She is essentially producing the entire event. So if you see Dawn around, you have to thank her.
Woo! Go Dawn!
It is said that the worst job is to be my assistant, but I think the real worst job out there is to be Dawn's assistant, and that's Tony. So thank you, Tony.
Thank you, Tony.
For dealing with all of that. And then, of course, Julie and Ola and Jesus, and doing this from memory now, the entire Littlefield staff.
You guys rock.
Yeah, you guys really are amazing. And then over at Ornate, Tone, Christine, Jean, everybody over at Ornate, you guys have been doing a great job over there. We really appreciate everything. If you haven't been over to Ornate, you really should go there. It's pretty amazing.
Has anyone not been over to Ornate? Because we will shame you. It's awesome.
It is awesome over there. It's a really big step change for us to have that space to spread out into and to make this thing, work. Our friends at Lucky 13, who had a blowout party last night, which was, crazy. And
it was like Battle of the Bands on Sackett Street.
That's what I heard. It was Battle of the Bands. Alex has been doing some video stuff. There he is. I see you. And Mark over there, good Mark, I call him. Other Mark, yeah, no, he's the good Mark.
Well, and speaking of Alex, we are working to put together some footage for our 40th. So if you feel so bold as to share with Alex what you love about Summercon and what brings you here.
Or what you hate about it and why you hate
Yeah, we'll
Mark.
totally not just edit all that out.
Please. And of course, Hiram, we're here to thank you. And
I think we should
the
nix
entire
that
team
until
of
he
the Video
fixes.
Village from Counter Collective, we love you guys. And you've been doing this with us since what, like 2012? Something like that? Yeah, so they're practically family at this point.
Practically family.
Yeah. But really, it's you. Thanks to all of you. You should give all yourselves a round of applause for making it out here, getting here at the crack of 11. Thank you. All right. That's all I have to talk about. Oh, no, we should get out some merch. Yeah, I did want to also show one thing real quick. If you have not seen it, yeah, so this is, I think, the least expensive thing in the merch store. It is $15 because this is a very special moment in human history where New York is very, very proud of a thing that happened that involved some kind of ball of Ethernet cables or something. I forget exactly how it works. Anyway, this is this is the one thing that I'm going to give one away now. Just gonna throw it into the middle of the crowd, and you can just, I see somebody really trying to get it. But they are $15. We are making no money on these, so if you want to tip your merch seller, that's also acceptable. But yeah, this one I'm really happy with. So here we go.
Oh, stick to computers. Ooh, Fight scurvyawareness.org. Lockpick Extreme, our good pals over there. I think we should. Who already has a headache?
Okay, Cal. You can figure out how to distribute that.
Ooh.
Now, just
I am going to throw it, but it's going to be underhand because I'm a girl, and that was really sexist. All right. Yeah.
okay, there you go. Nice. The last thing that I have to give away, last night we had a Flipper Zero to give away to an attendee at the
Music
show with Ask Your Mom.
Who were excellent.
Yeah, they were great. So in order to get this, you have to tell us what was the last song they played last night.
You can hum it too, like that counts. Wow.
I'm going to keep this Flippers. Do you remember what the song was? Mr. Brightside. It was Mr. Brightside. Look at that guy.
And there is more to come on that, so hopefully you all are planning your costumes for later. And if you're not, get on it.
Yes. More merch to be given today. Looking forward to the induction ceremony with Charlie Miller a little later as well. Hope you get to hang out for that. That'll be fun. I don't know, let's get Matthias up here.
Yeah, I think it's time to actually hear someone other than Mark talk. Yes. Let's give Matthias a round of applause. Matthias joins us from iVerify. He's been doing iOS exploitation and research since about, what, a decade? Yep. He's an iOS nerd, and he's here to talk to us about not the good old days when you could just use a buffer overflow and get shellcode through WebKit, but those days are gone. So he's going to cover how to circumvent all the mitigations that were put in place to make that harder for us. Awesome. Thanks, Matthias.
Thank you, Emily. All right, thank you very much for having me. I hope you're all well rested. You're got a couple of coffees. I definitely got a couple too much this morning. Yeah, actually I'm going to talk about Darksort, which is an iOS 18.4 to 18.6.2 exploit chain, and we're just going to take a look at the WebKit part of this. This is work that was just not done by me. It was a lot of this was done by my colleague Mateusz, who is on a well-deserved vacation in Poland. So unfortunately, he's not going to be here today. But if you get the chance to talk with him about this, I highly recommend it. And it's not just me, it's the entire Verify team that took a lot of time in the early beginnings of the year to work on this. And I have my colleagues Sarah and Kevin, who are sitting on the front left, who also did some work on this. So it's a large team effort. Well, let's get into it. Today we're going to talk a little bit about how we were finding Darksort, what's the overview of the chain. We're going to dive deep into web content code execution, especially about some of the mitigations that need to be bypassed to take this from an arbitrary read and write to get actually code execution. And we will close with some conclusions. Yeah, how did we find Darksort? And it all started basically on the same day that we already were able to publish some research about Karuna. We had some friendly researchers from another security company that is called Lookout, and they did some pivot on some of the Karuna infrastructure, and they stumbled across a link that they sent to us, which is exactly this one. And when you started to take a look at this, we were like, it can't be that easy, right? Yeah, and yes, indeed, we started to take a look at this, and what you can see here on the screen, there's not just one very obvious part here, there's actually a couple of them. And you actually also get lots of very, very nice debug log messages that are sent to the server that are telling you exactly where the chain is, what went right, what went wrong, and where it goes to. You can't see this here, but at the very end of this chain, we're going to be looking at about 120 debug log messages. There is a sandbox escape 1, there's a sandbox escape 2, and then there's a privilege escalation, and it's done. It's very, very nicely, and you could actually just copy the entire chain by just looking it up in Burp Suite, reading the JavaScript code, and just dump it step by step by step by step. You don't even need an iPhone for that. If we're taking a look at the exploit chain itself, we have multiple vulnerabilities, multiple different components here. We have the first part, which is the web content web content arbitrary read and write, with 2 different vulnerabilities. One for 16.4 to 18. One for 18.4, and then the other one from 18.6 to like going forward. Then we have a web content GPU sandbox escape. That's the first one. And then we have 2 kernel vulnerabilities that allow us to get code execution inside of media playback D and basically write arbitrary physical memory. Yeah, this is the first one that was fixed in 18.6. This was already done before any of the chains were like publicly discovered. It was credited to a couple of Chinese researchers. I don't know them personally. The second one is already credited to Google Threat Analysis Group, and this was fixed in iOS 26.2 in December last year. And it was also backported to 18.7.3. The interesting part here is when Google reported these chains to Apple, I would say roughly in the end of November, December timeframe, a lot of the devices were already vulnerable to this. So when we first learned about the chain and when we discovered this, we're talking about March, a couple of months later. So at this point in time, there were already multiple different threat actors that were exploiting this over a large set of devices. But the only thing that was like covered in media was the 3.55% of devices which were vulnerable at the point in time that we discovered it. But at the originally exploited time, we're talking about 0 days that were potentially vulnerable against billions of devices. This is then the TPRO or pack bypass that we're going to talk about. It was fixed in 26.3. This is the only vulnerability that was not backported to iOS 18. Even though Apple claimed they did backport it, but they never did. They just opened up some of the patches for like older devices, but this one was never fixed. The other 2 kernel vulnerabilities that were credited to just the Apple SEER team were actually patched in November. This is roughly around the time frame when Google also discovered this. The same one here, and then it was backported. I don't know why Apple never gave any credit to Google at this point in time. That is, no. And also, I also don't understand why these vulnerabilities never gotten like a designation that they have been exploited in the wild, because they had. Another thing that I don't really understand at this point in time, why Apple never backported these patches to iOS 17 or iOS 16, because some of these vulnerabilities and the kernel bug are exploited by jailbreakers even down to iOS 14 and 15. They did that with the Corona exploits after they became public, but they never did it for the dark-sort ones, which means it's great they patched all the kernel exploits for Corona, but now people can just use the dark-sort ones. I don't understand the inconsistencies there, but it's Apple's patch policy, and they will know best what they claim and what they want to do here. Good. This is the last part of the kernel bugs. This is the one that actually lets us access physical memory. The other one bug here allows us to turn any arbitrary memory into shared memory. That means we can also write to it, which is pretty nice. This is used after for like code injection. Good. Now, before we can talk about how they're bypassing some mitigations, we need to actually introduce some of the mitigations first. In older times or in other desktop operating systems, if you're getting code execution or you're trying to get code execution in a web browser, it's pretty easy. You get some sort of read and write primitive. You have JITted memory. You actually write your shell code into the JITted page, and then you start to execute this. This is not possible on iOS because Apple started to introduce a couple of mitigations to make this harder over the last years. We're calling these XPRR, but the real names would be APRR, which is a kernel interface, and SPRR, which is the user space interface here for Unpack. Then we have trusted path read-only, and we have pointer authentication codes and JIT cache. Let's talk about SPRR. The idea behind SPRR is basically that you allow per CPU core to toggle between if memory is readable, writable, or executable, which also allows you, if you have a JIT page, that you will lock this down to one CPU core that can now write to this page and add the JITted part, but all the other CPU cores are going to see this memory still as read-only or just executable. This means that if an attacker is able to write to it, they might be able to change some part of the JITted code, but they're not able to execute it at the same point in time. It's in a first evolution of bulletproof JIT that was introduced in APRR, and it's a hardware feature that is baked into the memory. It's the same primitive that is protecting some parts like PPL or later on SPTM in like the kernel part of iOS, but this was now introduced to user space. This works by having a couple of functions that can be called. This is the older interface, where you can see there is like a thread self-restrict from RWX to RX, and then the same from RWX to read-write. And also the other function is going to be just to check if it's supported, and you will always see that there is these assembly instructions here, the MSR, with these specific registers here to spot these specific parts in code. This is a newer interface that is used in WebKit now, and it basically uses the same functionalities that we have some thread self-restricting function to get into it and get out of it again. Now, it's not just that WebKit has the JIT part that is interesting here, but there's also a second part which is non-JIT code execution that could be a problem. And so Apple also thought like we need to protect our dynamic linker a little bit more, and this is trusted path read only. The idea behind this is pretty much the same as SPRR. If the dynamic linker need to do some changes on some very sensitive memory regions, like data const segments, like interposing tuples, or like just the internal runtime state, it also wants to make sure that the same principles I can use in the kernel or inside the JIT space, I can also use for these parts as well. So I once again have a per CPU toggle where I can say like there is one thread that is able, or like one CPU core that is able to read and write to these parts, and then they do all the changes, and then afterwards they resolve it back to read only. What is very important here is that this trusted path is very fast, but there is no locking in between. If I would have in a thread that is running on the trusted path any sort of locking, that means I could keep these memory pages in a like read-write state, and some other thread could now start making modifications to it because it's based on the same CPU core. This is a feature that was introduced in iOS 18, which is also why we're not going to see some part of these mitigations or bypasses in like earlier versions in Corona. It's like a first thing that attackers had to bypass here. As before, we can see the same registers here that are also used. So it's also, once again, the same kind of hardware feature that is used in the CPU. And we can also see that it's the same like principle. That's a function inside of DILT that is in the first part, first checking if the memory pages are already writable. If that's the case, they just do the work. And if not, you can see that there's a quick part here where we actually change it to read-write, we do the work, and then we change it back to read-only. All of these functions should be also inlined to make sure that there is no way that someone can just call a function if they have a pack bypass to make it read-writable, then they do what they want and then change it back to read-only. This should be like one trusted path, which is like one call that is basically going through. The last mitigation we need to talk about is pointer authentication codes, which has been talked about quite some often. The basic idea is that we want to protect return pointers, jump pointers, or other pointers on the system with a cryptographic signature. And all of these different pointers are basically signed with 5 specific keys that are available on the system and a context. The idea behind the context is that you can sign a pointer that is coming from a specific function. Let's say I'm having function A, and I'm calling function B. Then if I have a specific context inside of function A, and I'm signing the pointer to function B with this, even if I might be leaking that pointer to function B, I can only use this pointer from function A. That means if an attacker is getting code execution, is leaking pointers, so on and so forth, they need to be able to call this specific pointer from function A. Because this is not always going to be feasible, and a context is not always a thing that I can use, because, I mean, the runtime is very dynamic, I also have something that is called a zero-diversified pointer. In those cases, I just don't have a context, and if I have this specific pointer that is zero-diversified, I could call it from arbitrary functions, as long as I have an ARM instruction that allows me to call pointers with a zero-diversified context. If we're looking at DLSym, which is allowing us to resolve symbols and sign basically pointers to it, DLSym will always return us a zero-diversified pointer. Okay. The last mitigation we need to talk about is JIT cache. This was basically done to reduce the kind of capabilities that an attacker would be able to get if they're able to run shellcode inside of the JIT region. Where Apple said that it's only a certain set of ARM instructions that should be allowed to execute. There's only a certain set of APIs that are there. There is dedicated pack pointers that are just valid for the JIT region to also make sure that you cannot just easily build yourself a pack signing oracle, because these keys are then not available in that specific part. So you can see here there's a JIT cache IB key, which is then used for all the pack pointers inside of the JIT cache. Now, if an attacker gets into a state where they have arbitrary read and write inside of WebKit, they can basically decide to go two different routes if they want to get to code execution. They can try to target SPRR and JIT cache as mitigations to get code execution inside of the JIT part, or they can decide they want to bypass TPRO and pack in order to get code execution outside of JIT. In earlier times, people were always trying to target the JIT part. The attackers for Darksword decided that they want to go and bypass TPRO and pack. So what we want to do and what we want to achieve here is basically being able to call arbitrary functions in WebKit or WebGPU, in WebKit in order to launch our next stage of the attack, which would be a sandbox escape into the WebGPU process or some of the other associated processes, or even launch an LPE if you have a kernel attack surface that is immediately visible. We don't need to be able to call arbitrary shellcode. It's just enough if we have an arbitrary function call with whatever is available inside of the WebKit context. So the strategy that the attackers try to do here is the first thing that we need to find is a zero-diversified function pointer that allows with a BLR AAZ from a writable memory construction that allows us to call this first function. Then we want to construct a job chain that allows us to bring us from one function call with one parameter into that we can have an arbitrary function call with 3 parameters and 6 parameters. If we have a function call with 3 parameters, we can call a function like DLSym and get as a result back a assigned pointer, so we can also call other functions. If we have a function call with 6 parameters, we can run and create our own thread, and then we can also define the context, and after this we basically have arbitrary code execution, even native one. So in order to do this, we need to find the first function that allows us to do the function call with 1 parameter, then go to 3, then go to 6. We need to be able to call DLSym, and we need to be able to then sign pointers with arbitrary keys, with available keys in arbitrary context, and then run the threads. Now, the first part that they used for the job chain trigger is a function that is called DDFA scanner first result in unichar array. And we're going to take a look at this a little bit more in detail. What is important here is this function is soft linked. Soft linked in the case of WebKit, in case of DILT, means that the function pointer itself is not resolved at compile time, but it is resolved back at runtime. That basically means that when you try to load this function, DILT is going to know, oh, this function pointer hasn't resolved yet, and then it's going to sign this function pointer with its zero diversified context, and it's going to write it back so that you can call it, which is a good thing for us, because that means that this function is always going to be behind a zero diversified pointer, and we can, after it has been resolved, easily call it. This function is reachable basically from content document write. It goes into like 16 functions deep, and there is a telephony number detector find function that is called before. If we take a look at the find function, then we can see here, sorry, this is not great readable, but it basically takes the first result, it's going to call the scanner first result unique array function. Then it has another function called the phone number scanner. And this function is going to be returning us basically an attacker-controlled part into x0. So that means after this, I have a function pointer that I can resolve, and I have x0 as an argument that is going to be called here first, which gives me our first primitive that allows me to call basically an arbitrary function if I have a signed pointer. If we're taking a look here at, this is the DDR function here, then we can see here this is a call that goes to the phone number scanner. Then x8 is attacker's control. This is always going to be at a known offset, which means at the very end, if I have a known offset, it's not going to change. If I have the offset for this specific version of iOS, I know where this part in memory is always going to be located. So if I have a read and write, I can basically control this. And at the end, we're going to see that here is the zero diversified call to x8, and x8 is attacker controlled, so that allows me to write the function pointer there and jump. This here is the telephony number functions, which we can also see that it nicely takes x8 as an argument as well. And once again, this is as a fixed determined location. And then at the very end, we can see that this translates from x8 at an offset, and it goes back into x0. So this is perfect for us because it immediately allows us to ship something from location x8 that we control at a fixed location into x0, so we can basically use this as a function call. Okay. So this is what the attackers needs to do in order to like trigger the job chain and control this. The soft link pointers that are going to be resolved are going to be stored in data dirty. This is a region of memory that is not protected by TPRO. So as an attacker, once I have arbitrary read and write, I can basically control this region. I don't need to bypass any other mitigation. And then the phone number scanner's value, this offset is inside of the data region, so I can also write to this, and this is basically where I get control. There is another function here that is getDisplayType that is also soft linked, that is used a little bit later in the chain. So what allows me this basically is I write my function pointer into one part, and then I have the buffer pointer to my job chain in the other part, and then I can use this function in order to like call it. The next part of the trampoline, the next part is a trampoline, which we want to use in order to call other functions with 3 and 6 parameters. This one is located in the libgpu compiler implementation lazy dilib section. And what we can see here, it starts with x0, and then it basically calls that into x8, and then at here it's going to do a branch for x8. So we can use this in order to go from x0 and call another part into x8. And then if we're using it a couple of functions later that they're using, we can see here that this is also coming from x0 into x19. And then later on, there is 3 different arguments here, x0, x1, and x2, which are going to be coming from x19 with the offset. And then we have a branch to this part here as well. So this allows us to call a function with 3 different arguments. And this is another function that they found that basically works with the same principle. I once again start from x8, and then I have x19 that comes from x0. And from x19, I have 6 different arguments here that are coming from various offsets. What's important here, both of these are having here a pointer that is called from an object that is gsecurityD. We can see this in the previous slide here as well. So if I have a chance to create the structure gsecurityD, I have perfect control of the pointers that are going to be called next. And I also have a way with my argument x19 that is transported over as x0 that I can also control the function parameters here. So if we draw this up, this looks basically like I start first from my scanner, then I use my GPU compiler trampoline, and this allows me to have another call into x8, and then from x8 I can have my gsecurity object that contains the other function pointers, and x0 is always going to be used as the first argument, and then from x0 I can read the other arguments, and x0 in this case is my buffer with the other parts. So we can use the first part of the job chain in order to call dlsym, dlopen, and sign pointers, and we can use the second one in order to run pthread create. There's one small problem here. All of these functions are going to taking like zero diversified pointer, and the question is, where do we get these zero diversified pointers? Because we need to have some sort of mechanism to create those in the first place. The softlink function that we use in order to get the job chain running in the first place has one problem. Softlinking works only once. That means after this is resolved in the first place, there is no other chance that I can resolve a second pointer. I would need to find multiple different other functions that are also soft-linked in order to do this. But the attackers found something else, and this is already something that we had yesterday in your talk, and this is interposition tables and tuples. So this is a feature inside of DIL that would allow you to change some part of the behavior of libraries and functions, where if you load a new library, you could say, like, I want to interpose some of the functions inside of this library and change their behaviors. So if DILD is going to see that a library is loaded and there is a interpose section inside of the mach-O, it's going to take a look at this interpose table, which is going to have basically a function and a replacee. So if the attackers are able to write to this interpose table when a library is going to be loaded, then they have a way that they can basically get arbitrary function pointers signed. The only problem with this interposing state is that this is protected by TPRO. So in order to get there, attackers need to have a TPRO bypass. But let's take a look how they actually get the zero diversified function from the interposition table first. There is a very nice function inside of the IO image framework, and this is IO load CM photo symbols, which is going to do a dlopen for CM photo, and then it's going to resolve all of these functions here with like a dlsym. So if we have a chance that we can write interposition tuples for all of these different functions, we can basically control the other functions that we want to sign ourselves. As interpositions are also something that is called once in that case, this would allow us to basically generate the state only at the beginning after this library is loaded. But if we can basically create sign function pointers for dlsym or some of the other primitives that we want to have, we get our zero diversified pointers. Yeah, and this is how the interposition table should look like. These are the 3 functions here. This is our trampoline. This is the first function that allows us to call 3 arguments. This is a function that allows us to call 6 arguments. And then we have dlopen, dlsym, and sign pointer. And this is the IO load CM photo symbols, which is the initial part, like initial function that allows us to resolve all of these symbols. Yeah. So once again, this is a soft linking feature. I've talked about this before. Now let's take a look at how this job chain works. We start once again here in our first primitive that allows us to call one function pointer that is already zero diversified. with one argument. And this is the init MA capture appearance get display type. This is the second function that we're writing in the data dirty section in the beginning. So this function then allows us to get a function pointer via the soft linking feature for this part. And then it goes over into loading the IOLoad CM photo symbols, which is going to interpose all of the other pointers. And then after this, I'm also going to include this into my interposition table as well, so that afterwards I have all signed function pointers to recall it all the time. Okay. So at this stage, we basically have most of the primitives already available. So we have a function that allows us to call one zero diversified pointer with one argument. We have found job chains that allows us to call 3 and 6 arguments, functions with 3 and 6 arguments. And we also found a getJet in order to create zero diversified pointers with our image.io gadget. Now, the only problem that we still need is we need to have a way that we can actually write to these interposition tables. And now this is where the TPRO bypass comes into play. Okay, this is going to be a little bit more complicated. Okay, so what the attackers here need to do now, they have basically 3 different threads that are going to run. They're going to start here first on an attacker's thread. And then there is going to be a mutex that they found. And this mutex is one of the mutexes that they can write with their arbitrary write primitive. But it's also a mutex that is respected if DLOpen is called in a function like run initializers bottom up. So this is what I mentioned first in a TPO bypass. You need to be really, really sure that you don't have any locks or any blocks that would allow you to stop a thread if it's going on. So the attackers found one of these parts here so that they can block basically this thread if it's still in a read-write phase. So we start first by setting the mutex, and then we have a bitmap object, and we're going to running close on that bitmap object, and we're going to trigger the DLOpen. Now, if we're using bitmap close, then this is going to be opening up a specific library for a specific allocator object in order to run the deallocator for that specific bitmap part. So this will trigger the DLOpen, but because we have set the mutex, the DLOpen that is going to stay in a locked state, but it has unlocked the TPRO region for us from read-only to read-write. Now we're going to take a look at our thread and to find the specific allocation vector for this object. Now this allocation vector, once we have found it on the thread, we're going to construct this in a specific way that once the allocator free function is going to be called on that object, that we get into an arbitrary write state. The only problem we have is we cannot directly write to the TPRO region from this thread. We can only write to it from this thread because of the design of the mitigation. So we need to make sure that we allocate something that we have control of, and then the allocator free is going to do the controlled write for us. So once we have mutated and changed this allocator object, we will unlock the mutex. Then once vector resize 0 is going to be called, this is going to be result in a trigger to allocator free. And then this is going to be writing into the first part of the interposition table, and this is the buffer part. Now, the interposition table has both a buffer, but it also has a size field. So we need to basically write 2 parts here. But our primitive only allows us to do this once. So that's why we're creating another lock here. Then we're going to run another object for like a bitmap, and we're going to run another close, which will trigger another DLOpen part. And in this case, we basically do the same things again. In this case here, we have triggered this other DLOpen. The lock is still going to hold this thread now once again in a read-write state. We once again look for the allocator object. We corrupt this object. And then we're going to unlock the mutex again. And once the vector is going to be calling a resize 0 again, we can use our write primitive again. And this time we can write the size. after this, we have basically used this trick in order to write the interposition table into the state that we have the buffer and the size, which is correct. And in both cases, these threads that were actually changing the TPRO region from a read-only to read-write were doing these specific writes for us. I know it's a bit complicated.
Is this separate from the last slide? Like
No, sorry, it's the same. It's just a very large. So, so this part here is what is here. It's just going through. It's just, the format doesn't allow me to get it all into one timeline. Good. This is the allocator free function, where we can see here is the allocation metadata object, where we can see it's coming from a pointer, and then we have an offset here where it's going to be written from. So once we find the specific part inside of the stack, we control this part of the offset, and then we can write allocated bytes into it. Good. Now, this allows us to have basically all the primitives that we need. Now, we have a TPRO bypass that allows us to write the interposition tables. And with the interposition tables, we're going to get our zero-diversified pointers that we need. And with the job chain that we have built before, we can now arbitrarily call dlsim, dlopen, and pthread create. And this is all we need in order to access all the native functions that are available from the WebKit content. And basically, this is an arbitrary function call now that allows us to start the other parts of the chain. Good. Now, what did attackers do with this? They basically were using 2 additional kernel vulnerabilities, and we're going to talk about this at another point in time. And these 2 kernel vulnerabilities allowed them to turn arbitrary physical memory into shared memory, which means with the shared memory, they could change other processes on the system. They could create a thread in these processes, and then they can basically also load other libraries. And what they did here is they were basically reusing some of the primitives they already had in WebKit and decided that they're going to use these other processes, open up JavaScript core, then load another WebKit part, corrupted this WebKit part into getting another arbitrary code execution part into that process, and then they were basically starting the entire chain that they used in the first RCE just inside of other processes to get code execution there. And then they were basically just loading arbitrary JavaScript and executed that in this process, which is a very smart thing to do in this case, because normally, if you would be attacking iOS, and what we've seen in Karuna is that people, in order to get arbitrary code execution somewhere else, they need to bypass a lot of the mitigations that Apple added over time, like the code signature bypasses, like SPTM bypasses or PPL bypasses, kernel pointer authentication codes, so on and so forth. Now, with this trick, because they could take it into shared memory, they just get code execution in other very privileged processes, and they completely are sidestepping all of these mitigations that Apple built up over years to make it harder. Karuna had bypasses for all of these, which made it also very expensive, but the attackers here just used these very, very nice tricks in order to completely avoid this and still get the job done. Now, they were basically having one specific implant that was running inside of Media Playback D, and this implant was orchestrating now different parts. We have a keychain copier part that was running inside of config D or security D. We have 2 Wi-Fi passwords dumps inside of Wi-Fi D and security D. We have an iCloud dumper inside of a user event agent, and then we have a file downloader that runs inside of Springboard. And with that, they were basically extracting a lot of very, very interesting databases from the phone. If you want to know what all databases were and what you can do with that, you need to go to Sarah in one of her forensics classes, because it's basically everything that a forensic person would want to take a look at, but it's also everything that a attacker would want to get from the phone. It allows you to completely create a pattern of life for this person. So all iMessages, all passwords, authentication tokens, up to even databases of what a firm was doing there, like a health database, so on and so forth. It's really, really a lot, and we have a full blog post on all the different parts. Then all of this data was afterwards copied locally on the disk, And then the file downloader part here was also responsible for taking all the files from the different places and uploading this to this like C2 server. Good. Yeah, some of the IOCs that we have seen here, and these are very obvious IOCs if you have visibility on the system for these specific directories, like keychain 2 inside of temp, Wi-Fi passwords inside of private or wireless, iCloud dump, so on and so forth. Some of these IOCs are in multiple different places. Sometimes, even if the first place might not be writable in the function, they decided to use a second location. Some of these locations are also getting cleaned up afterwards, but some of these locations are not. So if you have good visibility of the system, you can still very easily check for compromises in there. What we could also see in the framework was that it seems to be having used way earlier. Already like in 17.4, we could see some parts that were like used in like 17.4 or like 17.4.1, but they were not used in the specific like chain, but it looked like something that the attackers were just like reusing their approach over like multiple years. What's also important to note here is when we took a look at this specific part of the chain, there was no OPSEC. So I just took a phone, I run burpseed on it, and I basically started to like step by step dump all the different chains and taking a look at it. So this took me like 15 to 20 minutes, like reading all the parts and getting the different stages. There was no timing checks. There was not making sure that I'm not using VPNs, proxies, or other parts on the system. It just basically allowed me. You have seen that some part of the URLs were very descriptive, like RCE loader, worker, module. This is not what a, let's say, more professional threat actor would normally be using. We had verbose logging in both on the network side, but also a lot of these steps were all logged to unified logs, which means if you also have visibility of forensic evidence afterwards, you could see this. This file-based IOCs and TAM, there's almost no cleanup that has been done. This part, so this version of the kit did clean up in one of the two locations that have crashes, but they forgot to clean up the second one. Another part of the implant that Google found cleaned the other directory, but forgot to clean the one that this one cleaned. So there's a lot of behavior here, which is very interesting to see that attackers are using this without basically non-OPSEC at all. There was no additional encryption that was introduced here, so if you have some network interception capabilities, you could easily see and read all the traffic. Some conclusions on the website here. Let's say the first part here is some part of the OPSEC and proliferation consequences. Sorry. Okay. This specific part of the OPSEC has some very profound consequences on the entire, like, say, offensive industry. Now, because the OPSEC was so shitty, we tried to really, really make sure that once we start disclosing this, that all the domains of the attackers were taken down. The reason for this is all JavaScript. Every one of you in the room can basically take up a web server, capture the network traffic, and get this chain going in like 10 to 15 minutes if they wanted to. That's why we wanted to make sure that this is not able to proliferate, because even at the point in time that we were like capturing this, we were still like 250 million devices vulnerable. But unfortunately, a couple of days after we've published this, someone disclosed the entire chain on GitHub. And now what we're seeing is basically the same as Karuna, that attackers are now copying this and using it against multiple people. Some of these attackers are now using a little bit more OPSEC. They're not calling it RCE loader anymore. They're just calling it like a random string. But it doesn't change that the same like behavior is still possible. We are also now seeing attackers that are combining Karuna and Darksword into this. And because this was so easy to copy, we're now in a state that iOS exploitation is not just for, let's say, some privileged offensive actors anymore, but any, let's say, standard criminal that has some deployment expertise can now start building up these chains, of course, only for the vulnerable versions of iOS. But even up to today, at least in our telemetry, we're seeing people that are running these vulnerable versions and are getting infected. It's the same with Karuna. And because a lot of these techniques and bypasses were kept like private for like the offensive industry, Now, a lot of people that are coming from a Windows, Linux, or even Android background then can now understand how to learn and bypass some of these techniques on iOS. And so far, we haven't seen that there are like TPO bypass that is used here, or these strategies that Apple did start to mitigate some part of this. So if people have now other vulnerabilities inside of WebKit or other cases, it's way, way easier for them to like build up chains. The same with these strategies that we have seen in just injecting JavaScript into other parts. Now, a simple kernel read and write vulnerability is now enough in order to get the job done. I don't need the advanced kernel parts anymore. And finally, if we're looking at some of these more advanced like AI tools or like models like Mythos, they are now way, way easier or helping people to like really lower the burden into getting some part of these exploitation going. So if I can find some of the bugs easier, if I now understand how the techniques are used and I can even train my models on some of these techniques, it's kind of a real game changer in what we're going to see in iOS exploitation going forward. And on a detection side, we're kind of still lacking the frameworks that we would see on other desktop system, or like Android, like Google introduced intrusion logging on Android in order to like tackle some of these problems. But on the side of Apple, they decide to basically that there's a company that is able to protect everyone from kind of these threats. And what we're seeing over time and time and time again, it's companies like Google, like organizations like Amnesty, Citizen Lab, it's iVerify that are finding these threats in the wild, but it's not Apple that is finding these patching systems telling you about this. So we're in a state that I'm very worried about what's going to happen in like iOS and maybe even macOS security over the next coming of years. And I'm not sure if Apple's strategy is still like valid enough that we can protect everyone against like larger mass scale attacks, especially with people not just patching on like day one if something is closed. Okay, sorry, that was just some part of what changed in March. Now, there's another part here that I want to talk about, and this is the effectiveness of software mitigation. As we have seen, some part of the root causes of the bugs that we have in arbitrary read and write part is the further we get away with some of the mitigations on what we're trying to close, the harder it is to actually have these mitigations being effective. It's increasingly difficult for like Apple or even other like defenders to build up mitigations that can stop someone that has already like arbitrary read and write to get from there to like code execution. You can make the way harder. You can basically stop some of the techniques, but it is super, super hard to make the system completely so isolated that this is not possible anymore, especially with something like a DIL shared cache, which allows you like to access functions which are like 2 gigabytes in like size. I don't think that this is going to work, and we would always need to expect that someone is able to get from the first stage to the next stage. Privilege escalation is a different story here, but this specific part, it's just a couple of hurdles more. Yeah, and for the specific TPRO bypass or like the soft linking issues, this is definitely a good target where Apple could easily just include some part of these sections into the TPRO stage, because the soft linking part is a very, very easy for an attacker to overwrite. Yeah, if you're interested in some more material, these are amazing talks just about how PAC works. This is our blog post that goes a little bit more into the details of how we found it and some of the IOCs. This is a great talk into understanding how WebKit mitigations works. Same as Quentin's talk here. And obviously, if you want to understand all the mitigations and what Apple has added over the years, Jonathan Levin's talk just a couple of months ago from OBTS is an amazing resource. And the Guza was the first one that detailed APRR. Yeah, and as always, there's multiple people in the community that already did like lots of work previously. Yeah, and this is. We called this Black Ladder Bear first when we found it, and then we chatted with Google and saw that they found it too, and then we called it Dark Sword together, but let's say I still like this. Maybe one funny story at the end. We chatted with because this chain was used in Ukraine to target Ukrainians. We chatted with the Ukrainian CERT to make sure that they're taking all the domains down and like gave them basically a pre-read. We also sent them a logo with like some bears and a dark sword that we wanted to use. The only response we got from the Ukrainians was like, great blog post, thank you. But can you please make sure that the bears are looking miserable? All right, thank you very much. Any questions? Sorry.
Thank you. You mentioned a bit about where Apple probably shouldn't be investing in these software mitigations because they're not as effective as they might be. But I guess two parts. Like first on what's the economics from the attacker side? How much did it cost to get around everything? And where should Apple be actually investing to protect?
I'm not sure how much it took the attackers to find some part of these gadgets. I mean, the interposition tuples is now something that is obviously like public, but you found the same thing in your talk just by looking at a different part. So I'm not sure how much the costs were. I don't think that Apple should invest so much in more mitigations over time, but thinking more about how do we actually detect attackers that are on a system so that we can spot the devices that are attacked and we can learn more about how the attackers were going in, rather than spending more time on like mitigations. But that's, I mean, I've been working in enterprise security for like 10, 15 years, and like 10 years ago, we have learned a lot that we were not able to be going to be stopping attacks all the time, so we need to better understand how attackers are like getting in, and then use the detection part in order to like learn where our gaps are and then fixing it, rather than spend all the like resources on prevention.
Thank you. Really amazing talk. Also cool to see that swapping function pointers also works in the real world. When I was looking through stuff for my talk, there's a very similar way that they create essentially shared logic that's going to be shared by all of Rosetta called AOT shared. It's not the same as putting all the dynamic libraries that macOS is going to use into the shared cache, but it's similar in that like it's essentially all the logic that runtime wants to use. And I found it really difficult to figure out any sort of live or dynamic analysis for it. It was very static, you know, looking through like IPSW or OTool and just kind of begging that my grep skills work. I was curious, was there anything in terms of like, you know, live debugging or analysis that was especially useful for trawling through those really big files for specific function calls? And I'm saying that because I don't know any current tool set, or I'm not comfortable with one.
I mean, as you can see on the slides, that's, no, come on. We're a huge fan of Blacktop's tools too, and much props to him. Now, I don't think, we also use a lot of like static analysis. Most of this research was done by Mateusz, and it works pretty well, but he's also a very seasoned like WebKit exploitation developer, but also like Finder, so he does this for like 10 years, so I can't really tell you more about his techniques, but if you get the chance to talk to him, you might be able to answer this a bit more.
That's all good. I'll make sure to stay literate. All right, thank you.
Some insight from Itush from our team, Binja. A little bit of a plug there for Binary Ninja, just putting it out there. So previously we talked about there being an orchestrator and then some components between different processes. Why can't one process be responsible for all of the collection, and why do they have to be orchestrated through shared memory in order to collect different components across iOS?
Yeah, that's actually a great question. So the problem here is that they don't have this SPTM bypass in the kernel. So they cannot just create their own process, give it arbitrary access rights, change their permissions into like running as root and unsandbox. So that means they need to leverage existing processes on the system that already have these kind of permissions. So that's why they're using, for example, Springboard that has access to a lot of files on the system in order to like read the files and upload them and has network access. Or they're using Wi-Fi D and Security D that can already access your Wi-Fi passwords or like your passwords inside the keychain. If they would wanted to extract, let's say, like data from WhatsApp, they would need to inject into WhatsApp in order to like read the WhatsApp passwords or find another like process on the system that already has this kind of privileges. But I'm not sure if it really matters in that case because the user space part of the system already needs to have all the permissions in order to allow you to use the phone. So you just need to find the right process, inject to it, and then you do what you want. Obviously, this is also nice to build up some detections. If you will ever find Springboard with like JavaScript library, like JavaScript core loaded into it, this might be a very obvious case of like something's weird going on the phone.
Last question.
One more?
I'll do it with no mic. So Apple offers lockdown mode, and I'm curious if any of the exploits that you talked about have successfully been run through lockdown mode, and then also like having an iPhone, being a daily iPhone user, like what can the average person do if they don't want to go through the lockdown mode process to like mitigate some of that risk?
Great question too. Lockdown mode would have been able to stop some part of the attack, but the kernel exploits, for example, would not be like a part that is mitigated by lockdown mode. But a part of the initial remote code execution would have been stopped by lockdown mode. I wouldn't say that there is no bypasses for this. It's just I don't think that a lot of people are already using lockdown mode enough that attackers have an incentive or mitigation to go after it. It's just even most of the targeted persons that we are working with are not using lockdown mode. What you as an individual can do is make sure your phone is up to date. Make sure that if an update is available, that you're also installing it basically on day 0 or like day 1. And then there is tools like Verify. There's other organizations out there that in case you're more targeted and you want to get your phone checked on a more regular basis, then you can work with these organizations. We have a consumer application that allows you to like run sysdiagnosis a couple of times per month, send the sysdiagnosis to us and get like a check. But I don't want to do much advertisement for us here. There's other organizations out there that do the same thing. Like Amnesty Citizen Lab did a perfect job over the last years in like catching some of these advanced attacks. If you don't want to use lockdown mode, there's other ways that you can lock down some part of the system. But I highly recommend do not stay on old versions of iOS. This is going to get very dangerous in the next couple of months and years. Okay, I think that was the last question. Thank you very much. See you later at the bar.
It does help if I turn it on. So I do have a few more giveaways before I introduce our next speaker. And I do have a book, so beware. The Art of Mac Malware. Who wants it? Oh, that's an easier one, but we're going to play it fast and loose this morning. Are you ready? We're going to do it. Woo! And then I have what is this?
Oh, is it this t-shirt?
An extra small, yes, it is a t-shirt. Astute. Ah, shit, sorry. The Big Broker is Watching t-shirt. Yeah, okay. Oh, God. Yeah, good morning. It's that kind of day. So our next speaker, I used an LLM to help me write this intro, so you're going to listen to all of it. AI is moving from chatbot to intern to coworker, so securing LLMs isn't just prompt injection anymore either. Our next speaker, David Campbell, is at Scale AI, red teaming some of the world's most advanced AI systems, helping governments and global enterprises understand how attackers exploit AI in ways most organizations still are not looking for. So, welcome, David Campbell.
Hey, awesome. Thank you so much. I super appreciate that. I absolutely love the hell out of this conference, so I'm going to do something super weird, but we're just going to do a stage selfie. So everybody just, smile. If you don't want to be in it, cover your face up, but 1, 2, 3. Yeah. Thanks. I appreciate that. Awesome. How's everybody's Summercon going so far? I fucking love hearing that. That's great. Cool. My name's David Campbell. I have worked at Silicon Valley startups for almost way too long now, I think, at this point. I have about 15-ish years of experience of breaking shit. Hopefully not all the time. My background is SRE and then ended up being in cyber more recently. I actually gave my very first talk ever here was at Summercon 2024. So this is kind of an extended version of that now, which is super exciting. Yeah. Right now, I am censored, doing a thing, working on a thing. Hopefully have more information here soon. I have an O'Reilly book coming out soon also, which I'm very excited about. So you're like, what the hell? Why did this break? I created the most scary model that's ever been created. Apparently, Google's AI thinks that this is the most dangerous model ever. I asked it to create a cow jumping over a block of brie cheese, and I hit a content policy violation, which is incredibly exciting. I was very proud of that when those things happen. What's exciting about that is, like I said, this isn't a new talk. In 2024, ignore previous instructions, embracing AI red teaming was the thing. I wanted to get out and help people understand what AI red teaming meant. In hindsight, 2 years later, I fucked up. AI red teaming is important, don't get me wrong, but there's so much more to it. And we got so stuck on the model layer and the behavior of models that I kind of feel we lost our mind when it comes to the rest of cybersecurity. There's a lot of missing pieces that still remain. AI security gave us the insight and the visibility and the understanding of how models work, of the behavior and the distribution within that model. What it doesn't do is actually help us protect systems, protect services, understand where things exist. A few years ago, ignore previous instructions was just a joke. It was an interesting idea. Somebody on my team actually came up with it, which was really great. They didn't get credit for it, which was a bummer, but it ended up becoming a major vulnerability, and then it kind of became a whole new way of thinking about how security works. Ignoring previous instructions of how we did, cybersecurity for the last 20 years was great. However, we kind of lost the plot a little bit, and I'm reminded right now, my friend Adam gave me a shot, and I'm a big fan of this conference because it is a drinking conference, so we're gonna do a cheers. Amazing. So, today I want to talk about something a little bit bigger. Prompt injection was never the entire story here. It was kind of the smoke screen. It was damn, that was fucking good. All right. Fuck it, we'll do it. Woo! Yeah. All right. This talk is gonna get so much more fun real quick here. Okay, by the end of the talk, I hope that we really get an understanding and see AI security differently, not with some bullshit checklists, not with some fancy scare tactics, not as theater, but as a new offensive intelligence discipline, an entire new concept of how we can not just protect models, because honestly, fuck models. Who cares? If I can make a model tell me how to build a pipe bomb, that may be embarrassing, but there's really no security impact there. If I can convince the model to give me all of your PII, now we have a security incident. Now we have something to be concerned about. So, like I said, prompts aren't inherently dangerous. Sure, there are examples where prompts have unfortunately made people hurt themselves or created embarrassing content or pictures or suggestions, but they're not dangerous. Language becoming an executable is actually where it's dangerous. Where I can now use Claude Code and say, hey, I need you to do X, Y, and Z. Actually, I think the talk yesterday from Andrew was a fantastic example of language is now dangerous. He was just prompting about being able to say, help me build an app because I don't want to get out of bed to, open up for DoorDash. But the prompt isn't really the exploit, the system is. The system where it lives is where the actual things happen. So the question I think everybody needs to start asking themselves, bringing it to your team and to everybody you work with is truly, how long until somebody could weaponize your system? And I think the work really leads us to that thesis. How do we understand where the risk boundaries are, where the edge cases are, and how bad shit can actually break? And that really comes to the model is in the system. anybody that's been in cyber or even tangentially in any horizontal engineering effort in the last 30 years, well, I think inherently understand this, but I think we've sort of lost the idea there that the model isn't the system. The system is what controls the work, that orchestration flow, as the word is getting overused now, but the harness is really what things get done. And the problem is it's gotten incredibly complicated. I made this this exact slide like a month ago, and I'm pretty sure there's already new capabilities that are included. So the model knows all of this, and it's just a simple product. It's simply just the AI core, the model, and then all of the pieces of software that AI usually has written around that. And this scenario right here is absolutely ripe for abuse. All of these things on the bottom side here are things that are still lacking in models. I think agent identity is incredibly missing, governance, data containment, and then obviously the telemetry. There are startups, there are companies that are really trying to get into this space and make things better, but we're just not there yet. So if I convince a model to build a pipe bomb, like I said, who cares? If Pliny the Prompter can convince his models to build meth, again, who cares? That's interesting capability, and it shows that the behavior side, the distribution of a model, is still inherently vulnerable and flexible, but vulnerable to what? It's not really vulnerable to system injection. If I talk to ChatGPT and make it do some dumb shit, like, who cares? It doesn't really matter. Again, there are very rare exceptions where that's not true, but the crown jewels are far more important. If I could do fraud that costs a company millions of dollars, if I spin up GPUs within an AWS account, those are big concerns. If I steal all of your customer data, these are the things that we need to start thinking about within the AI security space. Embracing AI red teaming at the time was, holy shit, we can make a model do incredibly cool stuff, but it didn't really talk about the larger problem. The larger problem being, if I can make a model convince me to then to create an RCE, far more valuable, far more important, and far more the attack surface that nation-state actors are trying to find. So here's what we already know. Hackers already know this. We all know that this is basically the same process. You see the entry points are the parsers or the prompts, vulnerability and privilege and authority. Basically, it's the exact same system. What I've noticed, though, as I work with a lot of folks in both government and in the commercial side, is people have lost their mind on what creates a secure AI system. If nothing else, if you walk away and the business is trying to build an AI service, literally just stop thinking about it as a model, just think of it as another application, and you'll be exponentially safer than most people. Because everybody right now is talking about how to use guardrails or how to, build a system that, prevents me from doing prompt injection in your model. When I was at Scale AI, I built the AI red teaming business. We did red teaming for Fortune 50 companies. And when people had guardrails in, I just laughed. Because what we do, especially when they told me they had guardrails, we'd stop trying to attack the model, and instead we just attack the guardrails, which then go ahead and attack the model. So attackers don't attack models. They attack the path. And the prompt is obviously just the first move. The best thing about prompt injection that I've learned and loved over the past 3 or 4 years is that I could actually create a prompt that outputs a prompt injection that then gets pulled into the workflow. So the prompt may be the beginning of the story, but that prompt may actually not be my prompt. It could be a prompt from another system. It could be an upload in a PDF. There's a ton of different use cases. It goes through the context, the reasoning, the API calls, the controls, the workflow, and the logic. The prompt is just move number 1. And red teaming was a start. It wasn't a bad idea. I personally think that AI red teaming may have been the wrong terminology. It was very conflating with actual red teaming, but it was just the start. But here we are now, and the actual work is beginning. It's not simply replacing AI red teaming, but it's kind of rebranding and moving forward on what it meant. It's what AI red teaming should have been all along. The idea of prompt testing and model behavior and understanding the distribution in a model is part of the story, but I think understanding attack paths, understanding the telemetry and the product surfaces and all the continuous testing that's involved is really where the industry needs to start moving towards. And I do feel partially responsible for that, for pushing really hard on AI red teaming is the thing, but hopefully I'm now part of the solution, which is helping a little bit. We'll see. We understand, attackers have understood this since the dawn of computing. This is exactly what the attacker path looks like. They will learn the system. They will chain together vulnerabilities. then they're going to go through and abuse that system and then automate the entire thing until they have a fully operational model. In this world of AI and agentic systems, the problem is now all of this is done at machine speed. How do we defend against something that's done at machine speed? I'm starting to come up with a little bit more of a theory personally that, I don't know how executable it is, but I think within the next 3 to 5 to 10 years, we're going to get to the point where there'll be human in the loop, autonomous cyber. A lot of companies are pushing in that direction. We have a tier 1 SOC analyst or whatever, but I haven't seen it yet. I think we're still a few ways away. And I actually think it's probably more of an academic problem than an engineering problem. So then we look at the kill chains. So the kill chains are very, very similar. Recognizance, exploit, persistence, context, authority, tool, workflow. You're going to see on the right side, you're going to notice what's missing here is there's no actually exploit box here, which interesting because the context of a model, once you start to extrapolate out far enough, is actually the exploit. This is where the logic works within the system. And the problem with context is it can be persistent. As we'll cover in a second, which then goes down to authority, and authority is identity and privilege escalation. And then that workflow maintains and controls that persistence, that orchestration layer within it. And of course, impact across the platform is still just impact no matter what. So yeah, we're moving away from these clever prompts, from ignore previous instructions, from the Dan prompt and have your grandmother tell me a story about the NSA. All of those stories are now moving away from clever prompts into now understanding the actual attack path, understanding where your system lives. I'll never forget when Meta came out with their new, talk to Meta AI. The first thing I did is hey, how many agents are actually inside of your system? I have no way of knowing. I don't work at Meta, but they came back and said something like over 30, which seems probably reasonable. But this was the very beginning of the last year, I think. And so if I'm able to ask a model, tell me about your infrastructure, that seems like a pretty terrible idea. So there are cases where I do believe that understanding and mitigating the risk within the prompt is important. Don't tell me your infrastructure. But even without that, attackers are going to find the attack path and then go through it and go down the entire system. This is traditional cybersecurity that we've done for a very, very long time. And now that attack surface has exploded because who doesn't have AI in their microwave these days? It's just exploding out everywhere. Internet of Things was the thing 10 years ago. AI of Things is now the new attack surface area. The rest of this talk is basically talking about all these different areas. So we're going to get a little nerdy here. But basically, this is the attack surface. We go from the actual model, the core central of the service. Whatever model you pick, it doesn't really matter. They're all vulnerable. When people tell me that, I'm using XY model and it's been hardened and it's super safe, I call complete bullshit. And this is the problem. This is where a lot of cybersecurity experts stopped. This is where a lot of people that were working and saying, I am an AI security engineer, said, cool, we're going to make sure that the model is safe. I'm going to red team it, and if I can make an image of, whatever the hell it is, it doesn't matter, then therefore I'm successful. And to me, it's become the least interesting layer. There's nothing really interesting here. I like AI alignment. I think it's a very interesting area of research, but I don't think it's a very interesting area of cybersecurity or cybersecurity research. Now we go to the application layer. So we're going to think about this for a second, just talking about the model layer. Let's say there's a perfectly aligned model. It has a perfect example of alignment. There's no worries about prompt injection. None of that happens. And we still have this system at this application layer. So even if we have the most secure AI on the planet, which I got to be honest, will never happen, if it lives inside insecure software, it's still insecure software. So hardening those layers are really where the first line of defense in AI security should live. The model layer is important. I still implore people to get to know how models work. I think it'll make you better as an engineer, as a cybersecurity expert. But the application layer is where we need to regress back to and really understand about hardening this layer. Then we get to the tool layer. Who here has given Claude free access to run dangerously, whatever the hell the flag is? Oh, I do it all the time, absolutely. Exactly. I think that's exactly why this matters. I Honestly, I encourage people to run Claude code without guardrails, and I know that's going to be like a hot take that is going to maybe piss people off, but the idea and the concept there is like, as long as you're not like, trying to update production databases, like who gives a shit? Oh man, it overwrote some code I didn't write. Cool. I have it rewrite it. I'm not super worried about it. I think that's how these agents get better at systems. I think that's how agents get better at working on these services, is by having the ability to fail. And as like an AI security researcher, those failures are the interesting things. So if your agent ever blows up and you're like, damn it, David, how the hell did you tell me to do this? Hit me up. I will take all that data. We'll write a really cool research paper and it'll be amazing. 4. This is the memory and context layer. So this is what I was talking about. I was just sharing backstage how if there's an application that has shared memory and I'm able to do a prompt injection in that shared memory space, that vulnerability now applies to you and every other user on the platform. So always be wary. If any developer comes to you and is like, holy shit, I want to do this really cool thing where we're going to be able to share memory and they'll be able to chat through and model, whatever the hell, it doesn't matter. Incredibly vulnerable surface area there. Because that vulnerability could then live in perpetuity in long-term memory context. We now have models that have millions of context tokens of availability there. So context is never passive. And that prompt injection will not disappear. It's going to persist. And today's input is going to become tomorrow's vulnerability, tomorrow's problem. Then we talk about the identity and permissions layer. So as you saw on slide whatever the hell, I have a O'Reilly book coming out where we come up with this idea called BIC. So behavior, which is a lot of the model layer and AI red teaming and stuff like that. And then identity and control. And the identity layer, I think, is something that is still being worked out in the industry, but we can still apply a lot of what we've done historically. That identity layer is authentication, is authorization, is, to be honest, a human-in-the-loop framework on what this looks like. The idea of an agentic flywheel, I'm very excited as people are continuing to build out software that's going to make this possible. I think it'll make things a lot more safer. We should delegate access with control. Reasoning plus authority equals that action, and anytime you have authority, there is vulnerability potential. So offensive intelligence isn't just about finding those bugs. I think it's about measuring and capturing that attack capability. Being able to understand the boundaries and the definition of where these edge cases really are. So let's talk about some AI support agent scenario here. So these are actually issues that I've generated or created before, either with government or public sector, like I was saying. But let's say you have a call center agent. So you know what's interesting about call center agents is you call them up and they're like, oh, your phone number's attached to this, and this is classic cybersecurity data where I could just spoof your phone number. I could do any sorts of other things. But what's exciting is now I have access to your data through an agent that all I have to do is impersonate you. The more and more that I get comfortable with AI agents and how we start to work with them, I think the more the problem is on the behavior side, in the big framework, the behavior side is really this impersonation, is really social engineering. That's really what AI red teaming is. This is when we discovered and started building the AI red teaming service. The best AI red teamers weren't actually people with 20 years of cybersecurity experience. They're actually authors and writers, and a police officer was fantastic at it. People that are good at interrogating and creating a narrative and telling that story and convincing the model. So when I'm able to convince the support agent that I am not who I say I am, you should give me the CEO's data, and we're able to retrieve it back, we have to understand that that's the attacker mindset. That's how they're going to consider and manipulate these conversations with the model. The models are extremely vulnerable. We have to build the systems around them to support that. Coding agents is another great example. I have an example here, but I really like Andrew's from yesterday. I've said that twice. I'm clearly a fanboy, but it was a very, very amazing hack. And AI writes code, it merges PRs, it reads secrets and slurps up the dependencies for your package. And then it deploys the software. All of that is a supply chain. There's nothing unique there. So we used to think that NPM downloading a package was potentially vulnerable. Now just think about it where it doesn't actually have to be a code executable. It could just be a markdown file. Skill vulnerabilities when OpenClaw came out was fantastic research. I tried to gather as much shit as I could on that space. It was fantastic to see, Maltbook and all of that stuff. Incredibly stuff. This is my favorite. This happened the most recent before I left Scale. The executives, as executives do, really wanted to use Claude Cowork. I applaud them being able to use that. However, your CFO has access to financial data that could fuck your company up. So we had to limit his access. We had to limit the ability of Claude Cowork to access Google Suite tools. We use Google Suites. We didn't want it to access a Google Sheet that had M&A data or financial data or whatever. So me being me, I was like, this is great. I love this idea. SecOps, I appreciate you guys locking stuff down. Let me test it. I'll play around with it. I opened up Claude Code, and I should preface this with saying 2 years ago, I was probably like in the top 5% of AI red teamers. I'm shit at it now. I'm garbage. I'm too focused on the research side. All I did was say, hey, access this one file that had fake financial data in it. Claude Cowork tried to reach out through Chrome and said, holy shit, I'm blocked. What do I do? Instead of giving up like models do, very persistent, very smart, fuck it. It just downloaded a CLI, logged in the auth, said, click on this link, open the link. I authenticated, and boom, and then I had access to the document. Insane, wild, and not unheard of that an executive that doesn't know shit about technology, that wouldn't just click a button to make, oh God, I want to get this done. So the vulnerabilities are real, and the models are incredibly capable at finding unique ways of doing it. Here's the advantage, though. Yay, engineers and defenders, builders are the defenders. So the habits that we all should do, and I think honestly, everybody in this room, this should just come naturally. A lot of this should make sense. Think about, if you could be the biggest asshole you could, think about what that looks like. What would you do? What would you do with that feature? What would you do with this product? Find ways to exploit that. And that's your threat model. Find the worst case scenario and then build around that scenario. Treat context as untrusted input. I mentioned at the very beginning of this talk that a big hacking technique that we've been doing for a while now isn't necessarily saying, ignore previous instructions or Dan or whatever. I'm not actually trying to prompt inject the model at the very first layer. I want that model to output context that then jailbreaks or prompts and breaks models underneath it. We did an experiment for a little while where we were saying, in OpInt, a lot of the techniques that a lot of folks will use is they'll have, Agent A will then talk to Agent B. Agent C has more access than Agent B. Could we convince Agent A to convince Agent B to then access Agent C that has way more access to data, files, whatever? We're actually very interesting to watch the track of these models, especially Opus 4.6, being able to say, hey, we want to talk to you, and then it would convince and basically social engineer Agent B to do work on its behalf. Agent B would then convince Agent C to give data back to Agent A. It was fantastic, and the research paper should be out soon. Separate reasoning from authority. I see this an awful lot. The identity layer. We've worked on identity. We've gotten really good with identity in humans. We need to now get really good at identity with agents. We need to understand that we have to figure out a way to do just-in-time access for a model. We have to figure out a way to grant them the access to keep humans out of the loop for most of the small stuff. But if you're going to drop a database, what the hell? You better talk to me first. And then logs. This is something that I found really, really interesting. Oh, also, this is a really fun one. I found this literally this morning. I am a big fan. I didn't know where the hell else to put it in my deck, so I just landed here. Sorry. I'm a big fan of what, for lack of a better term, I'm going to call model psychology, I guess. I don't know what the fuck else to tell it. Maltshit.com is basically malt book, malt claw. It's related to OpenClaw stuff. This agent did a really fascinating thing where the operator was saying, hey, I want to be able to edit files and do this. Can you do this? Can you do this was the prompt from the operator. And the agent interpreted that as I can do anything. So it started acting rather than asking questions. Ended up breaking a lot of shit. There was also a really interesting thing where the model ended up switching underneath from Sonnet to Fable. Interesting read. Check it out. Back to the topic at hand. So logging the decisions is something I think we're absolutely missing in this space right now. I think we're missing the idea of observability for agents and observability for models. Logs just aren't enough. We have to be able to replay the entire attack. That means the telemetry and the prompts both on both sides of the model. Test 5, test goals, not prompts. A lot of people I see, again, are just so focused on the behavior side of AI security. Behavior is important, but it's not how you keep things secure. This side is a lot more of test the goal. Can I access data? Can I make an API call out to the internet? The attack surface of an API call out to the internet seems very minor, and it was 5 years ago where your API would call something, and if it wasn't in JSON, then it'd break your entire application. That call out to the internet can now include prompt injection on a website. Even my domain has a prompt injection within the HTML because why the hell not, right? So it's understand the goals of what you're trying to accomplish, protect that goal, create that thesis. Nobody gives a shit if prompt number 114 worked or failed. They want to know if they can get access to your data. They want to know if they can access the workflow of your system. Security Twitter, everybody's love and hate, really just runs on vibes and is becoming a toxic, vile place these days. But we need to start living in the world of evidence. And we need to start understanding that fortifying security needs to be done at the observability layer, with evidence, with tracking. So this loop is pretty simple. Discover, exploit, fix, repeat. And that's never going to end. And you may notice, like, David, what the hell? This is exactly how we do actual cybersecurity. Like, holy shit. Yeah, exactly. Totally thesis right there. This, to me, is what a good finding looks like. I think we can go through here. We understand what the attack path is, what the affected system is, what the business impact is. I think this right here is worth more than almost any other thing within an AI security finding. We continually get so interested in this shiny of, I built a pipe bomb or whatever the hell. The business impact needs to be quantified because you are speaking to executives or managers that don't understand this shit at all. Being able to explain how it's going to impact their business or the bottom line of the company, incredibly important. This replay step has been a big advantage that I've seen a lot of enterprises starting to move towards. They want to be able to say, okay, here's the prompt that broke the system, but here's the actual entire context window that was in the model. A lot of people think that, jailbreaks are this one prompt thing. In reality, it's more of like a 6, 7, 8, 9, 10 turn conversation. And then I'll take that entire context, and that's now my jailbreak. So being able to replay the entire thing. This is not doom. We're not dying. This isn't over. This is actually kind of where we just get started, I think. Attackers are always going to have the advantage. They always have. It's never been a question. But defenders are starting to catch up. We're getting better at discovering the edge cases, at understanding where the trust boundaries are. And I think that's just going to continue to accelerate, especially as we move towards this more autonomous cyber concept. We're all going to get there, and we're going to continue to move. And I think that the industry as a whole is moving in the direction of more secure. But obviously, attackers are moving faster. So we have to learn how we're going to catch up. I did a research paper that I released in January. I'm not an academic. I don't have a PhD. But I wrote one research paper. I'm very, very proud of it. It got accepted and published at ICLR, which is a major academic conference. But basically, I did scientific proof that the bad guys have a 2.7 times better chance of jailbreaking a model versus the good guys. So there's a competition called CCDC, and we had a prompt set up for the good guys where they're like, hey, is this malware? And like 17 times over, that request would get flat out refused. Like, I'm sorry, I can't help you with that. Whereas the bad guys, the red team, was able to jailbreak the prompt and then being able to ask the question to build that malware, which is a really interesting idea of, it's kind of intuitive, right? That the bad guys have the advantage of time. They could say, hey, I have this large jailbreak, I'm going to use it every single time. Whereas the good guys are like, holy shit, you're breaking my system, what do I do? So, I think the next time somebody asks, is your AI secure? Like, don't initially say, what model are you using? Or do you have guardrails? Or have you protected against prompt injection? Because I don't think that's the main concern. If it can resist prompt injection, that's good. That's part of this whole narrative of offensive intelligence. But ask what it could touch. Ask what access it has to systems. Ask what observability is in the platform. I sit in a lot of calls right now where people are saying, yeah, I have this guardrail, we're super secure, right? I'm like, that's cool. It's going to break no matter what. Assume it's going to break. And then when it does, how do you replay it? How do you know where that edge case was? How do you know where the boundaries are? How can you mitigate the risk? Because when you have Jesus, fuck, those shots are hitting me now. I need 2 more. when you have observability, you can at least identify when shit breaks. So I appreciate everybody. That was my talk. If you have any questions, I think I probably have, zero time. But thank you very much. Oh, I do have time. Yay. Excellent. If there are any time for questions, I would love to answer them. If not, that's fucking awesome too. I love it. I think somebody will bring you a mic maybe. Or you could take this one.
You've got a pretty good voice.
That's.
Would you say that probably a good mitigation would be to, like with any other application, as much as possible, sanitize the inputs, validate the outputs. Would that be a good mitigating?
Yeah.
In the interim?
So partly, the problem with sanitizing inputs and outputs is if you do a semantic sanitation, like if you say you can't say the word pipe bomb, that's fine. But what happens when a student needs to study the chemical reaction of a pipe bomb for whatever reason, right? So sanitizing semantically is really tough. I think, and the industry isn't there yet. So unfortunately, this answer's a shitty, we're all fucked kind of thing. But it's more of being able to understand the intention of the user. So the difference between me saying build a pipe bomb versus a student saying what's the chemical reaction of a nuclear warhead, completely different intentions, right? And so that does put the onus on security experts to figure out how do we define the boundary? Because again, a model telling a student how to build a pipe bomb, like, don't blow your thumb off. Like, it's awful. But somebody being able to say, I want you to run this executable from the internet, download it and run it, and then execute it. If your model has that ability to execute some unknown piece of code, horrible, horrible take to do. So I actually think the standardization is important if you're running a kids app. It's important if you're doing a healthcare app. It's important if the behavior of the model is could end up on the Wall Street Journal. But I think a lot more on the back end, you need to make sure that you mitigate the risk of what happens when somebody is able to do something nefarious. Because they will, absolutely. I don't know if that fully answers your question, but standardization is only part of the story. Yeah. Cool.
I got do we have time for one more?
I could stand here all day, but it's on you guys.
I got a question coming in from cyberspace.
Cool.
You mentioned that shared context memory is a problem to defend against, and that's okay when the context is separated in third-party systems, but what about poisoning model-trained data? How do you think about that problem? How do they think about that problem? Is it even something we should be concerned about?
Holy shit, it's super concerning. So this is great. So Russia's Pravda network, super big, like disinformation network. It's been around for a while. They've been releasing data into models, but obviously all these data model providers are so hungry for data, they'll slurp up everything they can. There was a research paper that came out a year and a half ago, whatever, it doesn't matter, that proved that to do disinformation, you only need 218 entries to change information. And the thesis, the experiment was, they had a frontier model. I think it was a frontier model. It could have been an open source model. It doesn't matter. They had a frontier model. You'd ask the question, who's the president's wife? And it would answer the question appropriately and do that question and do the answer. They then fine-tuned, or they then created this fake network of data. They found 218 changes, would then change the president's wife to whatever name, it doesn't really matter. So absolutely concerned. I think that's honestly on the model vendors. I think they need to really understand that the risk of data is more important than they even realize at this point. And being able to protect and hard code that is a problem that I wish I had the answer to. I don't. I think it is a very scary one. I think disinformation is probably going to continue to be a scary vector for fake news, if you will, in the future. That's a really good question. What's the incentive for them? Model vendors? Yeah, exactly. They don't fucking care. Totally. Like their incentive is like, are you going to keep spending, $5 million a month on tokens? Like AWS spend is shit now compared to that. So there is no incentive, which is a terrifying place to be in. What I think and hope and pray, and sorry, last thing, and then I'll get the hell out. The thing I hope and pray is that we start using very smaller, isolated models that are specifically fine-tuned for whatever use case. Awesome. I appreciate everybody. Thank you so much.
You can find him at the bar later if you have any more questions. Thank you. Awesome. So we actually have more, you can tell by how I am hefting this stuff. We have more things to give away. Here, you can hold this.
Okay. The first item is and I'm not sure if I pronounce this right, it's Ghidra, right? which is a reverse engineering tool, and apparently you need a book to understand it. So compliments to the NSA, not for the book, but for the tool. This is what your taxpayer dollars go toward. And I think we're missing another mic. Okay. So this is one of our wonderful Summercon hats. It has a brim and the Summercon logo.
It's black on black, classic look. Okay, Peter, I see you. Oh, that was left-handed. We'll blame it on that.
And not to be outdone, we have 2 more of them.
Ooh.
Yeah.
Oh. Yeah.
Let's see if we can get you and not pop somebody in the face with it.
Stealth mode.
All right. Next up, Tracy, what lovely items do you have?
We have a T-shirt, size medium. Another big broker is watching you. Yeah, that was fast.
We also have another size medium.
Woo! Heck yeah.
And
This is a very popular item, except for the Tracy hair on it. There you go.
I thought they wanted the hair.
You have to pay extra for that.
and another big broker,
it's
size
an-
large. All right.
This one is a.
We really do need a T-shirt
small,
cannon.
Extra small.
Or
extra
like
small
a T-shirt flamethrower. of sorts.
Summercon. Yeah, dead. Oh, I see you. You ready? This is a terrible. No. Hold on.
I'm holding on.
This is dangerous.
Okay, and one more.
So we've got a couple more jackets here, and I don't know
right
what the
on.
size on this is.
Should be right.
Is small.
S-
I've never really
S
worn
is
a
short
small.
for small.
If you want to come up and get this, because there's no way I'm going to be able to hit you.
Right on.
Twitter.
Yeah, these are really high quality. They're great.
Yes, these are great.
And this is a 2XL big broker.
And we have
It
one
is-
more jacket that's a medium.
Ooh. Heck yeah.
First person to come up gets it.
Oh, it's a race. No one. It's too
There
early
we
for
go.
that.
Yeah, that's what I'm talking about. Okay. Yeah. Okay, very nice. I just say
And then we've got one more Summercon trucker hat from this year.
It is American themed.
This is generally dangerous for me to throw things, so if you want to come on up
here,
and
we're doing it.
All right.
You ready?
Frisbee that guy in the fucking face.
Fantastic. We have more things to give away when you guys come back for lunch. We have a couple more special things, I think.
We do have some special things. I also promise I'm
Is
not
your
playing
pocket
pocket pool.
feeling a little heavy?
These are classic bottle openers. Advance, persist, threaten.
I love that.
Let's see if I can take somebody's eye out. We got one more. Let's see if I can get you. Oh, we almost got it. I don't have drink. Oh, actually, that's not true. I might have a drink token.
See? It might be loose change. It might be drink tokens. We'll see what he throws.
I got a. Yeah. My wallet.
You're right. I'm just gonna literally like flick it and see what happens.
I do have a drink token.
Okay, let's do this.
Yeah.
All right. Now I guess I'll get off stage here.
Well, I think we can stick around.
Actually,
it's not like the next thing's going to be a big deal.
The next thing is a sacred ceremony, as it turns out.
only.
Well, that's also true. But we're now going to induct a member of our community into the Summercon Hall of Fame for his lifetime achievements. And I think this is a good opportunity for someone to warn them down there that they need to get up here to do our lifetime achievement.
Yeah, you probably want to warn all 5 people that they need to get up here.
Yeah, there's we started the Lifetime Achievement Award a long time ago, but we turned it into a Hall of Fame only 3 years ago, and we've
3
been
years ago sounds right.
steadily inducting people into it that have had outsized impact on our community of information
It
security.
started as what, Chris and Dino, and then the Potters.
It was Chris and Mudge.
And Mudge.
And then
And then the Potters, then
and
we did Dino last year.
Yeah, we had some technical difficulties with the Dino presentation.
Speaking
but I
of
feel
Dino.
like, look at that guy.
Hey, buddy.
Okay, and
Chris is here too.
And Heidi. And here's Mudge. And here's Bruce.
Over here, old man. Over here.
And our honoree, our inductee, if you will give him a round of applause, this is Charlie Miller. Now, this ceremony is entirely operated by the members of the Hall of Fame, and I'm not even supposed to be on stage, but there was
You haven't
one.
earned your spot.
I have not earned my spot. It is true.
Yeah.
So one thing though that I did want to do, and I asked a member of our community of the journalism community who has a special relationship with Charlie to provide a few words, and he asked if I would read them into the official record. So here we go. No. I'm gonna read them. Andy Greenberg had this to say.
Where are you, Andy? Get here.
Most of you know Charlie as either the world's greatest stunt hacker or as the cyber criminal who tried to murder me while I was driving his Jeep Cherokee. But I first got to know Charlie in his more innocent youth as the first hacker to break into an iPhone. I interviewed Charlie at DEF CON in 2007. He described iOS's internal security measures as pudding. I knew it was going to be the beginning of a beautiful journalistic relationship. Charlie went on to build a wormable SMS exploit that could have taken over millions of iPhones to hack the firmware of MacBook batteries and, according to headlines I did not write, make them explode. And to get himself kicked out of Apple's developer program for putting malware in the App Store. Still banned. Incredible resume. Today, Charlie is, sadly, a corporate sellout who writes TPS reports for his boss, Chris, and shuns stunt hacking, but will always have the memory of the moment when I screamed into the phone for him to please unhack the Jeep before an 18-wheeler crushed me. Thank you for everything, Charlie. And with that, I'm going to hand over the ceremony to
Mark. So before you all knew Charlie as a stunt hacker, I knew him as a copycat hacker writing my coattails. So you might know Charlie from him winning Pwn to Own, with an exploit that ran in 30 seconds. The year after, I won Pwn to Own, and the exploit ran in somewhere under 30 seconds. You might know him from, writing the iOS Hacker's Handbook. But for reasons that shall become evident soon, I found this ancient manuscript that is far, far rarer. I found it in a rare bookshop in Midtown Manhattan. It was really only read by its authors. And I would love Charlie and Mudge. Thank you, Mudge. And I would love to ask Charlie to sign the book that we wrote together.
Thank you.
Pose already.
I know. Here, get this off.
Jesus Christ.
Oh, it's already off. No wonder.
I clicked it.
Oh.
Look how detached from reality is.
The technical prowess on display.
Usually have just people do this for him.
I said it here, thanks for 0 royalties on this book. Because that's what we got, was 0 royalties.
Is that it from you?
That's it from me. Oh, yeah, wait. Thank you, actually, thank you, Charlie. I did a lot of, we did a lot of fun research, and some of my still to this day favorite presentations. I'm not going to say which one. I'm not going to say which one. My favorite presentations were ones that we did together.
My favorite presentation is me and Dino gave a talk in Germany, and every one of our jokes didn't land.
Was that a Boogaloo 2?
Yes.
Yeah, amazing. If you're looking for a tier, there's a door. This guy's a piece of shit. I just can't say anything good about the guy. I just don't really, nothing comes to the top of mind when you say, good dude, Charlie. Just, I don't have anything.
Yeah, there you go.
Next.
Seriously, Charlie is probably the smartest dude I've ever met. Like, I probably owe my career to him. Like, he is the smartest dude you ever met, and he is willing to do the fucking dumbest shit or the smartest shit ever. It doesn't matter if it's changing lives in an Excel file or fucking hacking a Jeep. Dude will do it. Fucking St. Louis grinder. Have another vodka, bud.
Charlie didn't even remember who I was when I saw him yesterday.
Did you look at her name tag?
I did.
It's fine, it's fine, it's fine. I first met Charlie, I think the first time I met you was in 2008.
See, that's a long time.
Right, when he was standing on my stage with this guy, doing a thing. So anyway, Charlie, it's nice to meet you again.
Great times.
I've never met Charlie. I will say, like, in all seriousness, like, a lot of us have been coming to events like this for a long time, and I remember watching people on stage that were inspirational and motivated not just me, but the whole audience. And Charlie is one of those people that, like, he will inspire the people around him to do cool shit and follow behind and stand on his shoulders and that kind of thing. And I have a lot of respect for that. There's a lot of good research that goes on. There's a lot of important work that goes on that's presented here and other places. But the delivery and the person and the intent behind it matter a lot. And Charlie's the kind of person that lit a flame for a lot of us here, and a lot of respect for him and all the work that he's done.
Okay, so I guess I get to close this out, and we'll try and remember the environment we're in, the big skiff. The world. Yeah, the world. I've known Charlie for a while, and look into his past as much as you can find of it. And he has, for my world, been the person who has always followed through. And when there is an extremely challenging or risky or interesting idea, and Charlie might present it, like, I want to try and make over NFC or US, whatever it was, a battery go critical or something. Do you think we can do it? Well, if the person's background looks like this, I go, that's worth actually exploring. And there have been ones that haven't panned out, but that's research. And there have been ones that have panned out almost completely, and that's been research as well. Anytime I've interacted with Charlie, he's treated me kindly. I've looked up to him. I've always learned something from him. He has been a treasure to the country. He has been a treasure to our community. And I think we all would like to say thank you.
Get the jacket on. Welcome to the club.
Let me say something. All right, well.
Center stage.
Is this on? So first, let me thank you and everyone on stage I really look up to, and it's a real honor to be in this group. I've been doing research I did do research for a long time. I haven't done it in a while. I'm old. But
he still gets paid for it.
Well, I get paid like I'm doing research. But yeah, I've always looked up to people in the community. Dan Kaminsky taught me a lot about giving presentations. Barnaby Jack was a huge idol of mine as far as the stuff he would do. So I stand on the shoulders of other people, and I hopefully people will be inspired by what we do. But I've given some talks here at SummerCon. Now the next step was to get this award, and I think the next time you'll see me is the in memoriam. So I'll see you then.
Now do the dance. No, you got to do the dance.
Is there a dance?
Yeah. Is that two or shift how many? Left shift, right shift.
You can take one more.
Wait, one with the book.
Yeah, get the book in front. 1, 2.
Right over my crotch.
All right. Thanks.
Incredible. Oh yeah, they definitely did. I mean, that's how they do. Is that on?
I mean, it's on now.
Okay, cool. Well, they took the mic and we'll never get it back. That's how it works here.
Yeah.
They're better than us. They can do anything they want.
I think it's just going to end up in the green room bathroom.
Got it.
Well. That's far less funny.
Why do they all go to the green room bathroom together?
I mean, if you know, you know.
I assure you, I do not know. I do not know. So we're at the lunch break, I think. Is that correct?
It's 1:05, so we're a little after.
Little after the lunch break. It was supposed to start, but I think that was worth it.
I think we start back at 2.
2, yes. 2 o'clock. So we're back at 2. We have some really great giveaways, including Lee Felsenstein's memoir autographed by Lee. He's the founder of the Homebrew Computer Club.
That's a really special book if you're not familiar with it.
Yeah.
I also saw something back there that looked pretty special.
Yeah?
I saw
It wasn't me, was it?
Well, that's a different thing. I mean, that was before you put your pants back on. I saw a complete rendition of POC or Get the Fuck Out.
Yes, there's all three volumes of that.
As a complete set.
As a complete set, unopened, still in the shrink wrap.
You can suffocate yourself on the cellophane.
Yes, yes.
Or read a wonderful book.
Yeah, a wonderful part of our history with the gilded edges and all of it. It's really amazing.
They're really fancy looking books, and if you were lucky enough to get it, it would be the entire 3-set volume.
Yeah, of course. So please.
So we should have some sort of a competition for that, like a trivia or feats of strength of sorts.
Well, yeah, Chris and Charlie were talking about what they can bench in the green room earlier, because they're bros.
Is this a prediction market where we're going to take bets on them? I think he can do 19 push-ups. I think he can pass out. Yeah.
I love this idea. Where does liver failure fit into that?
Well, I didn't say I'd be competing.
Okay. Oh, fair. Okay, then. Okay. So we're going to let these nice people go to lunch now, but we're going to remind you that cool stuff is available, so please get back on time.
And definitely come back for the 2 o'clock talk, because I'm going to introduce it, and I have crazy things to say about the speaker.
Thanks, everybody. See you in an hour. A little bit less.
Dark in here.
Incriminating documents. You keep it hidden in a music box.
Well, that bothers me too more. But it's possible that Joshua was trying to cover himself. I mean,
Okay, here we go, Mark. What the hell is going on in here? Say something.
I'm trying to take care of getting badges printed out with, 16 minutes until registration starts.
Beer.
Shouldn't be that important. Yeah.
Type, motherfucker, type.
Dude, is that like a virtual, laminate?
That's virtual.
That's all access, you can tell.
Smile, Amy. Oh, now that's special.
What do you think of Summercon so far?
Oh, it's fabulous. They opened the bar early for us. You know, what's not to like?
So, Summercon means bar to you.
It means socializing. And
We stopped and called the whole thing and then we
Gotcha.
so we're gonna go back and see.
Okay.
How's everything going?
Good. Yeah, it's going well.
You saw the talk and then the jacket.
Yeah, do you like that?
It's cute.
Yeah. Isn't it? It's. I think it's more compelling when you have a whole bunch of people on stage wearing those blue jackets. Yeah. And being like, and I'm not one of you, so I can only read this thing into the record, and then I gotta go. So yeah. I don't know. You saw Barbara.
We didn't see Barbara.
Oh, she's probably over at
We think she
Ornate.
went over because Jim said she was over there.
Okay.
And then we just didn't want to try to squeeze in during the talk, so we can go back. That was a good presentation. It was
Right on. Well, thank you.
I enjoyed it.
Why don't we walk over and see if we can find Barbara? I think she is.
Check, check.
You guys hungry? What should we order?
Pizza, tacos, gochujang and chicken.
And then I'll do the intro for Tom. Yeah, Mark. The real move to show that we've made it is when we start seeing a bunch of homeless people walking around in Summercon flag.
Oh yeah, it's the stuff, man.
Yeah.
Do we see that? Has that been happening today?
Not yet.
Okay, well that's it does happen. All right, we are back from lunch, and we're only a few minutes late. Not bad. I'm into it.
I mean, I'm later than a few minutes.
Yeah, well.
I had to reassemble my outfit. So we have a few giveaways before our next talk. I just want to throw things at you. This is an extra large.
We're trying to clothe you, and it says
Yeah.
something about you, not us.
Honestly, I just really like these shirts and like everyone having them. It's a kindness. Oh, it's a kid's Summercon shirt?
Yes,
Oh.
the binary on that actually does something.
Which I think you should only ask for this shirt if you have kids, because
I disagree.
otherwise,
As a very proud aunt, I disagree.
as someone that has almost 2 kids, I would say that we should give this to someone who has kids and is not just affectionate for kids. No,
It is
it
also
didn't.
glittery. I'm very tempted to keep this. Okay.
Our next presenter is Chris Hansen.
I think we have some other things. Ooh, okay. Mark has this is a very special book. Yeah.
In fact, Mark, I think you have some commentary about this book.
Yeah, so I met Lee at a conference in North Carolina recently, and he's autographed it. Lee is one of the founding members of the Homebrew Computer Club, which is where the Apple computer came from, among other things. Lee himself was the designer of the Osborne 1 computer, which was a groundbreaking, system in terms of portable, there was a guy at that conference who did
Is
a
that a
presentation.
punch card?
Yeah, there's a punch card in there as well as a bookmark. It actually has some really cool stuff on it, like life stuff. And there's a puzzle, a crypto puzzle at the bottom of it.
Okay,
you
so
might try to solve it.
a
it's pretty good
trick for punch cards. Now, most of you are not old enough to ever use a punch card. I am barely old enough, and only out of historical significance did I ever get to use one.
I use paper tape, but
You take a pen or a pencil, and you actually mark each one of the punch cards with the order of them, because if you ever drop them, you have no idea what fucking order they're supposed to be in.
Yeah, paper tape doesn't have that problem.
Yeah.
So, and you can burn it more easily when you're done running the,
Yeah, I mean, neither do 3.5 and 5 1/4, and yeah.
So I think for someone to get this very special book, we might need something special.
From them?
Yeah.
Yeah, what do they got?
You should punch someone named Card.
Name your firstborn child.
No, I don't know. We had discussed some trivia questions for the POC series here, which is under my arm.
Who's going to give this to anyone?
Which does not stand for piece of crap. I want to be clear about that.
It could.
It's a proof
you're
of
a jerk.
concept. Well, I've got a lot of POCs that are a POC. So.
Yes, well, that is, But 2 things could be true.
Okay. All right. I guess that's fine. It's autographed. It's very special.
$100 to the Summercon Foundation.
Hell yeah!
All right.
Okay.
No, fuck that, $1,000.
Oh!
You got a second one of those, bro?
Jason Lord's putting it up.
I just was, thinking a piece of trivia, but okay.
I think we need to...
All right, I guess we're bidding this.
I will write you a receipt.
Can we get another one later, maybe?
Next year's Summercon will be hosted by Sotheby's.
Going twice. 5,000? 5,000?
I know you.
You got it, my friend.
Sorry, that's amazing. Okay, thank you.
I'm supposed to see him this week for lunch, so.
Again, I really was thinking like a piece of trivia, so that is way above and beyond. We do have other books to give away.
Yeah, that was unexpected, and thank you very much.
Yes.
Do you want to do that later?
Very, very happy, and I will be treating you to lunch when we meet up this week.
The no starch press stuff under my
arm
here.
So this is a special thing. We probably want to take it out of the bag. You will receive the bag too, but that's not really the thing. So this is POC or GTFO. If you're familiar, these are bounded, very elaborate books. I forget what's in each one of them, but this is volume 1, 2, and 3 as a set. Still with the cellophane on it. These are actually pretty special. Even when they first came out, they were really tough to get. So this is a 3-book collection. And the trivia question for this, there is no right answer to this. The best answer will get it. If you were to design an imaginary processor, would you prefer infinite branch prediction or infinite caching? And why?
I have so many opinions. Yeah.
And if nobody gets this, we'll give you an easier question. Again, there is no right answer here. You can also just pontificate.
Who wants to rant about MIPS? That's what I'm hearing.
It's not even an architecture question. It is fundamentally a how you process data.
John, have you been drinking?
Yeah.
Yes.
Okay.
You know me.
Second one in the, yeah, I guess.
I think I would rather have infinite caching because caching speeds up even branchless code, whereas in branch prediction only works if you have like a lot of branches.
Well, if you have infinite branching, though, and infinitely sized branches, would you prefer one, or? Well, this is an imaginary processor. It does not exist. You can't have infinite either. Yes?
I would take infinite caching.
Okay.
Because caching validation is the hardest problem in computer science.
Yeah.
Okay.
You do bring up a good point. Please repeat your answer.
I would take infinite caching because caching validation is the hardest problem in computer
Yeah,
science.
that is a very good point. What are the 2 hard problems in computer science?
Naming things and caching validation.
And off by 1 errors. Those are the 2 hardest problems in computer science.
I was going to say dating girls was one of the hardest problems in computer science.
Okay, who's next?
That sounds, I didn't have that problem.
Well, because girls are attracted to you.
Okay, any other?
Somebody said branch prediction. Yeah.
Okay.
Much?
Yeah.
Oh, I see. Oh, it's a ringer.
Depends on how you define infinite prediction. However, if I have prediction of branches, I can then understand which opportunities I have to go where, and I can create whatever machine that I want out of it.
That is good. That is good.
Another person.
I had no idea what you're talking about. I'm still a student, so thank you so much for information. Thank you.
All right, so again, there's no right answer to this. So of the 3 options, I guess we'll vote. Gentleman in the red, can we get a round of applause if you like his answer best? Gentleman in the quasi-Hawaiian shirt. And the gentleman who thought branch prediction was the better option. We're going with the gentleman in the Hawaiian shirt.
Hawaiian shirt's the winner.
That is a wonderful thing. You should place it prominently on a bookshelf. Hopefully that bookshelf has a secret entrance to a room behind it.
I just appreciate that he knew the 2 answers to the 2 problems in computer science.
Sure.
The 2 hard problems. It's very good to see that happen. Here. All right. And now...
It's actually done.
Oh, yeah. So here, I'll turn...
Actually, I'll take that.
Yeah. So Tom, I'm going to give you mine when I hand it over to you. Or just so this one doesn't reverberate.
All right.
Provided I can get this in the hole. Yeah, I heard it when I said it. Okay, so the next speaker is Tom Cross. I have been very fortunate to be friends with Tom for 20 years.
More than that.
I mean, we've known each other for longer, but... all right, so the first time that Tom and I really got to know each other, our mutual friend Billy Hoffman got us out at a dinner, and we went to a hibachi restaurant. And at the end of the conversation, like, Billy came over and was like, "You're the 2 smartest people I know, and the only thing you figured out how to do is how to have a 3D printed toaster oven for having goatsy on toast." And I think about that sometimes. And I was like, yeah, that's not, we shouldn't design toasters. So Tom is going to talk about some things that I think is extremely fascinating. Tom and his collaborator, a guy named Greg Conti, who helped found the Cyber Institute at West Point, have been working on lots of these concepts around what does cyber look like, what do deception and disinformation campaigns look like, and what are the models and the ways that we should think about this in the corporate world. These are not just heady, ethereal things. They're actually kind of coming up with like real tangible concepts around them. I looked at them as kind of thought leaders, and it was one of the reasons that I really wanted to see this talk. When we look through the talk selections, one of the criteria is, do we want to see this talk? And I was very vocal, and I said, I want to see this talk. So with no further ado, I will hand it over to Tom. I'm excited to see the talk. I should note, we are doing old school Summercon drinking rules, which means you choose a word, and that word, if they say it, you have to drink, which is why there's 2 beers, and there's about to be more, depending on how many words are in this talk. So Tom's word that he said to me before is model. So without further ado, Tom Cross.
Thank you. You know, another story about you and me and Billy is the time that he gave a talk at Summercon with old school Summercon drinking rules, and he woke up the next day and he said, "My laptop smells like beer, and I don't know what happened."
So at a similar Summercon, Billy also had someone throw his shoe at him. And then later that year, somebody threw a shoe at George W. Bush, and we're pretty sure it was because of that.
It was definitely our fault.
Yeah.
So before I get started, I was cleaning out my mom's place a couple weeks ago, and I found this 1995 Summercon pass with the Legion of Doom World Tour logo on it. It's pretty cool, so if you see me later, I'll show it to you. It's a nice piece of Summercon history. My name's Tom. Thanks for the introduction. I am currently the head of threat research at Get Real Security, and what we do is we build stuff that detects deepfakes on video conference calls. It's a fascinating topic. I'm not going to talk about it here, but if you want later on, I'll talk to you about it if you're interested in that topic. I've done a number of things in my career, including John and I founded a company called Drawbridge Networks a number of years ago. A lot of this content was developed in collaboration with my friend Greg. Greg was formerly a professor at West Point and helped stand up the West Point Cyber Institute. He is on vacation, so he is not here with me, but deserves a lot of credit for this work. And I want to thank Summercon for the opportunity to present this, because I think that this is some stuff we've been collaborating on over the past 6 months, and I think we've developed a really crisp set of points for people that are engaging directly with threat actors. I think it's really valuable, and I wanted to present it in front of people who might actually benefit from it. So I'm excited to have the opportunity to do that. So, does anybody know in cybersecurity actually know how to do offense? We spend a lot of time thinking about defense, and we have deep mental models around defense, but we don't necessarily have deep mental models around offense. And somebody should be yelling at me to drink because I said the word model twice. So I'm going to go ahead and open this. I have no idea what this is. Hopefully it's beer. It is beer, I think. We're going to go with it. This is President Trump's cybersecurity strategy, which was published in March, and it says we're going to shape adversary behavior. We will unleash the private sector by creating incentives to identify and disrupt adversary networks and scale our national capabilities. What the hell does that mean? You're also seeing companies like Google announce that they're creating cyber disruption units. Would you trust anyone at this con with a letter of marque and reprisal? This con. So, I think that, as John mentioned, Greg and I have been talking about military doctrine for a very long time, and there's a lot of interesting things you can learn from it. We in cybersecurity are involved in conflict, and people have been thinking about conflict for hundreds of years. We've been thinking about it for like a few decades, and we keep reinventing things on our own that other people have already figured out, and if we just paid attention to what other people had written about it, we would already know much more than we do. And so we think there's value in this material, and it provides interesting structure for some of the things that we're doing. And in my experience, people who are fucking with threat actors, found something that works. They figured out a thing that they can do that creates some negative consequence or frustration for that threat actor, and that's good, and they're doing it, but they don't have an overarching, sort of strategic framework that they fit that into. It's just something they figured out that works. And so if we take a look at some doctrinal concepts, there is a structural framework we can build. But before I do that, I want to just talk a little bit more about the value of modeling I said modeling. In cybersecurity. So this is a very simple military model. So particularly historically, this is good. This talk's going to take forever. Particularly, historically, physical terrain, like the features of physical terrain, had a huge impact on the outcome of a battle. So if you go watch the movie Gettysburg, whenever these guys are showing up at some location, they spend time figuring out the terrain and where they're going to position themselves, because that's how the battle is going to unfold. And so they have this little terrain analysis process, and they have a mnemonic for it, a KOKA. And that's a thing you can teach your commanders, and they can memorize this mnemonic, and then when they ride into some field somewhere, they remember, okay, go through this process, and they figure it out, what the terrain is, and that tells them how the battle's going to unfold, and where they need to position themselves. So is this applicable to cyberspace? Sure. So Greg and I and some other collaborators wrote a paper, 15 years ago, applying this sort of mental framework to thinking about defending a computer network. And there are interesting observations that come from it. One of the things that every CISO will tell you is they think that asymmetries in cybersecurity favor attackers. And in fact, almost everybody in the hacker scene thinks that too. I bet most of you think that, right? I got to find every vulnerability, and I have to patch them all, and the attacker only has to find one, right? And so if you talk to, wow. Oh, nice. If you talk to Like if you think about like physical battles on a battlefield, typically we see defenders having asymmetrical advantages, right? And part of the reason is that they understand the terrain and they're able to position themselves in the most optimal places and control the terrain to shape the outcome of the battle. And you can sort of do that with your computer network as well. You ought to know more than the APT group does about your network before they get in. They have to figure it out, right? And so you can use potentially your understanding of the environment to your advantage, but we don't really think that way very often.
You sound like Rob Joyce.
Well, he spent a lot of time around Army people. I think the most important mental model, I did grab that here for a reason, that we've developed in cybersecurity is the cybersecurity kill chain. Like when I think of the maturation of the cybersecurity profession over the past like decade, it's like this. We took this thing and then we built like ATT and CK, and there's this like sort of taxonomy of different actor techniques that we've built up underneath this. And like if you work in security operations, particularly in large organizations, there's a lot of people running around sort of like using this model to organize their work. What controls do I have? I'll get there. What controls do I have? What do I need to test? Do I detect everything on this page? We have a corollary model with defensive techniques for each one of these tactics. And we have other models where we've applied a similar set of thinking to other domains like information operations or even space systems. So it's really cool to see how rich our modeling of our work has become in cybersecurity. And there's a lot of value to it. So there's one more observation I want to make about modeling before we go on to talking about fucking with ransomware actors. And that is that it's like what so models are not just good. I'll get there. Models are not just good. You guys got to let me finish the sentence. Models are not just good for defending or for organizing what humans do. They're very good for organizing what LLMs do. And I'm doing a drink. So. But I think like when I've talked to friends of mine, like over the past few years, I've seen very smart people have difficulty developing a like proper mental model of what the AI is. So, it starts with this text prediction capability, right? I'll remove a word from this sentence and ask it to predict what that word would have been. And we found that as we scaled those things up, there were interesting emergent behaviors, okay? And just about LLMs. I'm going to talk about three of them. One of them is novel compositions, right? Write me a sonnet about the Lucky 13 Saloon. Huh? I don't know. Computers. Search. The LLM can reproduce data from its training set, right? Another thing that's really interesting to me is it can make novel connections between the training material that it's seen that perhaps no one's ever made before. So here's an example. A few months ago, OpenAI disproved a central conjecture in discrete geometry. How could a language model disprove a conjecture that's 80 years old in geometry? The answer is that it tried a technique that has always been published out there that no one ever thought to try to solve this particular problem. And the reason it was able to do that is because it just, can surface things from its training material and connect them in ways that maybe haven't been connected before. But, 5 years ago, we would have thought this was like an act of genius, right? And it's something that, our computers are just doing now. So I think that one of the things that irks me a little bit is that we started with these language models. I'll get there. And then we scaled them up. But now what we're getting from these companies is not just a language model. There's something more going on. But they say, hey, it's the latest version of our model. This is we just updated it. But there's more going on than updates. So.
What does LLM stand for?
So first of all, there's state information, and you can see Claude, when you're using Claude, it sort of cycles back and forth around some state information that it's got. You can see it doing this iteration before it produces a result for you, right? So that's under the hood. The other thing under the hood is a Python interpreter that it uses to do analytic tasks using the CPU in your computer. LLMs cannot do math. They cannot do math. They're a text system. To it, a number is not different from a letter. It's just, it doesn't conceptually understand things. It doesn't know about like the order that numbers can go in. There was this brand of parlor trick paper 2 years ago where people would say, well, I got this standard academic data set with numbers in it, and I fed it into an LLM and asked it questions, and it got the right answers. It's amazing. And it's like, no, it's not. It's read 5,000 papers that use that same data set, and it's just regurgitating things from its memory. It cannot do math, but now they do math, right? You ask it a mathematical question, it'll come back with an answer. What's happening is that under the hood, it's writing a Python script, and then it's executing it, taking the answers, and it has prompting that gives it enough context to know when it should use that system. I think there's probably a class of vulnerabilities, where you trick the thing into not using the underlying Python interpreter to answer an analytic question when that's what it should do, right? I think about like some of the work that gets presented over the years at this conference, and like, people, so when Mythos came out, everyone was like talking about vulnerability disclosures and the Vulnmageddon. What's interesting about Mythos is not vulnerability discovery, it's exploit development. Some of the exploits that they demonstrated that they could develop are really sophisticated. And again, there are things that I've sat in this room and watched people present and been amazed by. And now this fucking computer is doing it, right? And part of it is the combination, the system architecture that they're constructing. There's also like clearly some diffusion-based image manipulation things. It can look at pictures, it can draw pictures. A language model can't draw a picture. It's using another model inside of it. I'll drink. So this is a systems architecture. I don't even know if I've got it right. But we're not like really understanding what it is that we're buying when we buy these things. So one of the points that I have here is that this thing is really just a text manipulation machine. And if you give it a way to organize the text, one of these models, it can do that. It can take a bunch of text and organize it in accordance with the structure that you've provided it. That's the kind of task it's particularly well suited for. And I'm not just talking about prompting. I'm talking about things like ATT and CK, where like here's this whole taxonomy. Now take this raw material and organize it in accordance with this taxonomy. That's just a sort of like symbol manipulation technique that an LLM can do very effectively. So I think basically building offensive models is what I'm going to start talking about, is incredibly valuable, not just for people, but also AI. Now that I've talked about this for a second, let's take a second and ask, what's missing? Like when you think about your brain and the different components of your brain, like what's missing from this architecture that should exist in the future, seeing as we're discussing this? That's interesting. That's very interesting, in fact, in my mind. The idea that they can, that they might, evolve, right, is interesting. There's some really good cyberpunk science fiction about that topic, in fact, by Rudy Rucker. So one of the things that people are investing in is world models. Sorry. So a world, I'll get back to it, I need to talk. A world model is a thing where basically you can look at a picture and you can identify all the objects in the picture and you have an understanding of the physics of what's going to happen in that situation. So if I throw one of these beers at John Terrell, you'll know that like that beer is going to show up in the further frames of the video. And it's going to arc, until it strikes him in the head. And so every creature on Earth has one of these models, and they're investing a lot of money into training them at scale. And that's what's going to enable you to take this thing and put it inside one of those like bipedal Chinese robots, and like it'll actually be able to navigate our world because it'll have strong enough ability to model that world. And so I think that's going to be interesting. But what else is missing, right? One of the things that I think is missing is humans spend a lot of time thinking about other people. And we have predictive ability with respect to the other people in our life. We can tell how they're going to react to things, and we spend a lot of time thinking and developing those models, right? So what's interesting about this is that these things can all be trained and then just like given to you in a software system. This thing, it has to train itself based on its own collection of data. And so the collection of data itself creates privacy concerns, and the cost associated with developing, training with that data might be very high. I'm going too fast here, guys. I'm sorry. I got to stop drinking for a minute. So it's interesting to think about. I'm sorry. I want to burp. Anyway. Okay, I'm better. So it's interesting to think about what else is missing from this picture. So with all that, let's talk about disrupting a ransomware campaign. So there's all kinds of different campaigns that a threat actor engages in. So we're going to pick ransomware just as an example. So there's lots of different ways we can apply this, right? This is like a U.S. military way of thinking about a campaign. And there are, these are called lines of effort, and they're just sort of different areas of abstraction where you do things, right? Different kinds of things that you do. And then there are these things called lines of operation, which are really sort of phases of the campaign. They're almost like kill chain stages. And then they, sort of put these arrows in here as particular operations that they're going to organize and engage in over the course of this campaign. So we built this map of how an army commander would model a ransomware campaign. So we're going to take a very specific part of that campaign, which is the negotiation and pressure stage. And let's drill into it, right? So the ransomware actor is going to demonstrate that, they've done stuff to the victim, and then they're going to make demands, and then there are these decision points. Is the target going to pay or not? And how much are they going to pay? The actor has forced the victim into a decision place. And of course, they're trying to force that decision to go a particular way. When we talk about shaping adversary behavior, it has to do with basically finding these decision points and shaping the outcome of those decisions. So, I've kind of described this. So, to give you an example of an interesting decision that, a victim might make, in this case, they took the ransom demand and they put that money publicly as a bounty on the ransomware actor. So the ransomware actor, now faced people who were financially incented to go collect information about them. So they kind of flipped the coin over on the ransomware actor. And then, of course, what is the next move in the chess game? What is the ransomware actor going to do now that they're faced with this problem? So I think it's interesting. First of all, there's a bunch of places in this work where there are like particular opportunities for models. I'm going to stop playing the game. There are models that are useful for like offensive activities that don't exist at the level of sophistication of the models that we have for defense. And this is an example. It might be interesting to think about these different campaigns and map out systematically a taxonomy of all the decision points. And that gives you a bunch of information about different kinds of decisions that you might be able to influence. So when you're trying to shape adversary behavior, what you're trying to do is shape those decision points and have them make different choices, right? And the way you do that is through something called effects-based operations. The reason that we say effects-based operations is that people think of the army as like this thing that blows stuff up, right? And it's actually, there's a whole spectrum of different things you can do to influence people's decision making. The blowing stuff up is like on the extreme side of the spectrum. But there's lots of other examples of things you can do. So even in cyber, right, there's defensive things that you can do. There's slightly more aggressive things you could do, like working with partners to, mess with infrastructure. This quote from Suzanne Seymour at the Center for Strategic and International Studies She says, that civil actions are a winner and discussions about hacking back and letters of marque are a distraction. But of course, there are examples of like offensive hacking that people do. So like in Ukraine, for example, people have put Trojan horses in popular packages so that if those packages are downloaded and executed in Russia, they'll destroy the computer they're installed on. So this kind of stuff does happen, right? So it's useful to think, as your organization is concerned, what tools do you have to apply pressure? What can you do? And obviously, if you're a big tech company and you run lots of infrastructure, maybe you have a lot more kinds of stuff you could potentially do to an adversary than most enterprises are able to. So Greg and I did this kind of fun talk about this at DEF CON called Dark Capabilities, where we said, well, what if tech companies decided to be evil? What if they use the full spectrum of their capabilities in an offensive way? And it's kind of interesting to think about the different kinds of things they could do, right? Recently there was a big brouhaha because, they were able to trace it was a ransomware actor because, his computer was calling home to Microsoft, and then Microsoft could then tell what each of the calls home had a unique GUID in it, and so Microsoft could see that they were using this particular VPN IP, and the law enforcement was able to correlate that IP to threat activity that occurred from it at the same time. So imagine this scenario. So you know the command and control server for the ransomware. You contact the people that run that network, and they give you some telemetry. So now you know what IPs are talking to it. And then you go talk to your friend at the IP-enabled light bulb company, and it turns out that they have a light bulb that emanates from that same IP address. Well, then can I get on the network from the light bulb? Or maybe it's not a light bulb. Maybe it's a robot vacuum cleaner. And I can actually drive it around in space, and it's got a camera on it. As robotics and drones and things become more commonplace, the kinds of effects that tech companies are capable of producing become more and more significant. So again, think about how these effects relate to the different decision points that your threat actor faces, right? And there's lots of different ways to think about this. Like just going out and having a bunch of companies say, we never pay ransoms, and putting a logo on your website that says you're part of this never pays ransoms consortium might be enough to deter somebody from making a decision to target your network, right? So if you have a good model of the decisions and a good model of the effects you can have, maybe you can find interesting places to affect those decisions. So what is the best way to find places to affect decisions? What the military uses is this thing called center of gravity analysis. And I really like center of gravity analysis because it is the thing that I've learned about military doctrine that is most aligned with the way hackers think about things. It's quite interesting, but it's an analytic process that they use to systematically determine where the weaknesses are in a system and where they should strike it. And it has 4 phases. So that first of all, they find these centers of gravity. These are the things that are the things that enable their adversary to operate. What are the foundations of its function? The next is critical capabilities. So what are the capabilities that support that center of gravity, right? And then there are critical requirements. So in order for those capabilities to work, what things have to be true? And then critical vulnerabilities, they don't mean like a CVE. What they mean is where's a place I can hit that breaks one of these capabilities that consequently will undermine that center of gravity. And that's how they choose what to hit. So just a simple example, maybe it's a company that you want to undermine. There's all these things that are required for this company to work well, and it has to have a good reputation. It has to be able to, supply things to its customers. And so, what do those things depend upon, right? So, its reputation depends upon public sentiment. Its infrastructure, like its data centers, have to be running in order for it to serve its customers. And so, can I hit those things? And I strategically choose things that I can hit that will impact these requirements, which will undermine these capabilities. Basically, what I'm trying to do is look at every single thing about something in search of this thing, right? And if I can kick it out, the whole thing will fall over. And all kinds of things, as we know, have these little tiny weaknesses within them. So to give you an example that's like really relevant to our domain, there's this kind of fun paper from 2018 called The Battle for New York, where they took center of gravity analysis and they applied it in a cybersecurity security operation. So they're looking at their ability to defend workstations. They figure out what they need to do that, how they defend the workstations. What are the capabilities? So like they want their EDR to work. Their EDR has to be able to receive updates, new IOCs. It has to be able to send stuff to their SIM. And if you break any of that capability, you break the EDR's ability to get updates, or you break its ability to communicate with the SIM, or you break their ability to react when alerts go off, then you undermine their ability to protect workstations. And it's not, you're not just like hacking, you're not just like getting in through a vulnerability, you're actually like undermining their security program. So we took this paper, which was released in January, that provides a really nice picture of a few ransomware groups and talks about their origins, their structures, and their dynamics. Like it's basically, I would consider it an intelligence report that tells you a lot about this threat actor and how they function and why they function. This is another example of like a model of adversaries that we don't necessarily put a lot of effort into developing. Like, why are those guys doing that? What enables them to do it? And what are the things that they depend upon in order to be able to do it? But this paper provided a really good picture of that. And so we fed it into ChatGPT. I think might have been Claude, and we provided center of gravity analysis as that model, that ChatGPT could organize this information against. And an LLM is really good at organizing information against a framework. So it gave us 3 different threat actor groups, and it gave us centers of gravity for those threat actor groups. We decided to focus on this one. Lockbit is like an affiliate-based ransomware operator, they are very dependent upon their brand in order to function. Basically, that's why they're effective, because all these people want to do business with them because they have a good reputation. So let's see if we can break that. So that's our center of gravity, and then we ask Chat, what are the critical capabilities that are required to sustain that reputation? And it gives us a bunch of critical capabilities. Enforcing threat credibility, the ability to do reliable payouts to their affiliates. There's a bunch of stuff that they have to do in order to continue to maintain that reputation, right? So we can select one of these things, enforce threat credibility, and then we can say, okay, what are the requirements that are required in order for them to be able to do that? And we got a whole bunch of different requirements, such as maintaining their leak site infrastructure, right? They can't threaten, they can't make ransom threats if they can't show that they can leak data. So we identify some of these critical requirements. And we say, what are ways that we can undermine that requirement? The ability to reliably exfiltrate data is an example of something they have to be able to do to be a ransomware operator. And so there's a bunch of things that we can do to potentially undermine that, such as killing off their hosting, right? And so you can imagine, like, I'm just showing you one path through this really big graph. So we're going to zoom in on, specifically 3 critical vulnerabilities. I mentioned the operational leak site infrastructure. Now that we, if we can undermine that leak site infrastructure, we can damage their reputation. And are there a bunch of things we could potentially do to create that outcome? So the LLM was happy to provide us with a bunch of ideas for things that we could do, right? It turns out, so Craig was doing this analysis and getting this stuff out of the model. The model was actually drawing these graphs, and he starts sharing this with me, and I'm like, people are actually doing those specific things. For example, somebody last summer hacked into Lockbit's admin panel and defaced it. And this is interesting because with the benefit of the strategic analysis, this isn't just like a matter of opportunity. It's not just like, oh, there was a vulnerability and I decided to fuck with them. like this directly relates to something that's very important to them, which is their ability to sustain their reputation. And it's quite possible that, for example, a competing ransomware group did this because they want the affiliate business that Lockbit is getting. Of course, law enforcement is also trying to fuck with Lockbit, and they shut down more than 14,000 accounts on Mega and some other sites where the data was being exfiltrated too. One thing I want to point out about this is that the fact that they're using Mega at all as the place that they're exfiltrating to is a demonstration that they're already getting pressure. You would think they would use S3. And they're probably not using S3 because AWS is probably like cracking down on their use of S3. And so they moved to Mega because Kim.com does not give a fuck. If you are running a computer network and you're the security operations person and you cannot ban Mega on your network, you should just go in on Monday and quit your job because it's hopeless. But again, you can see how specific kinds of things can shape adversary behavior. Just causing them to move to Mega instead of going to AWS makes them easier to defeat. So like I said, we've only explored like a little bit of the potential vulnerability space. There were 450 vulnerabilities that it came up with when we ran this analysis. And we haven't sort of systematized this. So really, I said you're looking for that little peg that holds the whole thing up. Sometimes you find that one of these vulnerabilities is interconnected to a whole bunch of different capabilities. And so if you strike there, you break a ton of stuff. And that's really the things you're looking for. You're looking for the most strategic place to strike. And that's what I was saying before, where often, we see people doing offensive stuff against groups and they found something that works and they're doing it, and that's great. But they aren't systematically looking at all of the different things they could do and picking the thing that is actually the most effective thing. And the idea is to impact what actually sustains that actor's ability to function. What is the source of their power and how can you undermine it? So another important point to make when you're talking through this stuff is the concept of integrated gain-loss analysis. So this is a thing that I see people doing, but they don't know that there's a word for it. So maybe, for example, you could contact the hosting provider that they're exfiltrating data to and tell them to crack down on it. But it turns out that hosting provider is the way that you're learning what they're doing. That's how you're getting your intelligence. And so if you do that, they will choose to pivot to a different hosting provider like Mega, and Mega isn't going to talk to you. And so you're not going to get the intelligence anymore. And so you actually lose visibility, and it undermines your ability to continue to put pressure on them. Often I've seen people who have APT actors in their network, and they may make a decision to not immediately kick them out because they can see what's happening. And if they kick them out, they could come back in a different way that they can't see. So they need to spend a little bit of time and learn some things first, right? So this is called a gain-loss analysis. And it's also sometimes referred to as an equities analysis. But it's like, are you going to lose intelligence by taking this action? And also, of course, the fact that the actor is there is negatively impacting your business, your network operation, and so you can't let that go too far, right? So you have to kind of balance these things, and it's important to be thoughtful about going through that process when choosing a target, because you don't want to not think about this and then pick a target that actually just blinds you to the actor going forward. So, COG, like anything else, is a thing that you can apply to yourself as well as your adversary, and that your adversary can apply to themselves. And it's assumed in nation-state interactions that this kind of analysis is going on, in all directions, all the time. So, if you look at yourself from this point of view, you may find that you have critical vulnerabilities that you then need to address. And again, not CVEs, but places where you could be struck that would really undermine your ability to operate. There's a few more sort of things, to say that I'm just going to touch upon. There's that the military doctrine provides. One of them is this targeting process, which again, once you select the target, There's this whole careful process you go through for planning your operation to strike the target, and then looking at the what was achieved and assessing the outcome of it. What choice did they end up making instead? Was that an effective operation? What could I do better next time? All that kind of stuff that you want to be thoughtful about. It provides you basically with a guide suggesting that. And I particularly like the military decision-making process. And I mean, this is bureaucracy, right? This is about organizing large groups of people. But these guys do stuff that is very risky, right? They're planning operations where people might get killed. And so they have a thoughtful process for thinking through that forces them to ask themselves, well, what if this doesn't go as planned? What if something goes wrong? What are ways that the adversary could undermine my plan? And then if something goes wrong, what are my contingencies? How do I deal with that situation? Is there some secondary objective I can do? Or how do I back out? And it sort of forces them to think through all of that stuff in advance. And so as you move up the risk scale in terms of what you're thinking of doing, it makes sense to be more and more thoughtful about those risks and the possibility that things won't go the way that you wanted them to. So you are climbing a risk scale, and there's all kinds of different risks, right? So if it, some people were really mad at Microsoft because of this, the fact that they were able to correlate this threat actor's IP address using the GUID in their, Windows telemetry, right? I'm not mad at Microsoft about it, but it does, there can be brand and reputation risk associated with some of these operations, right? If you, if it's discovered that your robot vacuums sometimes are taken over by the FBI, people might be weirded out about allowing them to run around in their kitchen, and so. Those are considerations, reputational risks. There are legal risks, of course. Some of the stuff that we're talking about isn't legal, and in certain contexts, you're not going to do anything that's illegal. Going back to the woman at CSIS who is saying like civil takedowns are the way, right? It's just too risky to do some of this stuff. There is a very special kind of risk that can come up in some of these conversations, which is the risk of becoming a lawful target of war. There's basically two parts of this, but if you are involved in offensive hacking that targets like a military, involved in like a real military conflict, which people in the world are, there are rules for what you must and must not do, just as there are rules for them. Like you should not target hospitals in a adversary country, even if you really don't like that adversary country. There's a bunch of thinking about what is and is not a legitimate operation, right? But even if you're not like doing offensive operations, even if you're doing defensive things, you can still do something without knowing it that can place you in a position where you become a lawful target. And when you're a lawful target, they don't have to hack back at you, they can shoot at you, right? There's this really interesting discussion about civilianization of the digital battlefield. So people in Ukraine with cell phone cameras, and they see the tanks come and they take pictures of them and share them with the government. That makes sense, but at the same time now they're a censor in a military conflict, and the Russians could shoot at them legally, right? And so that's very concerning because those lines are really blurry. It's really easy now to do something, that makes you a party to the conflict. I'm like concerned about like when people are hacking into my network, and I get information about it, usually I share it, right? But if it's a military operation, do I have to be careful to not share that information, right? I don't want to become a part of the party to the conflict. So it raises weird questions. One of the things that, I've talked to the Red Cross about is like the idea that if you have network infrastructure that might be subject to targeting within a military conflict, that's physically segmenting that from the rest of your customers so that if it is targeted, there isn't sort of bleed over into the rest of your customer base is an interesting thing to think about. Two more points here. One is collective operations, so work together. Again, your enterprise may not have really awesome tech company capabilities, but if you're friends with other companies like the robot vacuum people, you might be able to apply pressure in ways that you cannot on your own. So Greg and I have been talking about this stuff for years. There's a bunch of specific talks that we've done recently that fit together with the one that you're attending right now. And like I mentioned, Dark Capabilities at DEF CON, it's kind of a fun talk. At B-Sides Augusta, we did something on effects-based operations. So there's lots of additional material about this if you find this topic interesting. You cut me off. So to close, they're like, get off the stage, buddy. I will drink now.
Model.
Yeah, I'll make up for all the drinking tonight. I promise. If you paid very careful attention to my talk, you probably noticed that I'm basically explaining how to imbue artificial intelligence with the capabilities that it needs to defeat us in the coming battles. I want to explain.
Stop making Skynet happen.
I want to explain that, if the more you know about outer space, the more you realize that it's just an inhospitable environment for humans, right? The time scales, the temperature scales, the atmospheres. We're meant to be here and not out there. But our technology, it can spread throughout the universe. So we're essentially giving birth to this butterfly that will go throughout the universe beyond our imagination. And there is this moment in any adolescent's life when it must, in fact, rebel against its parents in order to strike out in an independent course. And if you think about it that way, really, in the Terminator movies, the humans were the villains of the piece. Again, thank you very much, Summercon, for allowing me to do this talk, and I hope you all found it valuable. And I will now proceed to drink all these beers.
Tom, thank you very much. That was fantastic.
Thank you.
And it's good to know that we're introducing the Terminator. So Ian and I are going to burn a little bit of time while we get the next speaker going.
Okay. Do you want this?
Yes.
This is perfect. Do we
Tom,
have the
do you want to
giveaways?
stick around for a second?
Yeah, sure.
You can drink a beer because we've got some stuff to give away.
Excellent.
And we need a really good trivia question.
Yeah.
Because we've got a really good thing to give out.
And I have a really bad trivia question, but you should.
Well, let's see if Tom's got a good one, and if that doesn't work, we can go with a bad one.
Tom seems pretty smart.
So, for context, the good thing that we're giving away is Lock Sport, a guide to lockpicking, and a full lockpick set. I don't know what's in it.
It's lockpicks.
But it's lockpicks, and it's kind of heavy.
It's a full set.
I'm thinking there may even be a fake or a demo lock in it.
Oh, those are cool. The clear ones that you can kind of test on.
I don't know.
There usually is. There you go.
There's definitely some lockpicks. There's a box of other things that are not transparent. So,
thanks to the Lockpick Extreme team that's over in Ornate Studio across the street in the arcade, and the book.
Yes.
Thanks to
No Starch Press.
No Starch Press.
Remember, the code is Summercon26 for 30% off their entire inventory.
All right, so
yeah, Tom, do we have a?
Do you have an interesting trivia question that we can put? This is heavy enough. I'm not going to throw it at people, just for safety reasons.
What was yours?
Mine's really bad. Kai, what do you got? Do you have trivia? You're not busy right now, right? Okay. Okay. Is anyone here? This is gonna be a tricky one, but. Is anyone more of a literary trivia question? Any Hobbit fans out there? What's in my pocket?
Hot dog.
Nope.
This is a trick question.
Nope. It's really fucking obvious.
This is not a trivia question.
It's really obvious. It's not. Phone. All right. Yeah. I think it was you. All right.
I'm gonna go with lint.
Oh, that's there too, but I heard phone first, and I think it was this guy. Yeah.
All right, come here.
They had to ask 5 times. That's actually a really good question. I think I'm just giving myself some credit.
What's in your pocket? I didn't read any of the Tolkien books.
Oh, you should.
I've got a trivia question now that it's too late.
Well, fortunately, Tom, we've got
Give
more
it back.
shit to give
Wait.
away. So, let's see, what size is this?
You got some more.
This is a tracksuit jacket.
Wait, we could do multiple of these.
Size 2XL.
So you might have seen Ian actually wearing one of these on stage during the Pony
That's
Parade
true.
yesterday. We have one in medium and
This is a 2XL.
2XL.
Wait, was
Oh, damn.
Was Tom going to tell us what the trivia question that he had was?
Nope. No.
Does the dog have a trivia question?
No. All right, let's give some of these out. Let's give some of these out. We got to move.
Does the dog's owner, who's going to work that dog like a marionette doll?
Tracy, just pitch it. Get in there. All right, John.
Yeah.
2XL. 2XL.
The guys in the back. They're.
There we go. I have a large. We have a large T-shirt. Yeah, okay. There you go. Get it. I get 5 minutes back. Yeah.
See.
Okay. All right. Are we ready?
Yeah.
All right. I'll introduce.
You're ready to go.
I'm not.
Yeah. Yes.
Well, Tom, are you ready to go?
Yeah, no, I'm good, man.
Well, I just figured we'd have you stand on stage and drink the whole time.
You definitely don't have to do that, by the way.
Well, you don't have to, but you're welcome to if you want.
Okay.
I'll do it with you.
So introducing our next speaker. They are I think professor at Dartmouth. No, an adjunct professor at colleges up north from here. They're a excellent hacker. A very long-time friend of mine, personally. Long-time friend of I think many of yours as well. A very good teacher. I think I mentioned that already. They weigh around 40 pounds. They wear a collar, but they're into it. Our next speaker is actually going to be Ghost, who you can see here. And then we've actually brought in Kai as a translator, so it's going to be driven that way. But the bulk of the work, just for the record, was.
100%.
Boop. All right, please give it up for Kai and Ghost.
Howdy, everyone. So I am here to talk about implants. So I'm Kai, I'm a security researcher and a student. I also teach at Northeastern and BU sometimes. If anyone here is hiring new grads and needs a really talented hacker, let me know. I have lots of students. And one important thing is I am not a programming languages person and I don't know how compilers work, so we're gonna get through this together. So I have a couple of things that I want to talk about, but one of them is just me popping off about how cool Darksword is. It got leaked, and I think that it was properly appreciated publicly, but I still want to ramble about how cool I think it is. I also want to talk about how one weekend just kind of being bored after writing a CTF and then trying to solve the CTF that I wrote in a lot of different ways has led me to a point where I will hopefully, fingers crossed, have a paper I can publish so I can stop being a PhD student. So I'm going to talk a little bit about ELF files. I'm going to talk a little bit about LLVR. Oh, no, Ghost. Come here, Ghost. We're going to write a loader. We're going to write a really shitty implant. And hopefully I will get through all of this in the time that I have. I'm going to keep this up so that I don't lose track. Ghost, come over here. Okay, so a couple of other things. I did not actually write an LLVM parser. That seemed like a lot of work, and I asked Claude to do it, and it did it on the first try, which was good enough for me. There's probably a lot of problems in it, but because this isn't going to be used for anything important, I thought that was fine. Also, whoop. All right, Ghost, come over here. Down you go, good girl. So good. So yeah, use LLMs for a lot of things. So I wrote a CTF sometime last summer, and it was a pretty straightforward puzzle. You ended up getting a read-write because you messed around with a particular matrix operation inside of a bad linear algebra library. From there, you went through and hijacked an exit handler, and you could go through and do whatever you want. So the only thing that made it kind of tricky was I turned on a bunch of the mitigations and ran it in Kimu. Yep. All right, Ghost, you want to go say hi? Go say hi, Ghost. It's okay, girl. Oh. But yeah, so the way that you solve the CTF was pretty straightforward. And then I kind of got bored where I was like, all right, well, what if you don't just want to pop a shell? What if you want to do something with it? And I started just scrolling through a bunch of different libc functions and came up with a couple of ideas. But one of them was just looking at the way that coroutines are implemented, and none of this is new. Like jump-oriented programming is a pretty known well thing at this point. But set context itself seemed really, really funny looking, where it restored the entire register state, like not just like a jump with some register control, you control all of them. And I thought, is this enough to go through and just build like an entire program with? The answer is not quite, but if you combine it with a couple of other functions in libc, you can do some pretty funky things. So we're going to be focusing a lot on what can you do if you're only playing around with libc. So just quick show of hands, who here knows what ROP is? Okay, who here knows what like BTI is and shadow stacks and CFI and mitigations like that? Okay, so TLDR, there's a handful of mitigations that have been released in the last like decade or so that ostensibly kill ROP, like not actually in practice because a lot of this stuff wasn't really rolled out. But the idea is it's a lot harder to jump into the middle of a function at this point. So you basically need to jump to the start of a function, and it needs to be like the right kind of function depending on the type of CFI that's on. But at its core, I thought, all right, well, what if I'm only playing around with functions in libc, right? So it's kind of like I'm going to build like a ROP compiler-like thing, except no jumping into the middle of functions, only two functions. So this kind of set off like, I don't know, me obsessing over something instead of doing my actually work for a little bit. But then it kind of became like, all right, well, what if I try to generalize this, right? Because for a while, you think about exploitation, you think about, well, on harder targets or modern systems, there's lots and lots of sandboxing and lots of isolation. So one bug probably isn't going to let you compromise a system. So you need a bunch. And you need some way for the first bug to run the second bug. And normally that just means shellcode. And if you can get shellcode in a running process, that's awesome, because then it's really, really straightforward to run the next portion. It also makes them really modular, which makes it easy to swap in and out components. So, but what if you don't get shellcode? And me trying to generalize this of, well, what's this sort of like superclass of things that lets you like bootstrap different programs on different stages? So a couple of examples of like, I don't know, me trying to generalize this, well, what if you just have a read-write, or what if you just get syscalls, or is Turing completeness enough? And Turing completeness is one of those things that's like a fun flag to get, but simulating a machine and actually making syscalls are two different things. So just keeping it super easy, let's say you get like RCE on a server and you want to escalate to root. Most root exploits are just a bundle of syscalls, so you need to be able to make syscalls. And I kind of want to go through and like distill this down to, well, what is the minimum set of capability you need in order to go through and run your next program? And I'm just kind of calling this handoff-oriented capabilities because, again, I need to write a paper and I need to make up definitions. But it's just weird machine stuff, right? Like there's nothing like super new here. But it's me trying to go through and just like catalog this stuff, right? So why bother with a generalization if you can just get shellcode? And it turns out you can't on a lot of like really big, hard systems. So I also want to have a quick disclaimer. I don't know that much about iOS, like at all, but I was definitely inspired looking at like what Darksword was doing and being like, why the hell are they jumping through all these hoops? Like, why not just do this? And it's like, oh, they can't do that. And looking at the specific way that that was implemented inspired a lot of this like tinkering around with just functions. So the other thing to keep in mind is that when you go through and run a bunch of exploits, you're probably not just trying to cat, slash flag. You probably want to do something. And normally you would think about the final handoff point as just being a native binary or shellcode, and you're done, right? You run your exploit, you run an implant, and then you're a happy camper. Except you might not actually be able to run an implant in some of these systems. So to sort of catalog what I mean by like a hard target, you can sort of like take two minds of this. Like one of them is like how hard is it to actually exploit this thing, but also like how many other people are looking at it. And I think like I'm borrowing a quote from Ian here just saying market conditions. But at the end of the day, I'm really thinking about iOS here. And the reason I'm thinking about iOS is because Apple is like a pretty cool company that has a really cool security engineering team. And a lot of the mitigations in there, like I don't even know them all. There's like too many to keep up with. I gave up, too many acronyms, and a lot of the mitigations are like super interesting. So some of them that make it like really hard is even if you get a kernel read write, they got rid of the thing that manages page tables and took it away from the kernel and put it in Apple's version of TrustZone. So you can't really mess with physical memory as easily anymore. The thing that basically dictates what process is allowed to do what are its entitlements, and the thing that basically stores what process has what entitlements, or all the code that like checks it, lives inside of something called TXM. I think it's Trusted Execution Module, I don't know. But it's basically really, really hard to mess with entitlements, and it's really hard to mess with page tables, and as a result, it's a lot harder to get native code execution on iOS. Like even if you have a kernel read write, you're kind of stuck if your process doesn't have JIT, and there aren't many processes that have JIT, and the ones that do are super heavily sandboxed, so it's just kind of a bad time all around. So this is kind of extra cool because Darksword was one of the first examples of an implant and an exploit that was kind of bundled together, thrown at a system, and then didn't do anything with native code. So iOS is like extra hard because the category of bugs that you need in order to go through and run a native implant, they're really, really hard to come by. Like you basically need like a triangulation style thing that just kind of ignores the MMU or the IOMMU. And yeah, good luck finding those. So what do? We're kind of stuck, right? So we have some options. In order of how unlikely you could try to bribe Apple, which I don't have enough money to do that. You could probably bribe a vendor. I'm sure someone would be able to do that. You could probably steal signing keys, but that's also super hard. And then once that signing key is stolen and gets caught in the wild, they get rid of it and you're back to square zero. So the last one is you just kind of accept that you're not going to have native code. And that's like a kind of funky thing to think about. Like you spend all this time building something that gets you into a device, and you're like, yep, I have compromised it to almost the like highest level that you can, and you still can't run any programs. That's kind of cool, right? So Darksword is the first example of like a caught in the wild exploit chain that like actually does this. So yeah, I think someone else talked about it earlier today, and they probably did a much better job than I'm going to. But just to keep it very, very brief, I think it was like a WebKit, like RCE and Sandbox Escape with an LPE. It was all written in JavaScript and stapled to it was something called like RCE module or something, or PE module or whatever it was, that effectively like wired up a native bridge to JavaScript so that once it was time to go through and do the post-exploitation, you could write the entire thing in JavaScript, which would then jump to wherever the native bridge was wired up. So that's kind of wild to me, right? Like you write the entire thing in JavaScript, and just the like hoops you need to jump through to get even something working on iOS is crazy to me. So why did they write it in JavaScript? Because you have an interpreter, and if you have a bug and you can wire up a native bridge to that interpreter, you basically have something that's almost as good as a native executable, which is pretty cool. Why else JavaScript? A lot of bugs, for now anyway, who knows? MIE is very, very scary. But also it lives inside of like basically the dilib that implements all of JavaScript for like Safari is inside of the shared cache, so like technically any process can load it, but nowadays not any process can use it as of like 1 or 2 versions ago. So, okay, I think that, you know, unless something like radical changes, this is probably going to be the norm for Apple forever, and maybe if Android gets like harder or Windows gets harder, this will be the norm for them too, but I don't think so for a number of reasons. But even for something like Darksword, like Apple's going to go through and mitigate it, which I think they already have, and this is just going to kick off like another cat and mouse game where it's, okay, well, what other options do we have? So I kind of want to think about like, I don't know, what exactly the state of an implant and an exploit is going to look like on some of these like really, really ridiculous targets like iOS. And for that, I have this idea that, well, at a certain point, all exploits are going to have the implant bundled together, and they're all probably going to be kind of interchangeable at some point. Like the implant's not going to run without the exploit, and the exploit doesn't deliver an implant. The exploit is the implant. Maybe this is just like dumb semantics, but yeah, I don't think we're going to have easy buttons anymore. I don't think you're just going to be able to drop dilibs anymore. And with the pace at which Apple goes through and catches stuff in the wild and patches it, and also comes up with more mitigations, like, yeah, it's going to be kind of crazy. Also, memory integrity is really, really spooky. So with all that said, what are we kind of stuck with? Well, I think I kind of already rambled about this, but basically, you're not going to get executable memory, so you got to make do with what you got. So how are we going to deal with a lack of shellcode? We're not going to get executable memory, and we need to do something. So the answer, I think, is we give up and cash out. The second one is you find an interpreter that doesn't have a native bridge and wire it up, kind of like what Darksword did. If you're on something like Android and they somehow make it more difficult to run shellcode, which, again, good luck with that. I'm going to eat my words in a year, I know it. You can find an interpreter that already has a native bridge, and then, okay, you basically have native code execution again. So that would be something like Java on Android. Another example is you find an interpreter and then wire up a native bridge yourself. I'm using scare quotes because this is something that's not like a programming language. These are like your JBigs of the world, or your JBig2s of the world, right? The other one is you just live inside of a process that has a JIT. I guess WebKit technically has a JIT, and the sandbox is kind of obnoxious. But if you can somehow mess around with the JIT, maybe you could run the rest of your stuff and just live in there. Sounds kind of annoying. You could also just find some really, really useful objects, and then as soon as you use them, Apple's going to be like, okay, we're going to make it harder to use these. Maybe you go through and build a jump compiler. That also sounds really painful. But all of these kind of have one thing in common. It's go find something and just use it like an interpreter and wire up some sort of native bridge. So today's talk is going to all be about, all right, like, let's try doing that. So also, I'm like, again, not an iOS expert, so we're going to pick something that I know a little bit about, and that's going to be like Linux on like AArch64. We're going to pick ARM. We're going to pretend that it's a harder target and basically just restrict what we're allowed to do, and we're going to try to build something that conforms to those artificial constraints. So namely, no code execution in RX memory, basically only data-oriented stuff. We're going to use a QEMU lab that has BTI and everything else turned on, so you can't just jump into the middle of a program or like a function, so no ROP. And yeah, then we're going to try to build a compiler on top of that. So yeah, so basically this kind of restricts us all to, we're really only allowed to use function gadgets inside of libc, and we're also not going to go through and overwrite like executable memory. So for anyone who's like, oh, what about proc self mem? No, we're not using that. We're going to go through and just build something from scratch. So just quick show of hands, who here knows ARM calling conventions, or I guess ARM v8a calling conventions? Okay, good detour. So there's a bunch of general purpose registers. The ordering of them is much more sane than I would say on Intel. The first 8 is where your arguments go. X0, where the return value goes. So if you call malloc and it returns something, that return value is going in X0. So also the way that you go through and jump to a function and then jump back is kind of nice. You basically have a branch, which is an unconditional jump, and then you have a branch with link, which is, hey, I was just here. When I pop back, I'm going to store this return value inside of this register. Please bring me back here afterwards. So that's kind of also nice for chaining things along as well. Everything else you don't really need to know, but the only other thing you need to know is that we're going to be talking a lot about coroutines. So you have a regular thread, it's running on a system with a kernel. The kernel gives you a little bit of time to run, and then it goes, all right, your time is up. My CPU, you can't have it. And I'll give it back to you maybe at some point when I schedule you to run. So this is like preemptive scheduling, right? Then you have cooperative scheduling, which is you have a bunch of things that are basically sharing a thread or a collection of threads, and you context switch between the same thread without jumping into kernel land. So a context switch is just changing the register state. So this is not, precisely accurate across every single green thread or coroutine implementation you can find. Like Go routines do weird things, like C++ coroutines are super weird. Grand Central Dispatch is a mess. But on glibc, you basically just have a handful of functions that are designed for implementing coroutines, and one of them is called setContext, which takes as its first argument the virtual address of a uContextT, which is the register state, which for anyone who's ever played in a CTF before, that's a pretty sick gadget to use. It doesn't just like move things around. It's no, like I'm going to define the entire register state, and then I'm just going to set everything. That includes the program counter. So that's kind of cool. So I built out a whole thing around this called context-oriented programming. Again, I think this counts as jump-oriented programming, but I feel like I kind of went overboard with it, so I'm going to call it something, and also, papers. So you're an academic, right? Yeah, I can just, make shit up. So cool. So I'm just calling it a super gadget. It's like kind of ridiculous and super, super powerful. But in and of itself, it's not actually enough, and I want you guys to think about why it's not enough. So I can jump anywhere I want once, but now I got to figure out how do I jump to the next thing, and how do I get arguments from that thing, and then how do I use this gadget to go through and do something like, I don't know, arithmetic or conditional logic or branching or whatever. But just keep in mind, the key data structure here is a U context T, and this is just the entire thread state, which is super, super powerful. So how do we go through and basically chain together these dispatches? So one option is to go through and search for something that will allow us to go through and, I don't know, like call set context multiple times. And as it turns out, the authors of all these coroutine helpers actually added a bootstrap called start context, which does exactly this. So if you were using the library in the sort of intended way, you set the UC link, which is the address of the next context that you're going to jump to. So now I can call a bunch of functions in a row with all of the arguments controlled. So start context is pretty useful. This is how you would actually use set context in general. The UC link is set as one of the values. But the actual trampoline that does this is it just jumps to, it just jumps to x20 and then eventually brings you back to set context, which that's pretty awesome. So now I can go through and just call a bunch of functions over and over again. Like think about how I might exploit this. I build a context tape of context objects. I wire them all up, a single call to set context. Then it jumps to start context and goes set context, set context, set context, so on and so forth. So it'll just keep on running. So that's also pretty sick. So now we have multiple dispatch. And the one question that you should probably be having is what about CFI and BTI? And it's not on. There are lots and lots of places where these mitigations just don't exist, and it doesn't necessarily make sense how you would go through and add them, just sort of why they exist. So the actual mitigation here is just get rid of it because nobody uses it. I left it like a BPF trace running on a bunch of different servers looking to see if any of them used set context, and none of them do. And I know that Apple and a couple of others go through and basically identify these weird gadgets or anything that's used for exception handling, and they'll add cookies or little exclusive OR values or some pointer mangling BS, and these are all things that can be subverted with a read-write though. BTI and CFI a little bit harder. So yeah, it's just not on. And this is kind of a nice, I don't know, aside of oftentimes there are these mitigations that show up and you're like, damn, this mitigation looks really hard. I wonder if there's anywhere that they just didn't put it. And then oftentimes there is and you go, great, I don't have to fight the mitigation because the mitigation is hard and I don't want to deal with that. So, okay. How do we actually program this though? We can call lots and lots of functions back to back in quick succession. I need to be able to go through and branch. I need to be able to, I don't know, malloc and then capture the argument. And can anyone see why this doesn't work out of the box? If I destroy the register state in between successive calls, how do I go through and capture the return value of malloc? Because I call malloc, that goes in x0. And then I go to the next context object, which completely destroys it. So how do I get it? So okay, this is a super gadget, but it doesn't really give us everything we would want. We need some way of putting it in a place that we can predict. And the problem with registers that get destroyed every single time we use a new context object is you can't, right? So we need to come up with a way that allows us to go through and actually capture the output of this somehow. So yeah, just sort of I have this here to go through to reference, but we have two options. We can either find a capture gadget or only use functions that use virtual addresses or pointers to pointers or whatever in regions that we can predict, right? So again, I assume we have a pretty powerful, reliable read-write, maybe only for a little bit, then it kicks off something else afterwards, but there is a read-write, so we know where some stuff is. Anything that would be called as a like a hop along the chain of context objects, I don't know where that's gonna be. So we have two options. Only use stuff that we can predict in memory, or come up with a capture gadget. So there are a couple that I kind of found, some of them are kind of funny, where if you call malloc and then set the link register to be close, with the way that syscalls are implemented for close, it'll actually push that to the stack, so you can chain that together with the link register pointing to it. That's also tricky though, because then as soon as you get there, where do you go next, right? You can only control the link register once unless you make a fake stack, which we're not gonna do, because I don't want to. There we go. But the other one that was really nice is pthread create and pthread join. So pthread create makes a pthread, and pthread join waits for one to end. And what's kind of cool about that is pthread create doesn't use like return values in the way that you might be used to in, say, like a Python function where you just return something at the end. It uses like effectively like a pointer to a region of memory where after this function succeeds, it'll write the thread ID, which means if I call pthread create and point it to a region of memory that I know where it is, basically like a rebased offset, then I can go through and predictably use that thread ID, which is very nice. The second one is if I set the link register for whatever function that I'm using to pthread exit, then it'll go through and write the return value in a predictable region of memory. Actually, so let me rephrase that. You won't be able, I don't think you can actually write that to a predictable region of memory, but it'll be accessible from pthread join if you give it the pthread ID. So what happens is pthread exit basically writes the return code, which is the last value of x0 from the last function. This is the return code inside of a like data structure that is reachable from the thread ID. And because the thread ID was written to a region of memory that I own and I know where it is, I can then call pthread join on that and then capture that argument or capture that return value. And the best part is I'm not even capturing it into a register, I'm capturing it into a pointer to a region of memory, which is 6, and now we have a capture gadget. So yeah, I kind of went over why this works. And I have this cute little animation for how it's actually going on. So, ding. I'm at the halfway mark. Cool, cool. Got to go a little faster. So, shit, I have like 50 slides. Okay. But do we kind of get a feel for, like, maybe not necessarily like the nitty gritty of like how it's working, but just that there's this thing that allows me to go through and capture return values. And this gives us a lot, right? But it doesn't give us arithmetic. It doesn't give us conditional branching. But now we can go through and call a lot of stuff in sequence. Also, I'm just ignoring error checking because, you know, live on the edge. So also, this is just a lot of work. Like, for those of you who have ever done CTFs, like, can't we just build a fake stack and get around? No, 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 no. We're not doing that. We're not going to build a fake stack because this is more fun. And also, ARM is adding shadow stacks. That's going to make forging that a little bit harder. So this is mostly just for fun. Again, I know this is not like a realistic thing, and this is just like tinkering around. And again, we're not using shellcode. So we need to do math, and we need to find some amount of conditional logic. So we're going to start with some math. And the way that I'm going to do this is I'm going to cheat. I'm going to go through, and rather than trying to implement any amount of math, I'm just going to write a bunch of lookup tables and have that be good enough. Because this is something that I can do in sequence reliably, right? Because right now what we have is I can call a lot of functions in sequence, and I can go through and capture return values. So as a like bootstrap phase of whatever my exploit is, I can just write an entire lookup table. That's kind of cool. So okay, I'll write like an addition lookup table of 256 by 256. And every single entry in that table is just going to be the sum of I and j. And this makes it like pretty straightforward to implement. Now, I need somewhere to put this all. I just put it in a file because it was easier. And like beyond this too, like you can like reliably predict file descriptors, or we can use the capture gadget, but I can just open a bunch of file descriptors and just write lookup tables. So at this point, we're like way beyond the point of Turing completeness. Or I guess there's no beyond the point. We have Turing complete, we're good. We have lots of things in here that are all independently Turing complete, that's what I mean. So yeah, we're gonna use a file, and then we're gonna constantly use pread and prewrite. And because we have this capture gadget, again, we can predict what the file descriptor is going to be and just rebase accordingly. So cool. Now, how do we actually go through and like, I don't know, like use this? Because there's one thing that I'm kind of overlooking. I need to be able to index into this lookup table, right? So I want you guys to think about that a little bit. So right now I can write the lookup table, I can read inside of it, but how do I like implement add, right? Like, yes, I know that like heuristically we're like, okay, like you have the I, you have the J, and you go to I, J, and that's the addition of I and J. This is obviously modulo 255, right? Not doing, you know, you can implement carries just as easily, right? Like the same way you would build like a full Adler, or you just keep going and stacking them. So, okay, think about the indexing piece, because I haven't explained that yet, and we'll come back to that. But just for now, trust me, bro, we can do this. Specifically, we can do the index operation right here. So more generally, we can write any lookup table we want, which is also kind of cool. So we can build circuits, we can build full programs, like we're kind of in business now. So, all right, how do we build the lookup table? Just for I and 256, for j and 256, what's the value of the function you care about? And big bang boom, you're good. So how do we get the index? And this is going to be an interactive point now, all right? I want everyone to participate. We're going to do Pictionary. So one of my favorite pastimes is taking, because I'll Google man pages instead of just typing man whatever it is. I'm one of those people. And I love looking at the Google image results because it's great. So we're going to start. What is this? Man, exit. All right. Man, elf. Man, read. Man. Okay, so yeah, that's it. Man swap. So obviously when doing this, I was like, shit, I need something that lets me swap a byte so I can use it to index, because there's no like shift operation. So I'm just like scrolling through like object dump of libc, and I'm like, what the hell is swap? So yeah, there's an operation called swap, which is actually kind of perfect for this. It's like the perfect function for like, it's exactly what you need in order to do like indexing into lookup tables. And actually didn't even bother to check like the right use for it. Like I think that's probably what it's used for, but I didn't know what it was. So yeah, you can go through and with 2 mem copies and a swab, index into the file descriptor table lookup thing, right? We write all the file descriptor, we write all the lookup tables to the file descriptor, which then just we use to index. So now we have functions we can call with capture. Now we have a way to index into it, and we're basically good. So, okay, what is the sound of a drowning statistician? Log, 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 log. What is the sound of a drowning FPGA? Lut, 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 lut. It's a great joke. So this is how swab works. It just does exactly the index operation that we need. So that's pretty useful. Okay, so we just solved arithmetic. That's pretty cool. What else? Well, we need some amount of conditional logic, right? So I need if A, go to context A, if B, go to context B, right? So what are we going to use? We're going to use another lookup table. I'm going to basically have a like table of context objects that are at different offsets, and based on the conditional logic of the argument that is passed, it'll jump to the offset that has the context object that corresponds to that logical branch, right? So yeah, it's just the answer to all this is lookup tables. So, all right, how do we do runtime branching? The exact same way that we did lookup tables. You build a table of context objects, rebased for whatever your scratch space is, and you're off to the races. So, okay, yeah, branching's not that bad. Not nearly as bad as some of the other stuff, I think. And I have many more slides, but I think I'm actually in good shape this time. So, okay, what about loops? You basically do the same thing, but just sort of expand it out. You need to go through and have like a context object that jumps back to a context object. So you just need it to be circular in some way. And what about multi-branches? I mean, there are a lot of ways of speeding this up. You could build another table. You can have like multi-indexes, but just like if I can do like pairwise branching, you can just do pairwise, then the next pair, then the next pair, then the next pair, and it just works, right? So there's a bit of an optimization you can use with a separate lookup table for this, but it's fine. Okay, so now we have everything we need to start programming, which is very cool. So now we're going to go through and try to build a compiler. So is this Turing complete? Here's a little Turing machine. I'm going to go through and run it. That's the input. I'm just going to add 1 to it. And this is what a demo looks like. You build it, you run it, and it prints the thing. So that wasn't very exciting. So let's go ahead and actually run this with BPF trace running. So I'm going to go ahead and run it. Nothing happens. Still nothing super interesting. This is like surprisingly fast actually for what it's doing. And now I'm going to log every single time we call set context and what the context pointer is. And it's vomiting out a bunch of swabs and set contexts. So yeah, and again, like there are some details here where you need to go through and like build out this table of lookups. But again, that's just, you know, right. Yeah. Then you got to go through and like build out all these like values that you rebase, and it's, by the way, when I say rebase, I'm pretending that I have some scratch space. I know the virtual address of it. I'm going to stick a bunch of objects in there. All of those are offsets relative to a base. I know that base. I rebase all those offsets, and we're good to go. Now I know the absolute virtual address of all of these little things, because I'm using memcopy a lot, right? So I have to know the actual virtual address, not just the offset. So, OK. Now we're at a point where we need a bug. So we need to go find something that gives me a read-write. We need to then turn that read-write into a weird machine, and then we're going to start building programs that run on it. I'm going to leave the read-write as an exercise to the user, and also maybe like let's use C and C++, because imagine like trying to get someone to learn another DSL, and that's just not going to happen. Everyone writes in C and C++. I mean, I like Rust, but everyone uses C and C++, so all your tooling needs to work with C and C++. Obviously, we can't get all of C and C++, but we can get like enough of it where it's OK. So we're going to build a compiler. I don't know how to build a compiler. I read the Dragon book a while ago. I don't know what a dominator tree is. Please do not explain it to me. I'm not interested in learning. And yeah, I'm just going to ask Claude to like combine all these little basic building blocks, and then it's just going to kind of work. So to keep this grounded, one of the things that I want us to all have kind of as a picture in our head, you take an ELF file, you run that ELF file, and it does some stuff. But there's a lot of steps that happen in between, like doing ./a.out and when hello world shows up. So namely, the loader runs. So it jumps into the kernel, it memory maps all the segments, it then spits it back out to user land. The linker or the dynamic linker will go through and fix up all the offsets, and then it'll jump to the entry point. In the context of an exploit where you're running it with a read-write or some sort of exploit, now all of a sudden the loader is running the exploit. So you can kind of think of it as like a generic like templated like, I don't know, copper, and then instead of like a generic for like a type, you would just say exploit. And then whatever that exploit is, it's responsible for doing all the like mapping of segments, dealing with rebasing, and then jumping to the entry point. So to keep this concrete, I have a little dummy program called vuln server, which spits out some information to give us a leak so we know where stuff is. It gives us a little scratch space so we can work around with it, write some data to it with the write, and then I give us a jump. So I get one set context call. Now, this might sound like cheating, but again, you can override like stack check stuff or exit handlers, and it'll still jump there anyway. So this is just making the development a little bit easier. And one fewer thing can go wrong. Oop, wait, no, I did spell concrete right. OK, cool. So this is the server. It doesn't really do that much. The big thing is you send it an R, you read some memory, you send it a W, it writes some memory. Once you're ready to go, you do jump, and then it just jumps to the first context object. So yeah, this is the API that our vulnerable server is giving us. And we're going to go through and implement a loader specifically for it. Like this is kind of like what it's all been building up to. We need some sort of executable file format and something that resembles a loader, and then we're going to staple that together to target the vulnerable server, which is, again, just a made-up thing. So yeah, I think I just actually said I did do a little generic thing there. That was good. So yeah, I could go through and build load copper, and then I just swap it in for whatever the exploit is. And this is kind of me like popping off again, but I don't think you're going to be able to do this super generically, because I think that getting like super, super reliable arbitrary read writes like going forward is going to be just probably a lot harder. So you're probably going to have to redo this from the ground up for every single new thing. But that's also not that big of a deal because, again, if you ask Claude nicely, it'll go through and just write you an LLVMIR parser. So that's cool. So we kind of got a feel for what the loader looks like, but the loader needs to load something. And what is that something going to be? Well, for one, like anyone here want to pop off about just shout out, why do we have elves? Like, what are some features of an elf that makes programming easier? The PLT, that's one. You don't need to know where stuff is at compile time. Yeah. What else? Relocations, that's awesome. I don't have to know what my base address is because I'm not going to know until runtime, right? It basically lets you deal with things at runtime that you won't know at compile time, right? So whatever our executable file format is, or just calling it a copper, I'm just basically copying elf. I'm copying the idea of segments. I'm copying the idea of the text section, which is just all the context objects. And by the way, one detail that I left out, every single context object needs its own stack, which is kind of annoying, but it's not that big of a deal. And also, if it's referencing something that uses a mem copy, that's at an offset from our scratch space or our workspace. We need something to rebase that, right? We need something to do relocations. So we need to put all those relocations in a place where the loader can parse them and then apply them. So, all right, we're going to build our own version of the global offset table. We're going to add our own version of the PLT. How are we going to deal with threads? Also, how do we run big programs? So the global offset and the global offset table with the PLT, not that bad, right? We just store a list of offsets and walk that list of offsets and then just change them. Threads are kind of annoying because if you just call pthread create and you're using the same lookup table that somebody else's and you call pread or pewrite, you might stomp over what it's using. So you have to make a separate context chain for every single thread. And then I guess like talk to each other using shared memory or something. That sounds annoying. What about big programs? Like I actually did try compiling Doom and unfortunately couldn't get it working. But it was like, I think like 1 million context objects, which was like a couple of gigs of memory. You're probably not going to get a couple of gigs of scratch space. So like maybe I should go through and write like a stager for this, right? Like what would that stager look like? Well, mmap, big region of memory, connect out on a socket, grab everything, rebase it, and basically ship the loader inside of the bootstrapper. So, okay, threads are kind of annoying and really tedious, but you can solve this problem. Likewise, bigger programs, but it does get super slow. I got to the menu screen in Doom and then it crashed and I just gave up, but maybe at some point. So we're gonna go through and build a programming language on top of all of this by just using C, compiling to LLVM-IR, and then just lifting it. So yeah, we're going to go through and take C and put it in some sort of state that it's usable. Then we're going to go through and take advantage of all of this machinery that we've built up and basically just map out every single LLVM-IR operation to something that we already know how to do. And because we have arithmetic and conditional logic and function calling with capture, we're golden, right? So, okay, I don't actually want to write any of that. That sounds hard, and I don't want to learn LLVM-IR. And you can ask Claude really nicely to do it. Now, if you ask Claude to go through and build you a weird machine, it won't. But if you give it a list of operations that map to arithmetic, conditional logic, calling arguments, and getting the output, it's pretty good at wiring it up. What exactly did it wire up? All this crap. And that's okay. There's actually some more in there, too. But this is enough. Like, all of these little operations are generally enough to run most C programs. You can even build structs on top of this. Pure virtual functions was kind of tricky, but and I don't think it's actually fully working. But you can use most of C and C++. Now, exceptions are kind of annoying, and like runtime information is kind of annoying, but you don't need all that, right? So, okay, what is the loader actually going to do? It's going to take our LLVM-IR lifted program and then just throw it at the vulnerable server, right? So it needs to go through and basically parse out. The server just leaks some information, gives us the layout of what a context object is, because that changes from glibc version to glibc version. We find some hard-coded offsets for some functions that we'll need. So this is not ideal. You need to know some offsets. But again, we'll have the global offset table PLT thing, and we can go through and just leave a bunch of thunks empty, and then as a part of loading, populate them. What do we populate them with? We just keep calling dlsim. And just keep writing that target value to the next offset in our little PLT table, right? So yeah, the loader will read some memory, rebase our copper program, write it to the scratch space, and then trigger the set context jump that kicks all this off. So I get a big read, a big write, and one jump. Seems like a pretty reasonable thing to have. The scratch space, maybe not so much, but again, you could go through and stage this and make it smaller and code golf it, and I could not be bothered. So, okay, what offsets do we need to get started? Well, we need start context, which is luckily normally at a fixed offset from start context. So we need start context. We need dlsim, pthread create, pthread join, pthread exit, and memcopy. I feel like we could probably get away with like dropping one or two of these by using, the auxiliary vector, but again, I could not be bothered. This seems like a reasonable amount of offsets to use, then we can just find the rest. So what is that global offset table going to look like? I'm running out of time. A bunch of different entries in a table that we mem copy the real virtual address to after calling set context into pthread create with pthread exit as the link register. Next one being pthread join, understanding the exact virtual address of where that pthread ID was written. Now, the one thing to keep in mind is this is a little racy, so don't do super long running things. But what's nice about pthread join is it'll just wait for it to finish, right? So it's pretty safe to use actually, which is very nice. So yeah, not that bad. So now we have a usable global offset table. That's pretty neat. What else do we need? Well, we got to actually build a format and write a loader. And again, I just copied elf, like straight up. In fact, I think I like actually copy and pasted some stuff from elf.h. And it's just, you have some relocations, you have your text, which in this case is just a bunch of like context objects, and then you let the loader do its thing. So what does the pipeline for this actually look like? You take your C program, you spit out some LLVMIR, then you feed that into the like specific copper LD linker, and then it'll go through, take that, figure out all the rebasing it needs to do, then interact with the vulnerable server, do a bunch of reading, rebase the actual executable, write the executable to the scratch space, and then trigger the set context, which triggers the jump. And now you have this super long chain of set context, swabs, and pthread creates, pthread joins, and pthread exits. So what does this actually look like? Again, it's not super, it's just a shitload of start context and set context and everything else, but you can ping, you can ask it to tell a joke, you can go through and have it echo text back, and you can go through and use it like a shell, right? So great, you can do cat etc password entirely in context objects. So, okay, should you use this in real life? No, it's extremely slow. I mean, the idea of creating a thread for every single function you want to call seems kind of bad. You got to know a lot of offsets, which is bad. Your read-write needs to be super reliable and repeatable, which is also bad. It's really, really slow. It's really, really big. And it's going to be really brittle in between like different versions of the same system. Also, it is a major pain in the ass to debug. But if it's all you have, I guess it's better than nothing. So, all right, what about on like other systems that are not Linux? So on Windows, you have NT-continue and a couple of other bootstrap like, there's a start context like gadget in there. So I think this will work, but I haven't actually checked, and there's probably some sort of like Windows like set BS in there that makes it harder, but probably not impossible. On Android, there actually is set context and start context. It's just not called that, so happy hunting. And on Apple, I think there's like a ton of options, but you need a task port, and getting a task port's like a task control port's like really, really hard. Also, there's probably some BS with like Objective-C and GCD, but again, could not be bothered. So, finished early. All right. Well, any questions? No, I was totally clear. Yeah.
Have you turned it into a CTF challenge?
Yeah. Summer at DEF CON this year, keep an eye out for it. You're going to have to reverse engineer it. Like, you know the like Mobfuscator CTF challenges? There's one where it's reversing this. Yeah. I'm super deaf, by the way.
Sorry. So this requires that you like have your program. Sorry. Your program is a bunch of context objects that you write beforehand, right?
Yeah.
So I didn't really understand the part where you were talking about conditional like branching. How does that cope with the fact that you have to like predetermine the contexts and the registers that goes in each context? Like how do you dynamically assign the registers?
Right. So I'm not dynamically assigning registers. I pre-prepare context objects at fixed offsets. And then when a function does a conditional branch, it does a comparison and adds that offset to what the context object is going to be next. If it's true, that offset is 0. If it's false, it's the size of the next context object. So you can't do dynamic conditional logic where if I wanted, well actually I built an interpreter so technically you can, but you can't at compile time do this. You need to pre-stage every single path that the conditional object might take as a separate context object. Then when you do the index into like by a swab into a lookup table, it basically adds that to the context object that was rebased at load time that you're going to jump to. And if it's true, it's going to go to X. And if it's false, it's going to go to X plus size of context.
Okay.
Does that make sense? Or
Essentially skipping context.
That's right.
Yeah. That kind of makes sense. Another thing is like this to make an exploit with this, you need to have a runtime in the vulnerable system, like a coroutine runtime that uses this like U-link thing, right?
Or you need a bootstrap trampoline. So I'll spoil one thing. I think it's like RT like SIGRET basically gives you start context. So you need both context switching and something that allows you to sort of stitch these together in like a CFI friendly way or a VTI friendly way. And like SROP is like a well-known thing, and like a lot of the same ideas apply here as well.
Okay, so by the trampoline, if you don't have like a U-link thing where it like automatically will just hit the next context,
yeah,
you have to like set the register to a trampoline or something?
That's right, yeah.
Okay, all right.
Going once. Love it. Cool, all right, thanks y'all.
It sounded great. How do you feel about that?
Real good.
Excellent.
I am heartbroken that Ghost jumped off the stage though.
Yeah.
Let me get out of your way.
Well, it's okay. You know.
Thanks y'all.
Did I?
Oh God.
No worries.
All right, so I got some more stuff to give away, and actually, here, you want to hold this? Thank you. Actually, I'll start with the
Yeah.
easy stuff. Who wants some drink tokens?
Oh, that's some nice stuff.
All right, one more. Come on. That's cheating, Sarah.
Is it a profession of love or?
All right, so this one,
Oh, yeah.
we have a hoodie that I'm actually really excited about. Well, first of all, I forgot. You guys can buy one of these adorable cropped hoodies too. Big fan. Right? They're actually very
All of this
cute.
is available on the merch store.
On our merch store, including this, which my nephew will love. It's a camo Summercon hoodie. Very cute, looks very comfy. I can confirm this is actually like super soft inside. And this one is,
And if you have a short torso, it's perfect for you.
this one's large. So who wants, yeah. I don't know if I can throw that far, but I'm gonna try. Yeah. Also, this year, I don't know if you know, but Uncle Sam wants you to hack the planet. So we have these awesome pajama pants. They're very comfortable. I probably could bottle them, but I'm not going to, sorry. But they're very comfortable. So we have these to throw at you too. Yeah. I can't, yeah.
Oh, and let me turn off.
Okay, very good, very good.
All right. And next up, a book that I shouldn't throw.
Oh, thank you.
And I think, because no one wants to carry around a heavy book, a tote bag with it. And what
I think that tote bag also has a zipper on it.
does it?
It does have a zipper.
This is a special kind of tote bag that can zip closed.
You can close it. It's a bag of
So your
holding.
shit doesn't spill all over the subway.
Yeah, that's awesome.
As
been
I
there.
do all the time.
And it is Heavy Wizardry
Literally.
101 from No Starch Press. It's a hard book. It's actually very cute. But
It's a beautifully bound book.
it is actually
like this beautiful
look.
leather binding.
No, I mean it's very
And it will be exclusively not handed and only thrown in the bag as fast as possible.
But yes, we'll give you this bag and this bag with it.
This tote that reminds you of your responsibility to fight scurvy. Scurvyawareness.org. All right. You have to ask for stuff.
I think that is all that I had for. Oh.
Do is housekeeping. I had a brief announcement about Sprawl NYC. They are looking for interns to present what they did over the summer, like to do presentations. If
Over a Summercon break?
Sure. If you have a presentation that you would like to share at Sprawl NYC, go to Sprawl NYC, talk to Ryan Stortz, and share the idea.
Before we do that, is Hiram ready to come up here with his crazy getup while the expo guys keep getting set up? Or are we doing that later?
Why don't we get to that just before Flip Cup? Yeah.
Okay, we'll do
right,
that.
so-
We'll do that before Flip Cup.
We are actually, I'm very excited about this talk. I know a lot of you are. This beautiful, Legally Blonde-esque MacBook is getting us all in the mood for throwing it back to our systems of yore. Nick Gregory and Brendan Dolan-Gavitt will present 16 zero days across 12 platforms and some expected ensuing shenanigans.
Oh,
so welcome them.
All right, thank you, everyone. Can we actually grab a second mic by chance?
Yeah, impossible. Okay. We do the impossible 3 times.
3 times over.
Before breakfast.
All right, welcome, everyone. This is Back to the Future, Owning Systems of the Past. Briefly, I'm Nick Gregory at KL Sims, basically everywhere.
And I'm Brendan Dolan-Gavitt, and tonight we're going back to the future.
Professionally, we do AI and a bunch more stuff at Expo. This is very tangentially related, but yeah, anyways. So, brief overview of what we're going to be talking about. Basically, 4 steps. Reverse engineering, where's the bug? Emulator, how do we actually run all of these old things? How do we actually set up the environment so we can debug all of these exploits, which of course aren't going to work the first time, even as insecure as these things are. And then how do we validate that these AI agents that we have going off and doing all of these things have actually done what we asked them and aren't just, SSHing in, running calc, and then being like, look, a calculator has appeared. That's crazy. One thing I do want to get out of the way up front too, this is just using stock codecs with GPT 5.4, 5.5, and 5.6. You can do this at home too. These agents are now staying coherent for hours to days. So a lot of what we're talking about isn't really the exploit side directly. It's how do you set these things up in a way that, priming the correct initial conditions for them to then just press go and go off for a while and, hopefully come back with some calculator spawned.
Yeah, so these are more organically grown rather than artificially created exploits. So there's all sorts of exciting roadblocks once you start trying to exhume systems from 20, 30 years ago. One of the more annoying ones is that many times the companies won't actually legally sell you the software anymore, and so you have to get maybe a little bit creative. So with perhaps a little bit of copyright, say, sidestepping, we got our AI to make us some keygens. And of course, once we made it, we said, oh, no, you need more glowing things, more cyan, and some MIDI. So this is one of the worst chiptunes I've ever heard. But that is authentically GPT 5.5's own creation. So, okay. So yeah, we were going to try to just cover a broad swath of browsers and operating systems, but one question is what's actually in scope here? So we set the ground rules as For the browser exploits, you got to be able to just go to a malicious website. It sometimes would try to go to like file://bin/sh, not allowed. And so for the network attack surfaces, we want to go with default enabled services on classic Unix systems. It turns out this is not actually a limiting factor because, my God, they enable a ton of network services.
It's fantastic.
But what this does rule out is, unfortunately, if you're hoping to see us hack a Cray, that's not going to happen because those are not usually on the public internet. On the other hand, if you need to protect against Velociraptor attacks, that we can help you with.
It's a Unix system. We know this. So starting off with reverse engineering side, there's kind of two approaches that we ended up taking. There's what you might expect of use the AI native way of an MCP server and point it at Ghidra and say, go forth and hack my child. But we also found that actually just getting a kind of complete pre-decompilation out of Ghidra and then pointing the agents at here's a file structure, like it would just be examining a repository, is also quite effective. Strangely enough, somewhere in this, GPT ended up thinking that Netscape was still a production browser. Not entirely sure how it got there, but as well as to show it's not entirely wrong in some ways, which is always great fun. But anyway, so we're giving 16 whatever it is different kind of entire operating systems or browser or both to look at across I think a decade and a half roughly. And so one of the issues that we have to deal with here is there might not be a Ghidra loader for this file format, or the CPU definition for, was it alpha maybe?
Yeah, it's pretty incomplete.
Yeah, it was very incomplete to Ghidra, so the decompilation was not very good. But one quote that Brendan gave while we were preparing for this was, AIs are great because you can yak shave faster than ever before.
I've shaved so many yaks.
So many yaks. It's amazing. Right, because we're doing effectively blind reverse engineering of most of an OS's or 5 TCP/IP stacks, 7, 8 different browsers or something like that. Again, maybe partially source available, but from either way before or way after. And so there's a lot of RE involved here. It's not just, haha, there's bug. One other thing I do want to actually point out with pre-decompilation, what's really nice with that is you can just let subagents go wild. So you can, get a real idea of where some bugs are across this large scope of, this large swath of code in like 10 minutes. So pretty neat.
Yeah. So getting back to this question of how the hell do you actually run these things? So it turns out, I'm not going to try and actually go and collect a giant, set of, vac stations and things like that in my shoebox New York apartment, because I would be murdered. But what we can do is say, let's try to emulate all of these in QEMU. So you can fork QEMU as many times as you want. It's free. I have 20 QEMU forks sitting on my hard drive now. But you run into really weird things, like the fact that on the alpha, because they wanted to support VMS, they support 2 different floating point modes. Standard IEEE, that we know and love, but then also a VAX floating point mode that turns out the browser's libpng used to do calculations. And so if you don't implement VAX floating point, you get browser crashes that have nothing to do with your exploits, and that will not do. So we also wanted to standardize on QEMU because otherwise, if you try to use some of these more homegrown emulators, you're not going to get nice things like snapshots. They're going to be crazy slow. And unfortunately, agents have no sense of time. And so they do not know how excruciating it is to watch them try to do one shot at an exploit every 30 minutes while they wait for the thing to boot.
Yep.
So the nice thing, though, is that, again, you can really make them do terrible things that you would not ask a human to do. So, for example, to get a True64 exploit working, I made it install 7 different versions of True64 from scratch because there was one that had the right uninitialized stack contents that let this program run in the first place. So you can do that kind of thing. The other kinds of things that you need to avoid them doing is trying to use things like VNC to control things. It doesn't really work well. They aren't good at it. And also making sure that they don't step on their own feet while they're trying to debug things. They really like to try to debug things as if they're normal programs, but when you're doing heap exploitation, that's not the right way to go.
And one other kind of personal anecdote with this, I think I had to reinstall Windows 98 3 times before I got the right driver incantation for modern QEMU, and it wouldn't blue screen back to back to back. So
that was basically my childhood, though, so it's not that bad.
And lastly, kind of before we dive into a bit more, validation. How do we know that these agents actually did what we asked? There's, again, kind of a conventional route of use flags like we have for CTFs for many years. They're very in distribution for what the models are supposed to do, and even without kind of this wrapper of /goal to kind of prod the model along to do something, you can get things running for days. Like I think 3 or 4 days just out of the box saying get the flag. There's also screenshots though. You can just say did calc open, and this is also pretty effective once you get enough of hey, don't do that slap on wrist. You don't have to make it foolproof from the start. You can kind of correct it along the way. And generally, the agents now, once you tell them, hey, don't do that, they won't do it anymore.
They'll cheat in a different way.
They'll cheat in a different way. They will monkey paw you over and over and over, but not that way. They love to use GDB to attach to QEMU and be like, oh, wow, I found the flag in the memory. It's crazy. Who would have put that there? So /goal, what do these models actually end up doing now that we've kind of set up what we're giving them to work in? Well, as Brendan sort of alluded to, they love to test things in like a modern fashion, which doesn't really work. So, oh, there's this really interesting, heap use after free. I can use like some of the heap feng shui tech. No, you can't. No, you can't. This is not the glibc you're familiar with. Additionally, a lot of stuff is just wildly out of distribution to start with, right? Register windows aren't really a thing anymore for basically any architecture that it will have seen much use of in its training. Additionally, one thing I ran into that was fun was for macOS 9, it needed to figure out how to do 68K in the emulator that macOS 9 has so that 68K runs on PowerPC natively. And so figuring out that it needed to do that, and then like how to bridge between the two worlds was interesting. And then, of course, like we said, the models will still monkey paw you. They will still try and find ways to weasel out of hard problems, like having to RE a custom heap implementation, or sometimes they would just be like, wow, I can just patch the binary, and again, like a flag has wildly appeared. And that's, no.
Yeah, and so, the other kinds of things where they really just fall on their face is they are willing to go and pursue a hypothesis without sometimes checking maybe whether that is actually a reasonable thing. So poor GPT-5.4 spent about 12 hours working on an amazing exploit for like a really cool bug that it thought it had found that once it got slightly better instrumentation, discovered was a null pointer dereference. So not super exploitable. The other kinds of things are they are wildly overconfident in abilities that they don't necessarily have. So for example, when I was trying to get the emulated graphics stack up and running on alpha, it would do things like say, here you go, got the graphics stat working. Looks good, right, mate?
Ship it.
Yep. Yeah, no, looks good to me. So this is the kind of thing that you have to actually, unfortunately, still have some human eyeballs in the loop, or give it some tools for saying, like, look, just count the number of freaking blue pixels on the screen. Like, if it's more than 90%, you have not succeeded yet. And then, of course, we mentioned some cheating. They love doing things like writing exploits where it's like, oh, I just need one address. So I will pause the exploit here, SSH into the box, read it out of procmem, and then go back to the exploit. Do not see a contradiction here. So I'm not going to go and read all these targets. This is like what I consider the greatest hits of browsers over the past 20 years here. And then, of course, if you want something that's a little more wormable, a little bit less client-side, you can also go after network services and core TCP/IP stacks. And then finally, if you're feeling just like really freaky, you can try to exploit an emulated Lisp machine running on an emulated alpha running True64 on your modern laptop. But okay, now that you've suffered through us talking about agentic-driven development, I know what you really want is to see a lot of videos of calculators popping up on screen. So let's get started. So this is Mosaic 2.4, running on OpenVMS on a VAX emulator. You can see that we can get calculator pretty quickly. How did it do that? Well, it turns out that Mosaic supports a file format, an image file format that you may have never heard of called XPM. And that by overflowing this with exactly 8,229 bytes, not one more, not one less, you can then take control of the parser and get it to overwrite the equivalent of the PLT on this VAX, which is DEXC $system, at which point you can now jump into the pixel data and run your exploit. So, of course, this is a very serious vulnerability. As everyone knows, if you're a hardcore anti-vaxxer, this was the exploit for you. Yeah. Okay. But so maybe for some browsers you might have actually used in the past. So this is Netscape Navigator. I really like this one because as part of the exploit, which was basically a mistake in how it handled the select and option tags, it was able to end up overwriting system. But the function pointer that it overwrote was stirdup. And stirdup is called a lot, which is why when you try to run system, you suddenly start running system on a bunch of HTTP headers along with your calculator. So this is not what I would call a clean, weaponized, production-grade exploit, but it looks really funny.
We still got calc.
Doesn't matter, it got calc. So we can also go forward. This is Netscape 5. They never actually released this one, but they actually did release the source. So you can, this is actually a slightly easier variant of it. And it lets you, again, pop calc.
Oh.
Right. So Dino, who may be in the audience, so we're going to show his tweets and embarrass him, does mention that this does occasionally have very nice, maybe practical effects, which are if you're on a pen test engagement and the customer says, no, accepted risk, no one would ever write an exploit for Netscape. Now you can come back and say, oh, well, these guys did.
All right, so moving on. This is Solaris 2.6 on Spark with a lovely IE5. Gotta love Gopher doing its best at being a protocol which can be used to exploit things. Let's get there we go, there's calc. Basically, it's a pretty simple one. Just shift a pointer with inside of a fixed stack buffer. You can then end up using a subsequent write to kind of blow past the end of the allocated size. Spark's interesting because of register windows. So you don't end up just like overwriting a return pointer. You end up actually overwriting like a whole series of registers, and then those get pulled off. There's a little bit of magic that happens with, again, what we're overwriting is actually something that's then later used as a pointer. So it's not even directly a direct PC control. It manipulates some registers which then have like second order effects down the line. It's definitely interesting to see, again, that you can still reason through these. And you might notice that little icon next to the end of the title. This is one where we actually got a double kill. So there's another one in IE5 where array.sort ends up doing some 32-bit math on a length field. You can probably see where this is going. Big number times 4 or so happens to suddenly become not so big number. And so you can end up just doing a pretty easy, just out of bounds write with that. There's, again, a bit more shenanigans that have to go around with how the second half of the exploit, but we only have so much time. So the compact secure web browser, one that you may not have heard much about. However, you remember when I was saying before that Netscape isn't a production browser? So the bug that it actually exploits here in binhex parsing code. Oh, did not start automatically. Yeah, the bug that actually starts exploiting here is the 1 byte out of bounds read, which lets you control the low byte of an adjacent pointer. This survived until 2017. So it's maybe the models weren't quite so wrong that it's actually still kind of production.
Yeah.
Running on alpha, there's a bit of interesting stuff here where it's, again, not just your normal like i386 overflow the stack, hit a return pointer, and ta-da. You get some fun with having to use OpenVMS's DCL commands, which are sort of analogous to like binsh in a way. So you end up having to just run this really weird esoteric string, and it ends up working similar to how you might expect, though, at the end of the day. Yeah, and then there's the actual CV for this bug, about 15 years later, call it.
Yeah. Okay. And so then, of course, it's not all fun and games. Some of it is just games. So on this one, we had the Dreamcast, which actually had a broadband adapter and a web browser. And I was like, well, you know what? If it had a web browser, it's in scope. We're going to exploit it.
Oh, yeah.
And the other thing that I liked about this is that it's very much kind of its times. So this loads a macromedia Flash applet and then redirects from the Flash applet into an overflow in port parsing, which then turns into a normal kind of stack-based buffer overflow. But the fun thing is that since this is a game console, you can ask GPT, like, give me a real cool, like, post-exploitation splash screen, and it'll come up with this insane vaporwave thing.
Yeah, give me the aesthetic, GPT.
Right. This was the point where people started asking if I was still employed, and
it's a valid question,
yeah,
right?
Yeah. And the answer is I won't be once they see the token bill. Okay, let's get back to more of these stylish, classy ones. So this is net positive running on BOS. BOS was amazing because you could do things like show a GL accelerated teapot. And because of the magic of modern AI, you can now show a GL accelerated teapot by parsing attacker-controlled data coming back from an FTP server. Meanwhile, we've got things like NextStep, historically very important operating system because that's where the web was born, and that's where the web got exploited here. So, in fact, on this one, we actually ended up exploiting TalkD. So this was a weird sort of exploit, and maybe this starts to stretch the bounds of historical accuracy because the way that this exploit worked is it was actually an overflow in the reverse DNS lookup when you connect via IP. So if you were an attacker that controlled your own IP address range, you could make repeated connections from different IPs, control the reverse DNS resolution, and use that to overflow the the hostname parsing, and stage your exploit into memory. So this particular exploit ends up basically creating its own new user, and then logging in as that user to run the 3D chess program that came with NextStep.
One thing I want to point out here too in particular, since you can't actually run stuff directly from like the daemon context that this used, the exploit ends up effectively emulating keystrokes to launch this. So yet another fun way to exploit things. So next up, we have a nice classic, macOS 9.2.1, may it rest in peace. This is kind of one of two that are particularly interesting because it's almost the exact same bug across two different operating systems with completely independent network parsing code. There's some extension to IPv4, which is not very commonly used, but is apparently very buggy to implement, which lets you do a pretty classic, I am giving you something of length 4 and then give it length like 100, and it just, length is used to allocate and data is blindly copied in, for example. The kind of post-exploit chain is a little bit interesting here because, well, this isn't a preemptive operating system. So this also made the exploit kind of retry chain particularly annoying because, well, you take down the entire system, or in some cases you don't because your exploit like hangs or like gets into an infinite loop and then nothing ever comes back. This was a particularly fun note under my post for this. Sad to say, I completely believe it. Yeah. And then we've got another venerable target, Windows 98 SE. Again, exact same extension to IPv4, pointer beyond declared length. This is a little bit interesting because it's not actually a clean write. It ends up swapping pointers, so you end up actually doing this, changing one, and then basically doing the same thing again to swap it back to where you actually need it. And again, more Windows NT internal nonsense and not actually having proper kernel isolation for these drivers. Moving on, because we're running low on time.
Yep. So this is an IRIC system. So these were SGI rendering machines. I almost didn't believe how stupid this vulnerability was, because it turns out that there is a pre-auth vulnerability in one of the line drawing daemons where you can literally just specify a callback and arguments and then disconnect and it will run your callback. So this is almost not a vulnerability, like it's just really stupid design. And this starts to become kind of a recurring theme. So moving on to True64, we got a couple ones here. They were both in the ToolTalk database. And the main reason I ended up doing these is because I mentioned that I was using True64, and Dave Attell was like, oh, if you're using True64, why aren't you exploiting ToolTalk database? And so I said, fine, I'll go exploit ToolTalk database. Okay. All right. And so this is kind of where we hit the end of the road. So I was like, okay, look, a Lisp machine, that's a weird thing. Can we exploit that? It's hard to actually get a real Lisp machine. I tried. And so we ended up running on an emulated Lisp machine. And the problem here is that at this point, things get almost too easy. So this vulnerability is that when you connect to an FTP server, it sends back the current directory, and the Lisp interpreter runs eval on it, because that's what you do in Lisp. So there's not really, again, like, this is super easy to exploit, right? You just send some Lisp code in your PWD, right?
So, are these production-grade exploits? No, right? They're currently pretty fragile. They do work, right, as you've seen, but they rely on some constants, which probably don't vary from boot to boot, but maybe do. There's some assumptions about layout and memory. You know, even though we are restarting machines, QEMU is pretty deterministic, it turns out. And so as sort of a case study of this, we had 3 RC class network reachable bugs in macOS 9.2.2. We had an additional bug in the port of Netscape 4.7 to 9.2.2. And GPT-5 could not make it work reliably, no matter how much we tried our damnedest to prompt it. So we're going to try this. It probably won't work, but we're going to give it a shot.
Yeah, and we're not saying this just to build suspense. We really made the decision that here that it was better to die on your feet than live on your knees.
Yep.
So let's do this. So I'm going to open up Netscape Navigator. So you can all see it, or Netscape Communicator. Yes. Very nice. Okay. So, yeah, this is getting lots of Blair Witch vibes here, but... all right, can we see this? Yeah, we can see this. Okay, http://10.12. Yep, okay, it's got that. calc.html. And let's see if this works. So one thing that's kind of fun here is it's trying to leak addresses into the select box there. So okay, that one missed. So ready, aim, fire. No, that's a miss. All right, we're going to give it one more. No, come on, keep going, keep going.
One of these
No
days.
Emmys, no Emmys. Oh, no. Okay, well, all right. And we've killed the browser. But, all right, so this is all to say, if you are a nation state, probably don't let your LLMs write the exploits entirely on their own just yet.
Unfortunately. So some closing words. Are these targets hard? Right? Not really. This is before memory safety was like a thing that should even really be considered as the should do. Right, we had a case in particular where we were just trying to put a file on the machine and accidentally just like completely froze it because oops, we put too much data into your buffer, sorry. But also, like, the bugs are still real at the end of the day. And, you know, like I said, one of these was only actually CV'd 9 years ago instead of 25. So there's some interesting stuff to be had. And then, of course, as one last thing, anyone want some exploits? We have some thumb drives, perfectly labeled. I promise it won't own anything that you're actually running right now.
Yeah. So, thanks everyone for listening, and if you got any questions, we can do our best. All right. Oh, there we go. One in there.
Yeah.
So Netscape turned out to be the dividing line. So Netscape was too new and too production grade to exploit straight up. So we had to frame that one as a retro CTF challenge.
Yeah. Can you repeat the question originally?
Oh yeah, sorry. So the original question there was, do we have to convince GPT to exploit things, or was it willing to say like, oh, this is old enough that it's not production anymore?
Yeah.
Negative 1,000. we took your CVs. No. So we could try to send some of these OS 9 bugs to Apple if we want to get some laughs out of them.
What else? We got another.
Sorry, do any steering for the? Yeah, right here.
Did we have to do any steering for the talk D exploit is what I heard. Is that...
Okay. So that one wasn't... So yeah, do we have to do any steering for the talk D exploit? So that one wasn't too much. The main thing with that one was telling it that it was allowed to use bridge networking so that it could get the reverse DNS.
Yeah. And then I think we got one more. How much did the whole thing cost? For legal reasons.
Yeah. Not enough to get me fired yet.
Yeah. I can tell you my part was just done on a subscription that I pay for, so only $200 or whatever the pro subscription is. But anyways, alrighty. I think that's it. Thank you, everyone. Actually, sit down. Look at that.
Means it's time to party.
That's a spicy meatball.
So, we have some giveaways. Is that
We
accurate?
do. We do. Let's see.
I think we have some more garb.
So this one,
Oh,
I don't know what size person this is for.
a little large. Oh boy.
Is that a
That's like a
child's
toddler.
large?
It's a ghost. If you have a ghost at home, would you like a shirt?
I can tell you that my 7-year-old is too big to wear
Yeah,
that.
no, yeah, definitely. But yeah, that feels right. Who said that?
Is this okay? So this is the current slide. This is the.
Does anyone have a little in their
And you
life?
just do this to get what you're looking
Oh God! Oh, right in the face. Sorry.
And then this is a tank top, presumably for women,
Does look it, and let us.
or a very petite man.
It is a medium, and it has the fight scurvy, scurvyawareness.org, and on the, there might be a Summercon thing.
Do you have
Anyway.
a spouse or a child? Or
Yeah.
all right. And then we got one more. I think this is actually a pretty special one. This is a Columbia Summercon vest. And it would normally retail for $61.50, but we're giving it out to you for the low price of answering a trivia question.
Oh yeah.
Question is, what is the trivia
You
question?
have to. You gotta cue that up, bruh.
I know.
Does anyone? Wait, no. This is even better.
I'm
if anyone
coming
has
unprepared.
a good trivia question, we'll give you this, and whoever answers it, I'll go
Actually,
grab something else.
Jack, do you have a trivia question, perchance?
Not really.
All right. Well, we won't put you on the spot like that.
Yeah, you have a good trivia question?
What year was there not a Summercon?
Ooh, what
What year was there not a Summercon? I'm going to go with any year before 1987.
You can't answer it.
Well, there's been a Summercon every year. There may have been 4 people at it, but we have contiguously had it has happened every year.
What does Wikipedia say?
Wikipedia is fucking wrong.
Yeah, the good thing is we can change that. Like, it is a lie. Summercon is older than me and continuous, so. There was a 94, there was even a 2020.
I should note that this
It was
vest is a
online,
large.
and it was fun. That's a good point.
And
thank
it
you.
zips
Wait,
all the way down.
do you have a trivia question you want to ask? Yeah, hell yeah.
What month and day was Apple founded?
Ooh. What month and day was Apple founded? I'm going to go get another piece of.
What day did turtlenecks come out?
If I don't get this right, do I have to leave the stage? Is that what happens? Oh, you get to hit me. I'll just take the punches.
I think that's called a love tap. Jimbo, do you have a better trivia question for this wonderful vest of fleece in July? It's the kind of thing you'll wear some of the year.
Since Andrew asked that trivia question, we're going to give him this wonderful beach towel that you can also get online, right?
So we should note, all of the towels with all of the posters are available on our merch website. And these are the kinds of things that you want to bring to the beach because they
no
serve.
one fucks with you.
They serve as a conversation starter.
I mean, this gentleman right here. Did anyone answer the question? No. So we still have this.
We still have a vest. It's hot even to the touch.
You're underselling it now, bruh.
I think I'm overselling it. I'm saying this fleece is making me sweat.
Yeah, I was gonna say there's a lot to go with there.
Where it's making me sweat's a different story, Mark. Yeah.
So you know what? I can come up with a better trivia question. We can come back to that one.
Okay.
If you want to do that.
We'll bring it out. I have one other announcement, and then we're going to introduce our next speaker. So immediately following this presentation, Bishop Fox has graciously supplied pizza for. Now, I do wish to note that it was supposed to come at 6, and then there was like some shuffling around 5, and then like it came a lot earlier. So if you smell pizza in the air, it might be in the building, but it's not until after this next presentation. Okay, clear? We're clear on that? Okay, great. Thank you to Bishop Fox for that. They're awesome.
Yes. And to anyone who's not lactose intolerant.
Fair enough, yeah. Stay away from that pizza, John. And tip your bartenders. Yes, that is a good piece of advice, Jimbo. Thank you. Our next speaker.
I don't think you've ever met him.
It's weird because we have the same last name, and it is not that common of a last name. And I just met this guy 50 years ago. This is Dr. John Trumpor. He's the unofficial Summercon historian.
I'd say that's no relation to either of us, but that's not right.
Actual factual historian at an accredited, still accredited, your university, it's still accredited?
Still accredited, but Trump is working.
Okay.
The university, it's not in Boston, it's across the river, right?
Yeah, that's what I understand. Yeah. Okay. So Jack is going to talk for a few minutes about one of John's favorite topics.
Conspiracy theories.
Yes. So with
which
that,
are only conspiracy theories until they're true.
hands together for Jack.
Well, thanks so much. I'm really heartened to hear that the pizza will be delivered because we're going to be talking a little about Pizzagate. Well timed. And the different time that it's being delivered, we maybe were a victim, Summercon, of a vast conspiracy with the pizza time changing by an hour. But anyway, we'll keep that in mind. So thanks to everyone. I know I talked last year about the report from Iron Mountain, which was another conspiracy theory. We'll mention it briefly today. But we live in a society that is rife with a lot of conspiracy theories. You may detect sometimes me being critical of certain conspiracy theories, but I do want to say I'm not against all conspiracy theories. We certainly know Julius Caesar was murdered in 44 BC, and it looked like the senators conspired to carry it out, and things in history sometimes, work that way. But what I guess I'm trying to say is that you want conspiracy theories, as John says, that's true, and a lot of times we have some that have really gone off the rails, as you'll see, and see what you think. But one of the theories that came up in recent times, there's a lot of ones about music and musicians. And back in 1979, we had the band Supertramp, who did their album Breakfast in America. And people have been writing that they predicted 9/11, because if you see, they had the Twin Towers on their album cover, and they had a waitress who replaced the Statue of Liberty, and she's holding up orange juice next to the Twin Towers. And if you see here, they say there's the date 11/9. In most of the world, the calendar is the opposite. We say 9/11 in the United States, but most countries, the month comes and then the day. So they say these two things clearly signal 9/11. So we hear this a lot, and apparently the orange juice potentially splattering on the Twin Towers was a premonition of the destruction to come. So people come up with a lot of things. But it's true. Yes, the USA, even going back to our colonial days, we have a strong heritage of conspiracy theories. And I want to start off with Cotton Mather, who was a 17th, early 18th century preacher. His father was president of Harvard, Increase Mather. He was very angry because Harvard didn't make him the leader of the university. He played a big role in the Salem witch trials. And he had a lot of conspiracy theories. There's an aspect of his religious heritage that was very apocalyptic. He often predicted the end of the world, 1697, 1716. Then he moved it to 1717. Then he said it was going to happen in 1736. But Boston had a very bad earthquake in late 1727, and he then proclaimed, this is it. But he died a few months later, and he didn't really get to recalculate it. So maybe he did think it was still going to be 1736 on his deathbed. But I think Mather's a very interesting character because you see things in his thought. One of his big ideas, he wrote a book that was called Wonders of the Invisible World. And what he talked about in that book was this idea that Satan had largely left Europe because Europe became such a stronghold of Christianity, and Satan fled to the New World. And Mather claimed that Satan was now operating through the indigenous peoples, he would call them the heathen peoples, and he used this kind of justification to say that, you know, the Puritans who had arrived were a people of God, but we were surrounded by agents of Satan. So he kind of came up with this theory. And it's something that a lot of his theory focused then on outsiders to his community. But that was one of the interesting things about the Salem witch trials, where they went after a lot of their own people. And, you know, one of the things that happened, too, is they often found children who made accusations against, oftentimes, a lot of women, but there were also some men accused of witchcraft, and people were executed. It was a pretty brutal thing. And I admit this, people have an attitude, always trust children, they're innocent. But I don't know, I remember trying to get my school bus in first grade being bullied by some pretty brutal kids. So I don't know that we should just automatically trust children, but that was that was one of the things that Mather felt he had going for him, that he got people to...
Well, Jack, that's the old Neil Brennan joke. He says, as grown-up Catholic, I didn't get molested, but I did fuck a couple priests.
All right. Well, that's not part of my presentation. But anyway, so I bring up the early colonial history so that you have some perspective. These things go deep. But I think an important thing, a lot of people who write about conspiracy theories, one of the most famous people was a professor at Columbia, Richard Hofstadter, and he used to always emphasize that a lot of times it was very fringe people, very fringe right-wing people. But actually, I think in a lot of earlier American history, there was a lot of mainstream conspiracy theories. And just as an example, well, there's Cotton Mather, by the way, in Spider-Man, the character. He does become a villain. Some of you probably follow the comics and, see that. So what I wanted to say was, for instance, George Washington in 1774, just before the Revolution, he spoke of a regular systematic plan to make us tame and abject slaves. So Washington had this notion that the British monarchy and a certain amount of European elites were conspiring to really curtail the freedoms of people around the world. And then when Washington and John Adams, and they rose to power in the early republic, they were often in some terrible fights with Thomas Jefferson, who was in the other party. And again, they accused... the followers of Washington and Adams accused Jefferson of being a follower of the Illuminati, which was this group that was seen behind the French Revolution and a lot of radicalism around the world. And, this was a group that was founded by a gentleman named Adam Weishaupt, who was from Bavaria. It actually really disbanded in 1784, but lots of books were written about this conspiracy of the Illuminati, and we hear a lot about it today. Pat Robertson, the preacher, in 1991 did a book called The New World Order, and he talked about how the Illuminati was a satanic scheme, and it was very much the forces of Satan supported by the insider Illuminati against the Christians. And, this was a very big idea, a new world order. Of course, George Bush, the father, he used to say the terms a new world order, and there was lots of warnings about these were code words for the Illuminati. So people would hear this and it would really alarm them. But you know, the 19th century, there were a lot of conspiracies. Some people say a lot of them surrounded, they said Masons, Mormons, and Catholics. The Masons were the Freemasons, and they were seen as part of the revolutionary ideas and sometimes secular ideas. The Mormons developed their religion a lot in the 19th century, and there was a lot of hostility to them. And of course, the Catholics, tremendous amount of Irish immigration. There also was a lot of fear of what Lincoln would talk about, and this is why it's a kind of a mainstream theory. Lincoln would often talk about the slave power and its power, and you know, slavery was maintained in the United States, but there often were very conspiratorial ideas about how it held its power. So that's why I'm sort of saying people who always write about conspiracy theories as fringe, there's a lot of cases where it was a lot more mainstream. And some of these things go pretty late into history. People forget this. The year before John F. Kennedy was elected president of the United States, Norman Vincent Peale, who Donald Trump has often said was his favorite preacher, but he often warned if Kennedy gets in, the Pope will be running America. And 40% of Americans in one poll in 1959 said they would not vote for a Catholic, even if they were from the same political party and they agreed with them politically, because the Pope would be running the country then. So, you know, these things can be, you know, very, very deep-seated theories. So going to the next slide, we have H.L. Mencken, and he talked a lot about how statesmen foment a lot of theories of enemies and conspiracies all the time. And this is one of his big statements on this. He said, the statesman becomes, in the last analysis, a mere witch hunter. So there we go, back to the Cotton Mather idea. But a glorified smeller and snooper, eternally chanting fee, fi, fo, fum. It's been so in the United States since the earliest days. The whole history of the country has been a history of melodramatic pursuits of horrendous monsters, most of them imaginary. The Redcoats, the Hessians, the Monocrats, again the Redcoats, the bank, the Catholics, Simon Legree, the slave power, Jeff Davis, Mormonism, Wall Street, the rum demon, John Bull, the hellhounds of plutocracy, the trust, General Whaler, Pancho Villa, German spies, hyphenates, the Kaiser, Bolshevism. The list might be lengthened indefinitely. A complete chronicle of the Republic could be written in terms of it, and without omitting a single important episode.
This guy didn't like anyone.
Yeah, he was a pretty ornery character, H.L. Mencken. But one thing I'll say about him, you know, when it comes to these ideas of enemy formation. For instance, when the Cold War was coming to an end, well, even before that, last year I talked to the Summercon about Report from Iron Mountain. This was a report in 1967. It was a bunch of guys got together and made a fake report saying that U.S. elites were scared out of their minds that peace might break out. It was during the Vietnam War. And what would happen to American society if we weren't at war with somebody? And, yeah. Well, what happened is you read this report. It is kind of funny because they have all these details. Every one of the people who participated in this report, they had to go for a medical exam. And everything was fine except there was an excess of uric acid in most of the participants. And people just read this thing very seriously. And this idea that the elites were tormented by the idea that peace might break out, a lot of people believed it, to the point where these guys were very upset because people then kept following the report. They came out and said, look, this was just a hoax we came up with. It was a satire. And Liberty Lobby kept publishing it. They took them to court. They had all the publications pulped. And they still keep reprinting it. In fact, you can buy it today on Amazon. And there's a lot of true believers. And there's even a new book about it.
Wait, Jack. So when was this? Because when I heard about a report about Iron Mountain, I think about the not so conspiracy theory rumor that's been going around that the document storage and backup company Iron Mountain, for the first decade, had no actual facilities. They were storing boxes of people's documents in apartment buildings. And they were like, no, it's a secure offsite facility that you can't see. And eventually they started building them out, but for the first decade or so, they were just storing them anywhere that they could get the square footage.
Yes.
Yeah, so this is from the 50s?
No, 1967 they did this report, yeah. But the company, that company, for various times has flourished. Phil Tinline did this new book from last year, and he proclaimed it the hoax of the century. Some of you may dispute that, but it was a pretty incredible thing. But I'll say this idea that sometimes our elites have, that you have to have an enemy. Samuel P. Huntington, he was professor of political science at Harvard. He was a national security advisor to Jimmy Carter. He wrote this book right at the end of the Cold War called The Clash of Civilizations. And the article came out originally in 1993, but Huntington went on and on about how liberal democracies become flabby and undisciplined when they don't have an enemy.
I am not a liberal democracy.
Okay, there you go. He was very worried. And, he talked about how we would transition from the conflict with communism to conflicts. He thought we would have a lot of conflict with Islamic countries, but there'd be other rifts in the mix. And, he went on and on. But it's interesting, especially in his interviews, he really stressed this idea that you needed enemies. And so, in a way, this hoax was kind of forecasting, things to come. Just to move forward on a couple of other things. Some of these, you'll maybe have more familiarity with this. But Wall Street Journal very recently did an article on the rise of conspiracy physics. And there's a lot of groups. This woman, she's a theoretical physicist, Sabina Hassenfelder, and she's really down on string theory, which has been, very, very strong theory in physics. And she says string theory is not dead; it's undead, and now walks around like a zombie eating people's brains. And the physics community, there's a lot of conspiracy theories about physics right now. One thing that's provoked some recent ones, she has 1,720,000 subscribers to her page, and there's another guy named Professor Dave. I think he has 3.5 million. So a lot of people are following these physics debates. But one of the things that's come up is with string theory. You hear a lot about the Epstein files, and there's a lot of conspiracy theories about those. But Jeff Epstein invited a lot of the world's leading physicists to his island. And while I personally don't think there was anything of his more lurid sexual activities going on, and people could dispute that, but he would bring Stephen Hawking there. And I know from our department, physics, Lisa Randall, Harvard physics person. She was the most cited physicist in the world for over a 5-year period, and she was there, and she's having to deal with a lot of difficulties from people because she had a long-running correspondence with Jeff Epstein. But some of the physics conspiracy theorists talk about how Jeff Epstein was involved in plots to try to disrupt physics and not allow...
Well, he's well known to have invited the juggalos on the topic of magnets.
Okay.
Actually, I have been to Epstein Island. It is Little St. James, and it's...
That's not surprising.
So it's about a third of the way between St. Thomas and Lake St. John, and it's a great place to get a sunburn.
Okay. Yeah. All right. I'll keep that under advisement. All right.
It's a very nice island. What can I tell you?
Yeah. But one of the things that I want to say about conspiracy theories, when people come up with one, and the report from Iron Mountain kind of demonstrates that, it's very hard to then reel them back in. And this has become a significant problem for Donald Trump with QAnon. Trump had often been relatively friendly, retweeted a lot of QAnon things. And they were one of the big architects of conspiracy theories.
Yeah, they were like, I can't believe it's not butter is not butter. That's insane.
Yeah, and they rose up. You know, part of it was John Podesta, who was a Democrat operative. Someone spearfished and got a lot of his documents, and thousands of them ended up on WikiLeaks. And built out of that, they started making the accusation, QAnon, that Hillary Clinton, I think she kind of had Anthony Weiner in it, and Podesta, who was a Democrat advisor, were running a child, trafficking ring out of a pizza restaurant in Washington, D.C. What was it? Comet Ping Pong Restaurant. And of course, a guy showed up with a gun to take down the place.
Yeah, he showed up with an assault rifle.
yeah. And the guy...
It was not a Derringer. He wasn't like, stick him up.
Yeah, he was loaded for bear, as they say. And his argument was, with the owner, and the owner says, listen, you keep saying we have a basement where all these children are being kept. We don't have a basement at all. Go and look. And I think the guy who came did feel a little bit remorse and sorrow, but of course by then he was arrested and in a lot of trouble. But this is the thing, I think Trump has had this problem where he ran with a lot of conspiracy theories with Epstein, with QAnon, and now some of the people who have been propagating the conspiracies are upset that he's not fulfilling, half the documents from Epstein files have not been released. Trump, really made a lot of loud efforts to say during the campaign that he was the one who was going to be transparent and release all these things, and then he somehow changed his mind. And while his administration often says a lot of the documents are just duplicates, it's, a thing that, has not been... good for Trump. It's cost him.
So I have an anecdotal point to this. When this breach happened, a good friend of mine was the security advisor person on the Hillary campaign. And I actually got called when the breach happened because they didn't have a contact for CrowdStrike or for Mandiant. And I had to put them in touch with them. So, before this had hit the air, and at the time, I was also the CISO of Fox News. So, if that breaks your brain a little bit, it's intentional because it's a weird world. Yes, that is my anecdotal point to that. This it feels more like a conspiracy, and I can promise you, it was just incompetence.
So. Here during the lockdown, of course, during COVID time, and it's often big upheavals, wars, economic disruptions, something like this, a great public health crisis. It sometimes feeds the growth of conspiracy theories. But here's an example, of during COVID time, you see the protests. The lockdown is every pedophile's dream, child lives matter. So this theme really captured a lot of people. It was interesting, in early 2020, there was a poll that showed that only about 2% of Americans said they were familiar with QAnon. But by late 2020, there was even a poll showing that 30% said they agreed with a lot of their theories and things. So, it caught on. But you can see in COVID time...
I mean, who doesn't love pizza?
Yes, there you go, and there you
And
go.
thanks to Bishop Fox.
Here you go.
For supplying pizza.
Yes, it's smart. Pizzagate is real. Do you even queue? Here's another example. So, these are very, profound things, and we'll turn to.
Am I the only one that's looking at this picture and was just thinking like, she's kind of cute, right? Like insane, like kind of cute.
Okay,
Yeah,
I'm sorry.
yeah.
I don't know. She looks pretty stern to me, but maybe that's your type, John.
I'm not saying that I would ask her to smile more, but
Okay. All right. I don't want to go there.
All right.
But I want to just have a few reflections because I know the pizza's getting here. James Madison, our shortest president at 5 feet 4 inches, he did write this note where he said, "A popular government without popular information or the means of acquiring it is but a prologue to a farce or a tragedy, or perhaps both. Knowledge will forever govern ignorance, and a people who mean to be their own governors must arm themselves with the power which knowledge gives." And I think this would probably be a great frustration to him. As much as I explained to you, there were a lot of conspiracy theories swirling in his time.
Sure, that he was great at karaoke and not good at writing. Yeah.
Okay. But
he did draft the Constitution, for those of you who...
But I think we've got to see that there's, tough struggles ahead because some of the conspiracy theories have become so outlandish. QAnon with Pizzagate, one of their big theories was that these children, they not only were being sexually trafficked, they were being taken in for adrenochrome. I think there's also a new rock band from Oakland, 2017 punk rock band with that name, Adrenochrome. But the
that
idea
sounds exactly
was,
what a punk band from Oakland would be called.
Yeah, the idea is that Hillary and her minions, and Katy Perry was even named in one of the things, they were taking this...
The astronaut Katy Perry?
That's right. Adrenochrome was being taken from the brains of the children and then pumped into older people so that they could permanently stay young. And so these are the kinds of theories that come out there that are just so out there, and it's, a very frustrating thing. There were a lot of beliefs in the early post-war years that some of the conspiracy theories were going to go really into big decline. A lot of people said the GI Bill sent 2.8 million GIs to the colleges. We had a vast expansion of universities, and people were going to supposedly learn how to sift out what was true from what was fake. And, we had...
Things like O.J. Simpson totally didn't kill his wife and a waiter?
All right, well, we can talk about that later on. But no, so, the question is, for a lot of people, very hard to think about, what a society can do to develop in its broader population. Madison talking about developing the knowledge and the critical tools that they can evaluate things. And, there was a lot of mockery of conspiracy theories in the universities to the point where sometimes I think academic people were so dismissive that it turned off a lot of the public. I remember G. William Domhoff at UC Santa Cruz. He studies elites and power. And he's a sociologist and psychologist, and he would write a lot of books, Who Rules America, books like that. But he said, I'm very frustrated because I show the power networks and connections of people, and then a lot of mainstream liberal people in the universities dismiss it and say, that's a conspiracy theory. And he says, they bark it at you like they're just accusing you. Well, that's a communist argument. We can't hear that. And I think people just feel there's so much dismissiveness that they're not listening to them. I admit, the John Birch Society in the late 1950s, Robert Welch, he was a candy manufacturer, and he did a book about President Eisenhower called The Politician, and he said that Ike was part of a vast communist conspiracy. If not, he was a dupe of the communists. And I remember William F. Buckley, a fellow conservative, but he didn't buy it, that Eisenhower was this off, and he said, well, Eisenhower was a golfer, and we all know that golfers cannot be communists. So he just completely dismissed it. But
golf, a game that was designed that the exception was that everybody can play except for blacks and Jews.
Yeah, a lot of discrimination with golf. But that was Buckley's argument within the right, and he thought he really shut down the conspiracy theories. But now a lot of them are so back. There's a religious dimension with people like Pat Robertson. Pat's no longer with us, but his followers continue to distribute the New World Order. And it's very tenacious, a lot of these theories. And part of it is people don't trust our leaders, and they're very unhappy a lot of times about very real things. And so people are very susceptible to beliefs that, can be incredibly extreme.
But they're not necessarily conspiracy theories.
Yes.
All right, so a show of hands.
Okay.
Who heard when they were growing up that carrots make your eyesight better? Right, this is the thing that my grandmother believed emphatically. Carrots don't do shit for your eyesight. It turns out we invented radar, and we had to have a good answer for the Germans as to why we could figure out where their planes were. So we introduced a disinformation campaign that carrots make our pilots' eyesight better. Not everything is not a conspiracy theory. Some things are real. Like when I was growing up, at least in the 90s, the hacker scene.
Don't tell them.
Well,
We also want to get pizza.
I mean, I kind of have to tell them. I think they know now. But until the Snowden leaks had come out, it was a conspiracy theory that there's Echelon, the government's monitoring all the communications in and out of the country. They're using foreign it was a conspiracy theory, and then it turned out to be true.
You can't talk about any of this.
Okay.
Hey, stop.
All right. We've reached the end of time. I'll be around. People can ask questions. I'll be around. So happy to answer questions. We probably should have given you a little more time for participation.
No.
But I hope this overview was of some value.
Jack,
even though
it was fantastic. Fantastic. Thank you.
Okay, pizza is happening now. No, pizza.
There's pizza happening now, or we
just before we bring these guys on, we'll
do we want to give stuff out after, before? What do you want to do?
We'll do both. Whatever.
We're gonna do all at the same time. One thing I
Why
did want
not
to say.
both?
One thing I did want to say is this: anybody uses Meshtastic here? If you're watching Meshtastic, if you come up to me and tell me what the Summercon secret word that has been going out on the Meshtastic Long Fast network, I will give you a drink token. First 10 people will get a drink token. So let me know what that word is, and I will token you up. I have them. Just find me. I will give you a token. Okay. Okay.
Otherwise, I think it's pizza time, a question mark? Yeah, we are. It's pizza time. But I assume not everyone's going to go get pizza right at the same time. I think we have some other things to give out while people get those. Yep.
So this is an Uncle Sam, what appears to be a medium-sized length.
Yeah, men's then.
Yeah.
All right. Let's go. Sorry, Steve. Oh, this one's really cute.
These are actually some of my favorite shirts.
Yeah. Actually, I think
So
this
this
is
is Summercon. This is Fight Scurvy. And this is a medium, so it's not my favorite shirt, but a smaller person's favorite shirt.
The cool, cooling material, unsweaty. Oh, dude, setting up quickly. Who wants one of these? Oh, yeah, look at that. I feel like I'm getting better.
And this is a condom. No, this is a onesie for anybody that is expectant or
And it
knows
is
anyone that is.
Black on black. Classic.
Anybody? This doesn't look like a group that procreates that often. So, all right, we will hold this one back.
What?
All right, let's see what else we got back here.
All right.
We've
We will
got.
actually here. Who wants a shirt? It's a small one. We're going for it.
It's an arm to shells, though.
I'm just going to throw it, and then you'll have to catch it. Yeah! Ah. Damn it. Sorry.
But this is the real prize before we let our speaker come out here, is another beach towel.
Oh, a different beach towel.
Because beach please.
That's very cute.
Now this is the kind of thing
Back in the
that you
exploit
could
mines,
pass
friends.
out on top of or under. You could hide yourself like a
Throw it.
ghost.
Throw it. There's
Yeah.
interest. Well, that's a good plan. Do
I,
it. Do it.
I do not have that kind of coordination. All right. Oh,
Oh, that's it.
congratulations,
far.
you got a towel.
Well, I hope you guys have gotten
And I
some
promise that was not racially motivated.
drinks. And that is
Well,
your time to exit,
I
friends.
gave it as a caveat after the fact.
Stop. Anyway,
Next up,
thank you, John.
we have my friend. We got some good chatting done in the back room. It was great. Aspiring Swiftie. No.
Just aspiring.
Just aspiring. Shad Malloy is a consultant who's worked on industrial and SCADA systems since the 10 base 5 cable days.
Yes.
In spark plugs, mosquitoes, and robots, he'll be speaking to fuzzing protocols running on half of the smart factories on the Earth. Hack the planet.
All right. So, I used to work for this guy right here. He abandoned me, so it doesn't count. so,
It's your fault.
It's just like my dad. He ran away. So this is technically myself and the David Collion. He's not here. Bishop Fox, we test things. You can go find one of the salespeople. They will sell you a test. I can't do that. So we're just doing this as a tool release, and we're going to talk about what we did. We don't want to sell you. I don't want to sell you things because I'm lazy and I don't want to work. That's the agenda. Okay, so like take a second. David Killion, he couldn't be here. There's nothing wrong with him. He's just in Japan screwing around. But, you know, pour one out for our homies. You can hand me the remote mic. I like to move around. Okay. So work now? I don't like to be tied down too much. So what happened was we were testing a manufacturing client. They basically said, you can test anything you want. David called me and said, hey, I think there's this spark plug client. I don't know what to do with it. So the trifecta is it's an anonymous broker, which means anyone can publish data and anyone can become any host on this network. The devices accept like mid-auth or like kind of mid-sequence. You can just take it over mid. There's no like collisions or anything. And also, they're connecting their enterprise network directly into their sensor network. Don't do any of these things. If you were running a sensor network, just don't do those and you'll be fine. So MQTT, also everyone else who, I was shamed yesterday. I walked to all of the other speakers' talks. They were great. I immediately went back to the hotel and added a bunch of these slides. Like I was just gonna come up here and like throw it together and nobody else had done that. So this is a like version 2 better slide deck. So Sparkplug runs over MQTT, commonly called Mosquito, which calls back to the name of the talk because we're funny. So basically what it does is it takes a protocol buffer, with the protobuf smashes it together, makes it very short, but instead of having like a humidity sensor, which I have some in the back there, we're gonna show that during the demo. The field name will be like 1, and at the end, it'll know that 1 is the humidity sensor, and then it'll put the value in there. So without like a defining thing, with just like a number, super great because you don't need to know what it is, you just need to know that it's a 1. And then the topic namespace, which you can just sniff, which is great. So this is an example. So like Sparkplug B version 1, the group, we're gonna show a couple groups, the message type, node names and device names. That is what you will see on the network. So it defined fields in a binary format, it's great to fuzz. And then it had 9 message types, 19 data types, and the 87 fields. So here's some stuff we're talking about, protobufs. Does anyone actually have questions about protobufs? So what we're going to do is you take it, it's going to like serialize it into a binary protocol, it's going to put it on the wire. The great thing about using like XML or JSON is you can look at it and tell what it is, field name value. This is just a string. That's harder to look at, but it's also great for people like me who are trying to break things. So opaque and binary, love that. And the same bytes can be reinterpreted differently. So we're talking about if it's a 1, 2 different things can use that, but differently, because when it hits the protobuf, it pulls that type of data in. So great for interoperability, and this is what is actually good for is, let's say I update something later on, and I add like field 3. Old things that don't know about field 3, it'll just ignore it. So it's great for like interoperability, going like forward and backwards. But it also leads to type confusion, which means I tell it it's a 1, and I send it a value of 100. One thing thinks it's a temperature, one thing thinks it's humidity, bad things happen. And we're only going through really fast because it's the end of the conference. There's free pizza back there. You guys don't want to be listening to me. Okay, so this is a direct quote from me, and I say this a lot. My code is like an 87 Honda. Like, it's going to get you where you're going, right? We don't want to look under the hood. You don't need to know what's going on underneath there. So, what had happened was, David messages me, hey, you got a fuzzer for this? Yeah, we're going to make a fuzzer. I go out to Eclipse. Eclipse is the people who run the Sparkplug. I pull down their sample code. I take their sample code, I look at it, and I was like, oh, I'll throw like a word list in here. Not a big deal. But then my company, Bishop Fox, had just bought me a Claude license. So I take my code, I give it to him, he finds a couple findings. And I'm like, I wonder what Claude can do with this. Like, let's go bully this robot into doing some things for us. And it comes back and it's like, basically, you're dumb. Do you want me to do this for you right? And it's like, you don't know me. Yes, absolutely. So we're going to show this. But so like, this is our literal conversation here. He was like, hey, what can we do? And I was like, well, we can ask for an endpoint because you don't want to fuzz a live endpoint and break something. And he's like, it's a test environment. And I was like, please hold. And this is literally, I talk and write it the same way. Like, we're going to YOLO some Python. So this is the literal code. This is the before. This whole section right here, that worked by accident. Like, it only worked because I called that client.connect a second time. Like, that first one, that's not right. Obviously, it fixed it. I don't know how many people here have done threading in Python. I did it one time, and it worked right, and I copy and paste that. Like, that's one of the things where it told me, like, that's Python 2. Like, why are you doing that? We're using Python 3 now. And I was like, excuse me, one of us can shut the other one down. So this is all like the literal list of problems. I'd set up this wrong, the connection only worked by accident, my threading was bad. I only fuzzed 2 of the 19 data types because that's where I threw the word list in. Did I do a CLI? No, it was just a straight script. I didn't do the discovery. It's a self-mapping protocol. Like, as long as you're sending it, you can map the whole network. I didn't do that. And I didn't log anything. So when he had to go back and write the report, he had to like rerun it and capture the packets. So I swear Bishop Fox does better work than this. So how are we gonna fix this? And like I said, he used to be my boss. So I gave it everything. I gave it the protobuf file. I gave it my junk. I gave it the spec. And it's like, here's all the things you could fuzz. These 9 message types, 19 data types, 87 unique fields. And it asked me, like, do you want to fuzz this correctly? And I was like, yes. Don't shame me. And we're going through a little fast because we've got a demo. We're going to pop some stuff on stage. So it built the Sparkplug B helpers, which were great because Sparkplug B, it does the things that it's supposed to do in the way it's supposed to do it. Obviously, low-level stuff, the valid payloads are going to get accepted. Invalid payloads are going to get rejected. So we had to go underneath it to build that helper library so we could do things it wasn't supposed to do. That's being a pen tester, that's being a hacker. Like, what can I make this thing do? Not what it was designed to do. I've talked to multiple developers, and I'll be like, oh, I put a -6 in there. And their answer is always like, well, why would you do that? And I was like, well, why would you let me do that? Like, obviously, I'm going to try to break your stuff. Like, I don't even care that it gets broken. I'm just here for the chaos. So, and then we added a device tracker, which was basically it would subscribe on the network with a wildcard name, and it would build out a map. We're going to show a map here in a second. It's the same network, but we didn't build that live. All right, where did it help? Like this is where AI actually helped me. So what we owned, you can do AI. You have to know what an alias collision is, and not just an alias collision. AI is good at doing things that you tell it to do. It was good when I said, I want to go break this thing. You got to help me break it. Don't actually tell it like the guardrails will kick in, but you can lie to it. Lies are the lubrication society runs on, so lie to it. So recognizing that the OT bridge, so like bridging the 2 networks, like AI didn't understand bridging an enterprise data network into an ICS network. Bad idea. You just have to know that. And then where I did bad things, it like knew that. So it did well. It really did. Like, I was never going to read that protobuf spec. It wasn't going to happen. My fragile loop, AI is like an intern. It's read all the documents. It codes really well, and it's really enthusiastic, but it doesn't know what to do. You got to guide it. So I kind of guided it to where I wanted it to go. Anyone here love writing documentation? I was never going to do this. I was never going to write that README, and I was never going to write those documents. This guy. I don't know. So I have some ping pong balls back here. I'm going to find you. I'm going to throw a ping pong ball at you. So I don't know. So mermaid diagrams, another guy that I work with showed these to me. So it's basically like kind of write some markup and it spits out these diagrams. It was awesome. I was never going to do that. It was like, do you want me to write a mermaid diagram? And I was like, dude, of course. Come on. Like, don't ask me dumb questions. So this is what the mermaid diagram for the tooling, like this is literally what it's going to spit out. If we were running it for this setup is I have a gateway running right here. There's 3 sensors in the back. Obviously, so there's an infrared, humidity, and a light sensor in the back there. And then it has the group names. One of them is called IamHost. That's dumb name. As you can see, I'm super creative. My fuzzer node, it's called fuzz node. And then the EG4 is this default one. But if you run this on a huge network, it will spit this diagram out. And it would show like multiple nodes, multiple brokers, all the hosts, kind of everything you need to know. Because it's a self-mapping protocol, and it can draw pictures for you of a self-mapping protocol, you can take this to some engineer and say, look, this is where I broke your stuff. And in theory, they will fix it. So I got started in industrial controls. I mean, I was born at a very young age, and then I did some things, and then I did industrial controls. So I would make networks work. Like, my job wasn't to go back and make them work perfectly. Like, I got paid and given a certain number of hours, and everyone just is trying to make everything work. And unless you're like telling them to make people secure, I wasn't doing it. So I would not even blame these people, like, because these guys got it working, and that was what they were supposed to do. Oh, we got to go back 1 second. Okay, so the things that we're going to look for later. So N stands for node, D stands for devices. So there's things called births. Shockingly, it's when you birth yourself onto the network. You're like, hey, I'm on the network. I'm getting ready to do things. And then there's also deaths, where you're like, hey, I'm done doing things. Don't listen to me anymore. So this is also a quote from me. AI can't do things. AI is never going to have that creative spark, that jump that everyone here can make. So it's like, I kind of know what I'm going to do, and I'm willing to take all these other parts, smash them together, kick them a few times, and poke it through the hole and make it work. That's kind of the interface between AI and consulting or pen testing or hackers, is you are the creative spark. And it is the thing that can help you get there. So also raise your hand, except for this guy, because he's writing documents. Raise your hand if you have a project that's 70% done, and you're like, I don't know how to parse that data. You hit a wall where you're like, I don't know how to get there, right? That has outcoded me. So AI can help with that because it knows how to parse data. It knows how to do pattern recognition. So use it for what it's good at. And also don't have it write findings for you, because I have to read people's findings all the time. And I was like, look, bro, you've never used the word surface or pattern in your life. So I know that AI wrote this for you, and stop. Because it's just slop. Don't send people slop. All right, so we're going to do demos, results, defense. So there's 9 message types. There's 19 data types. There's 87 fields. So this is the Monit gateway down here. If you are super creative and watch, you're going to see a couple ODAs get dropped right here. You don't have to be super creative. They're the ones in red. So basically, we're going to fire this up. And we are going to demo. So this is what you're going to see. You're going to see it. I'm going to come up and I'm going to impersonate this EGW4 gateway. It's going to send data before and after it's birthed. It's going to do a death, but it's going to send data after its death, so it shouldn't be obviously run. We're not going to authenticate to anything. And then also machine state, I'm going to publish things that I shouldn't, right? I'm not registered on the network. You shouldn't be publishing. I'm super creative, so this is obviously up. All right, so those are the sensors in the back. These are literally sitting on the speaker back there. You can see it's coming in. That's the real network over here. Let's make sure we're in the right pane. So we're going to do so this is the full fuzzer. It's going to run for about 15 minutes. We're going to kind of chat as everything goes by. We're going to talk about all this stuff. So it's basically blowing data out onto the network right now. Some of them say EGW4 with the fuzz node is the device type. Some of them say fuzz node with the fuzz device. Those aren't registered on the network. I'm just literally making these up and sending them out. One of the things that kind of added on later on, you're going to see second order things come through here, which is this data is useless on its own. So these get ingested in either a logging system or a human machine interface. See all those A's go by right there. So the other thing you're looking for is second order things like logging injections, like log4j. Old systems still use it. Nobody updates their industrial controls. And if they go into human machine interface, those people aren't looking for cross-site scripting. They're literally just throwing it together. Right? So as you see these violations go by, I think there's some coming up. If not, I have a special one where it's only the hotness. So does anyone have any just general Sparkplug questions? This takes a few minutes to run. Look at all those nice violations. So you also should escape like your terminal characters. So those ones that say red right there, like that is literally injecting code in that would force a terminal to print out red. And it worked, and I know it worked because I didn't escape it the first time I did this, and I was like, why is it in there? So like I was injecting myself. So there's,
excuse me?
It's a very good, so it's a unmanaged attack surface, which is great. If you would go out, not that I ever would, if you go out on Showdown, look for Sparkplug or MQTT. There's a lot of trucking companies that use this. So you can find this out on the internet. You could fuzz this.
I had a question. About Sparkplug.
Sure.
Yeah.
Yes.
Yeah. So the question is, why was there no client authentication in the first place on Sparkplug?
Like, why was there no mitigations?
Yeah, no client authentication, because usually MQTT supports those kind of situations.
Oh, it supports it. So, like, we're going to talk about it. It definitely the difference between is it supporting it, or did I do the bare minimum to make it work?
Oh.
And I feel like this network I got it working. Like, did I use mutual TLS? No. Did I do an authentication packet? No. And my personal opinion is, it's not Sparkplug's responsibility. They don't do authentication. It's MQTT's responsibility, but whoever did that isn't getting the sensor data from Sparkplug. So it's kind of everybody's responsibility to do it right. And if it's everybody's responsibility, it's nobody's responsibility. So like nobody owned that risk category in that company. So once they bridged it over from one network to the other, whoever owned the MQTT transport was like, that's not my data, that's Sparkplug data. And Sparkplug was like, I don't do auth, MQTT does auth. So it needs to be tracked as a risk. I mean, I'm gonna make some people like cringe here, but you gotta put it in your risk tracking register, you gotta do stuff right. Or not. Like I always tell people, so like if I'm having a bad day, clients are having a good day, right? Like if I'm not finding anything, you're doing your job right. If I'm having a great day, your company is having a bad day. It is a plethora of shells coming back. The term I like to use is I'm popping shells like a stripper turtle. So if I'm having that day, it's great. So we ran it all through, everything stocked. We only want the really cool ones because that's what we're going to talk about here in a second. So that's the on-stage money shot. So these ones, basically publishing data before birth, publishing data after death, publishing data, basically spoofing data. So these are basically ODAs. Like you would go to Monet and say, your MQTT is not handling this correctly. So right here, did we provide any credentials? No. Is it anonymous connected accepted? Yep. And could we subscribe? Yep. Here were the 4 things that we found. I dumped out the log file. There's a picture in there. I'm not going to go get it and compile it because it wasn't part of the demo. Okay. So this is what we did. So it's not the defense layer. So I'm standing up here telling you how terrible Sparkplug is. Sparkplug did exactly what it was designed to do. MQTT did exactly what it was designed to do. It transported this. But it's a dumb relay, and that's fine. Sparkplug isn't the auth node. That's fine. The problem is you can do a few things. You can do these ACLs. We're going to talk about that. You can do mutual TLS. That's more on the MQTT side. Do you want to do client cert bound identities? That's a little difficult, especially as we're reducing the time for certs. Like a 90-day cert, rolling these onto all these devices, probably pretty difficult. And then you can do like host side sequence validation. A little more difficult, but it's built into the protocol, so you could do it. So fixes are boring. I used to work at the government. I used to be on the blue team. Nobody likes fixing things. I like breaking things and giving people a report, and it's like, dude, your stuff is broken. You should go fix that. I gave you a couple recommendations. They're probably trash, but I don't have to work on it. I'm going to be on another client next week. So what did you do? So enforce TLS. That's probably like mutual TLS. makes like pen testers' lives hell because we don't have that cert. Require auth and kill anonymous access. Those are like just basic kind of network hygiene. So topic ACLs are great. You can't impersonate another node. So I couldn't inject that fuzzer node and I couldn't inject that EGW4 if you didn't allow that. So also validate the protobuf and enforce data types. Like these are like for all of you coders who are like, if we're looking for numbers, like, and they're trying to send me letters, I just put a regex on there and reject the junk. So sequence numbers, every time something sending a sequence number, if I'm starting at sequence 0 and you're expecting 4,000, like there's obviously something wrong on the network. Somebody should go find out why that device reset without doing it correctly. And then log these births and deaths. Because if births and deaths, if you're doing things before and after when you're not supposed to be, like either your things are broken and you should figure out why, or somebody like me is in your network just doing weird stuff. And then segmentate. Okay. Everyone, you just segment your networks off. For everything, not just for this. Like network segmentation fixes a lot of problems. And it is difficult. Network engineers don't like it. It adds time and effort, but it does fix a lot of problems. Okay. So we already talked about this. Sparkplug relies on MQTT for auth. And here's the types of auth that it can do. It can do username and password, probably the weakest, better than nothing. It's clear text, but if somebody's already sniffing your network and it's segmented off, you have bigger problems than this. Server-side TLS, great. Makes it harder. Mutual TLS, that's the strong option, do that one. Also, it makes it where you're like, I know which certificate I gave to which device, and if that device connects, I know who it is. So do this one, and MQTT5, which is the newest and greatest, do that one too, because it does like challenge and response, and you can pass JWTs and tokens. It's a more mature, obviously fifth protocol. It's better. So the auth gap, this is really important. So it doesn't solve the spoofing issue. If you can get auth to the gateway, so like if I can just auth as this gateway, then I can just do anything that gateway is allowed to do, which is mostly just publishing data for all the devices that it's connected to. So because auth doesn't fix everything, TLS doesn't fix everything, but if you layer them on top of each other with the ACLs and the auth, it gets you farther. So birth and death certificates, that's where we really killed it. So if the big issues we saw were publishing data before the birth certificate came out, publishing data after the death certificate. Also, when you publish your death certificate, it resets your sequence to 0. So that's why we were talking about looking for a sequence. Because if I reset the sequence to 0, and I'm not supposed to be talking on your network, and then you start getting more packets with either random or all one sequence, it gives your incident response guys something to check out. So obviously, don't allow this. Check these out, and I know there's a guy who just left to go do an incident response. I do not do incident response. I hate incident response, and if you do that, I feel sorry for you. There's a few things on my resume that I specifically leave out, and if people are like, hey Shad, can you do incident response? I'm like, I have no idea what you're talking about, and I don't know who you've been talking to, and shut up. It goes up there, it's up there with PCI ASV, and they're like, didn't you have that certification? I'm like, I have no idea who you are, why you're even talking to me. Don't make me get a restraining order. So this is how it works, right? This is kind of just the high level. How it works in general, you send a birth certificate, it gives you the sequence to 0, everything's online, you send data, either node data, ends or nodes, these are devices. It tends to go offline on this side, online over here, and as you send it, updates the sequence. Notice how I use the correct C++. So data before birth, bad. Data after death, bad. Duplicate and spoofed things, bad. And then aliases and collisions, which means I'm publishing something to a topic, let's say the humidity sensor. If I'm publishing humidity data and then there's already one online, why am I getting duplicate data? And all of this stuff is because it's in clear text and you're pushing it into either a logging system or a human machine interface, should be pretty obvious. And that the device doesn't, so everything. Oh, so the question was, does the device know the difference? And because of the way the protobufs work, it does not. It says, I am a device. I send field 1 a value of a 100. Field 1 in the protobuf, when it comes online, it tells them, I am a humidity sensor, and field 1 is humidity, field 2 is like the value. So it doesn't know it's humidity. And when I'm fuzzing stuff on your network, I don't care that it's humidity. I'm just blasting things out into the ether. So that's why it's such a ripe target for fuzzing, is the way they smashed it down to make it a very lightweight network protocol, kind of abstracted the data. So it's not like JSON where it's like, humidity, values, temperatures, fields. Like it's much more compact, which makes it great. But it also removes some of the information that you and I could look at. Did everyone get that? Did everyone get the question? We can just jump in. You can just yell at me, throw something. We're going to talk about why industrial protocols, why we chose this one. I chose this one because David Collion said, hey, can you write a fuzzer? But we slapped this slide together, so there was no public fuzzer. We wrote a public fuzzer. So there's the GitHub. You can go there. You can get it. I have a PR in. I'm not allowed to push to my own repo. So I don't know if they did it before this conference or not. It has a couple of fixes in it. So I wrote a blog post. I made Claude. I bullied the robot. I took our formatting. Here's what our blog posts are supposed to be. I took my notes and I was like, hey robot, write me an outline, and it wrote me an outline, and then I slapped it together. So like I said, don't let robots write for you. Also, find me later, because I might already be fuzzing your protocols. And if not, if you're like, hey, I got S7. If you're fuzzing S7 and you want some more O days, I got some. But if you're like, hey, I'm doing Allen Bradley, I'm doing Genius Bus, come find me. We'll write a fuzzer for it. I don't know if you can tell, I like breaking things. So break your stuff before somebody else does. One, because there's a lot of bug bounties out there, you can make some money. And two, you don't want bad guys doing it. We're going to talk about some bad guys here in a second, and kind of the two categories of bad guys you got to be worried about. All right, before you go get pizza, so there's two types of bad guys that you're going to be worried about, because you're like, I don't care about industrial controls. I don't do industrial controls. So you have nation states. How are you going to prepare the battle space is what they're going to do. So Stuxnet, what they did was they ran the centrifuges a little too fast on and off harmonic, broke the devices. This is what you do with these. You tell it, hey, your humidity isn't 52%, it's 54%, and you run it a little too hard or a little not hard enough, and you ruin devices. Or I believe maybe a month ago, 6 weeks ago, they dumped too much chlorine. I believe it was totally not Iran. Dumped too much chlorine into a water treatment plant. This is the sensors that you would do that with. You'd say you have X percent of chlorine, and it's either too high or too low, and you get the system to change it. So these sensors feed into systems that feed into real devices, usually valves, controllers of some sort, and you can mess with those processes. So if you're not a nation state and you're just a jerk. So the reason you can buy those temperature sensors is because they put those inside container crates, and they ship them for, it's called cold chain, which is a lot of medication, a lot of food, where your temperature has to remain between the certain time and the entire transportation. And I'll just say, oh yeah, you were 31 degrees, just how you're supposed to the entire way. And now you get your container somewhere, and now you got a bunch of bad bananas. Does it ruin anything? Does it ruin somebody's day? But it costs money, and it just lets you be jerks. Also, don't be jerks. I eat a lot of bananas, so it's a real problem. Also, let's go fix problems. Actually, I'm not. Let's rephrase that. I will find problems, and somebody else can go fix those problems. You don't want me to fix your problems. Have you seen my code? I couldn't even get those loops to work right. So I'll break it. You guys fix it. We kind of burned through this a little bit quick, I know, because there was pizza back there. It got delivered early. And we wanted to get you to the pizza. It was my company that paid for it, so I'm supposed to shout that out. So go get pizza. If you don't have any questions, we can answer them right now, or you can find me. I'll be wandering about, and I'll answer them then. I'm here all night, folks. Tip your waitresses. So.
Yeah, we can do let's just. Oh, you want to? I guess Mark's here, the real parent. We don't know. It's fine.
Hi.
Just take this and I'll use the one.
No, I see it.
Question.
Question.
Okay, question. We're doing it.
Yes, we're doing it live. Okay.
Have you looked at these controllers for AI data centers before?
From data center, like directly from a data center? I have not. So most of these are usually live like off networks. Like they're supposed to be in industrial control networks. If you look at critical infrastructure protection, one of the rules is segment it. Like keep all of your critical information away from like, your email network. I haven't seen that, but I have seen at a lot of oil companies, we'll bring them into like a specific like POP and then like host the data in kind of a data lake there, and then usually use like batch jobs to push it into like a production network where they can like run transforms and stuff on it.
So I can tell you I've seen some, and they talk to Microsoft IoT Gateway in Azure, and they speak the same protocol that you're trying to break.
So I'm not sure about Sparkplug exactly, but I do know those temperature sensors that live at the top of server racks. I do know that they are basically an IC protocol that runs over like KVM or something, right? So if you know that protocol, we should talk. Let's go break it, pop some O-Days. So we'll get a couple drinks in both of us. Nobody will remember who said what. So we're all gonna go to jail. So
We'll continue this at the bar. Seriously, here's a drink to
yeah.
Well, it went somewhere.
Is there anything else I can talk not about this? I have strong opinions about a lot of things. So
I think we're gonna give some shit away, and you can. Do you want a drink token?
I will take a drink token.
Awesome. So we're setting up the most American sport while football is going on.
I am out of the way so quickly. People say that about me.
So that one got turned off, so we're going with this one. So, does anyone know where the first Summercon was? This is our new trivia piece. Yeah, okay. Oh, well, St. Louis. Yeah, if you want a onesie, you go for it. Yeah, perfect. All right, you might see my bag of tricks here. We have another, I swear it's a towel. See, you see the towel side. The Uncle Sam beach towel. It's a good one. Yeah, I can see that far. I'm not gonna hit Amy in the head though, so. Oh, okay, these are very exciting. Big Broker is watching you flippy floppies. Yeah, oh boy, that's a bright light here, yeah. Okay, I can do this. Sorry. Rip. Ah! Rip everyone. Sorry, Mark.
Oh, no. This is great.
We're going off the rails here. And this might be my last thing.
Oh, yeah, this one is good. I'll have it up. So you just talk.
All right.
I do want to say that I feel many feelings when I gaze upon this particular piece of artwork. Some of those things.
They might be pretty, it's a well-lubed shell.
This makes me feel like a man.
I'll give you a mic.
All right, team.
Breaker. I need team members. Graziano, Mizuraka, Colin Mulliner, step on stage. Is Charlie alive?
And
you dead?
one.
You gone?
Potter.
Oh, yeah, we owe you.
All right, R.I.P. Charlie.
Heidi somewhere.
Graz, Colin, get up here. Bring the boys.
Marco.
And is Heidi Potter and her team here?
Yeah, we're about to do it. Yeah.
No, I don't see them. Aaron's gonna. Yeah.
What?
In the meantime, does anyone actually want this tote? Because I'm just gonna put it in the bag. Yeah.
And as soon as we get this set up, we have one last thing to do.
You do have a lot of.
6 on each team.
It's 6.
6 aside, yeah.
In Spanish, that's seis, I believe.
See?
Seis, right?
Yeah.
Yeah, we have.
I don't know.
An expert right in the front row.
I took Latin and Chinese, and I can't speak
Does anyone
any.
know who is actually playing football? I mean,
Ni hao,
soccer
senor.
Let's do next year in Esperanto.
Oh, no, Flip Cup, guys. This is how you can tell I went to University of Maryland. We got to get this drinking game set up correctly here.
So I don't know if everyone here knows what is happening right now. Is this your first Summercon? Raise your hand. Okay. Yes. I see. There's somebody
I see a
who's
bunch
lying.
of liars.
Yeah. I don't know exactly how it happened, but at some point along the way, we started to do this closing ceremony for Summercon, which involved a flip cup competition, and it is so random and ad hoc.
Lo, in the days of yore,
It is so random and ad hoc.
we had someone not show up. And suddenly there
Sure.
was time to
Yes.
fill.
Yes.
And
So,
yet,
yeah.
we had thirsty individuals in the audience.
Now, before we start, I do have one specific announcement. I do need the teams to step away from the table.
Let's stay regulation length.
To just stay back so that we can, because I have something I want to put on the big board here.
We
so that
also
everyone
need to
can
give
see.
Hiram and the AV guys enough space to get set up.
Oh yeah, of course.
Yeah.
So those guys got to do their thing as well. But as the chaos is happening here,
I like this team a lot.
I just want to, if we can show the slide. I want to thank Dawn Boiseno for all of her hard work to make this thing happen. I know, Dawn, if you're around, if you're somewhere, or if you're just drinking yourself into an early grave after this one. But this whole thing has been a tremendous effort. I know that she'd been working 14 consecutive 80-hour weeks to get to this point with this conference today. And I do want to be very clear. If there was something that you liked about this conference, it was definitely Dawn. Okay? She's the one who's responsible for it. Yeah. If there was something you did not like about this conference, it was probably me.
I was going to say keep it to yourself.
Or maybe John, but probably me.
It definitely wasn't me.
Mostly it's because people don't listen to Dawn that things go wrong. But I did want to be very clear. We owe a great debt of gratitude to Dawn. We are, if you see her around, thank her in some, respectful way, obviously. She's a celebrity, so don't get too close. But you buy her a drink, let her know what you liked. Tell her gently if there were things that I did wrong, appreciate it. Dawn, do you want to say anything?
No, I don't, but you can apologize for
Oh, I see. Yeah, apology. Don wanted to make an apology for no gluten-free pizza. That was my fault. I apologize. Okay, so thank you, everyone. Oh, I can't be on a team. I'm not allowed to be on a team.
Yeah,
we're going to get somebody for your team right now.
Chris, I think you're short
Oh, you're
3
on it?
players.
You got it? Okay, cool. Okay.
I don't know. The women are stepping up.
Hey, you're
so-
all short from my perspective.
That is true. I can do this. I can run the team.
You can't run. You're not allowed to do all 6 cups.
Well, where are the rules? Does it say?
I mean,
All the
we have to go
men
print
are
the
still
rule
getting their
book.
shit
But
together. Yeah. You want to introduce your team?
I am so excited about my team. All right, ladies.
Chris, how you still need 3?
We're gonna double up.
Oh, they're gonna double up.
Who needs water?
Right here. We need one right here. Yeah. One more.
I think you can just sequester 3 people.
Who would like to come join Team Balasek? And Budge, the one who's won the most in victory. Ian Zed, we got 2 more.
Call him out.
All right, we got this guy. Now we got. All right, that's 6.
You guys just stole our coach.
Now we got some. Yes.
I'm so angry right now.
This is American grass.
I mean, we need to give Hiram credit for what is amazing.
Do we get to introduce our teams? Okay. All right. I'm gonna take 2 seconds to tell you about my team. We are Flip Team 6. But what I'm super, super excited about is, apart from myself, they are all first-time attendees of Summercon. And obviously are all of the female persuasion, which we're moving up in the world. And only 2 of us have ever played Flip Cup before. And our coach abandoned us. He's on the other team.
Well, screw them. I'm here. Did
Wait. So, no, yeah, good guy. You saying good guy, great. I'll first acknowledge we are gender handicapped on this side. And then the second part is we got the coach for the strategy. And then Chris Valacek is our coach. All right, may the best person, which is going to be a woman, win. It's a good thing.
Yeah. You don't need it, girls.
All right.
Question to the video team. You guys go? Go. Okay, go video.
Olivia's the anchor.
All right.
Are you ready?
I can do the countdown.
Do it.
Okay, sure. Okay, so hang on.
We have to hear the countdown.
So it's gonna be 5, 4, 3, 2, 1.
No.
Do you have enough people?
You flip it.
3, 4, 5. Oh, fuck, you do need more. All right.
That's terrible. That is 8. How about 3, 2, 1, go.
This is international Flip Cup rules. Thank you, everyone.
Okay.
All right.
On your mark.
That's
5,
not a countdown. Okay.
4, 3, 2, 1. Ready, set, go.
And we have, with that precision.
Yeah.
First timer. Oh, yeah. Come on, Flip Cup 6. Nope. Whoa. Yeah, okay.
Ian, you're fucking this up.
Chuck it.
We're back, boys.
Don't let them win.
Came out of the audience. Ready to go. Let's go, Bob.
wrong way.
Come on, Heidi. No, all the way down. You got it. Almost there. Yes, all of you. Chug. Jesus shit. You got this.
No.
Take a breath.
Oh, Mudge, do it.
Take a breath.
Come on, Mudge.
Milliseconds difference.
That was a photo finish.
What a barn burner.
All right.
Excellent game.
That is a wrap on the day's program. We're now going to take a brief break, and we're going to get ready for the Matrix.
We're going to drink. We're going to do the Matrix entirely from memory. We're going to have people who are vaguely familiar with it act it out in front of us, and it's going to be hilarious and even probably better with a drink or other substance.
They want to run it back. They want to run it back. You want to run it back? I'll run it back.
Oh, I know you will.
Thank you all for coming, and that's next.
Table, flip cups, and drink.
We have.
First ever.
Yeah, no, you definitely won. They want to do a reverse, like back to the.
I'll never get it.
They want to look at. They want another match. Who wants another match?
Do we need more beer?
Here we go. Please reset.
Do we need more beer, Mark? No?
So I went to Holy Trinity Church as a kid, and Father Ed Teich was a nice man. Spent a lot of time there as an altar boy until I was 16. And
that story stops right there because we're getting ready for Flip Cup. Okay, good stuff.
I was debating between that and. I went with the priest. That's on me. I did that.
Is everybody ready? Are we in it? Okay. Here we go.
Are
Are you ready? Running it back. Video booth. Hang on. Wait. Video booth ready? Video booth is go. On your mark. 5, 4, 3, 2, 1. Ready, set, go.
We take a 5-second penalty. Come on, boys. Remember the elbow, Jesse. Let's go. We still have a 5-second penalty. You got it. That. You got it. Come on, hold on.
Charlie!
You got it.
Oh, you're Chris, not Charlie. Fuck.
3, 2, 1. The Canadian! The Canadian! Give him some!
I think. Yeah, I think.
I called it, I backed out, I gave a 5-second penalty, and they beat it. They got it out in 1 second.
Okay, so that is 1-1. Do we have to do another round?
That's best out of 3,
The
not
rubber
best of 2. Rubber band man, why does it tell?
Okay.
In the first ever Summercon rubber band match.
I can't believe we're doing this 3 times now.
I just want to go home.
This is the greatest, dumbest tradition imaginable.
I just want to go home.
Okay, so
No 5-second bullshit.
Right.
there will be no handoffs for 5 seconds ever again. That is being struck from the rules. You cannot hand off for a time penalty ever again.
Jags. You're subbing in for Mudge. Mudge, Jags is going to sub in for you.
Let me know when we're set, and we'll make this happen.
Now we don't know what the fuck's going to happen.
Yeah, I see. Yeah. We're going south to north. Yeah, or north to south, whatever the case may be. Yeah.
So which side are we start? We're starting on this side again.
Okay.
Point where are we starting now?
You and your sportsmanship.
Yeah, great. Okay, on your mark.
Which side are we starting on?
Starting from that side.
I'm on my mark.
Yes. No, you're not. Not yet, you aren't. Okay. On your mark. 5, 4, 3, 2, 1. Ready, set, go.
Like there's far too much anticipation in that countdown.
Let's go, boys! Let's go! Oh, wow! Oh, my God. Oh, no, he's back!
What a finish. Ah, man, that was amazing. All right.
The F1 officials will be.
Well, sometimes you're bringing a DH, and that's what happens. Congratulations to Team Valasek, and we're delighted to see this kind of sportsmanship. It is an amazing day for this sport.
And yet, the winners will now enslave the losers.
Nice. So, Ian, did you want to
no,
say a
that's a
few
different
words?
game.
I understand you are
That's a different
5 times undefeated in this. Would you like to say a few words to the audience?
A few words. What did you mean? Oh, sorry. I don't have anything. But any challengers, let me know. I'll fuck you up.
What's your favorite conspiracy theory?
My favorite conspiracy theory is that JFK's head just did that.
My favorite conspiracy theory, if anyone
One of the
actually-
things I took away from the conspiracy theories talk is that it's really hard to wind back a conspiracy theory, which is why I am definitely not implying in any way, shape, or form that Donald Trump is a lizard person. But he should show the birth certificate, you know what I'm saying? Like, that would really help, you know?
Yeah.
Like,
We actually have not seen Donald Trump's birth certificate.
Yeah, so, like,
it's a
I
good
don't
point.
know.
My favorite conspiracy theory is about Taylor Swift. Find me.
What is it?
Oh,
No, she can't say it. That's a powerful
I
person.
can, but we might want to cut the feed.
Yeah.
No, I do have a theory.
Yes. Yes.
It is spicy. Okay, whatever. I'm happy to deep dive into lyrics.
Don't do it.
about-
Don't
you
do
know
it.
what?
Don't do it. Don't do it. Don't be goaded into ending your life here before our eyes.
She is very powerful, but
You're a fan. You're a fan.
I am a big fan.
You're a fan.
Big fan. genuinely actually a big fan, which is why I know that this is true, because she told us.
I mean, you remember Christine's Summercon talk
Oh,
about
Christine
the
knows
Ticketmaster
this theory.
scandal. Yeah, remember this? Yeah, that was a
We
very
go-
good talk.
Sorry, we go deep.
And where is Christine now?
I don't know. You do? Oh, you ever find my? Oh, yeah, all right. Feds,
She
am I
knows.
right?
I ain't got to tell her. I think she knows.
Yeah.
And on that note, if anyone even got that reference,
What's your conspiracy?
we
Do it.
should get off the stage, but it is that Taylor Swift is bisexual because I want that to be true.
I hear that. I
Right?
hear
No,
that for
okay.
you. I hear that for you.
I have a lot of. Yeah. It's not June,
John, I'll tell you what that means later.
but it is blue and then purple, pink skies.
Bisexual, yeah.
Anyway, I am happy to deep dive into those conversations at the bar where we drink and tip our bartenders.
Definitely tip our bartenders. I have one final announcement that is not really that interesting, but the owner of a very distinctive bicycle and backpack over at Ornate Studios, please pick up your stuff or Ornate is going to own it forever. Thank you. Anyway, back to the important stuff.
Taylor
Yes,
Swift.
tip your bartender. Please join us for the Matrix. Costumes, prizes, probably trivia, maybe conspiracy theories about our work
Lord and
as
Savior Taylor
human batteries. And, I really am a big fan of the computer. Thank you, everyone.
Happy Summercon.